Good morning, students. Before starting the class, all of you must log in with the name of your section and then the name. Don't use any bracket or full stop, comma. Okay. If you are a 2A1 student, just write 2A1 and then space and your name. Okay. And yes, in fact, for 2N students, special instruction has been given and they are following it. And I want each one of 2N students to follow the instruction that we have given, okay, so that we can get your attendance correctly. Even when you log out and log in, use the same pattern. Okay, ನೀವೇನಾದ್ರು ಬೇರೆ ಪ್ಯಾಟರ್ನ್ ಅಲ್ಲಿ ಮಾಡ್ತು ಅಂದ್ರೆ ಸಪರೇಟ್ ಇದಾಗಿ ಬರುತ್ತೆ. ನಾವು ಅಡಾಪ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋದಲ್ಲ ಇದ್ರೆ ನಿಮಗೆ ಅಟೆಂಡೆನ್ಸ್ ಲಾಸ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಪ್ರತಿ ಸಲ ಇದು ಮಾಡುವಾಗಲೂ ಕೂಡ ಒಂದೇ ಪ್ಯಾಟರ್ನ್ ಅಲ್ಲಿ ಲಾಗಿನ್ ಆದಾಗ ಮೇಂಟೈನ್ ಮಾಡಿ ಅಷ್ಟೇ. That is the thing. Okay. In fact, in the last class, I discussed about basic properties of charges, and in fact, had given even a brief introduction to Newton's law of gravitation. Because I will be discussing Coulomb's law, the ideas will be very similar. Okay, that's why in the last class I mentioned some ideas related to gravitation, Newton's law of gravitation, which I have already studied in first PUC. And in fact, today morning I had sent 2 videos. If you have already watched them, no problem. Otherwise, whenever you are free, you just watch those videos. Definitely they help you in understanding the concepts better. Okay, in fact, after 2:30 today also I will be sending some videos, just short videos, 5 or 10 minutes videos. Okay, basically they help in knowing physics better. Okay, that is the thing. Okay, in fact, I have to discuss Coulomb's law. And another important thing is, if you are facing some problem related to online classes, you have to inform it to your class teacher or principal. Sometimes what happens is you will not be knowing that. Okay, ಈಗ ನಾನೇನೋ ಬರ್ದಿದ್ದೀನಿ ಸರಿಯಾಗಿ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಅದನ್ನ ನನಗೆ ಕಳಿಸ್ಬೋದು, ಸರ್ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ, ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಈ ತರ ಇದು ಮಾಡಿ ಸರ್. ಓಕೆ, ಇದು ಇರಬೇಕು. ನೀವು ಸುಮ್ಮನೆ ಇದ್ಬಿಟ್ರೆ ಆ ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದು ನಮಗೆ ಗೊತ್ತಾದ್ರೆ ತಾನೆ ಅದು ಸೊಲ್ಯೂಷನ್ ಹುಡುಕೋದು ಅಥವಾ ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡಕ್ ಆಗೋದು. ಹಾಗಾಗಿ ಏನಾದ್ರು ಪ್ರಾಬ್ಲಮ್ಸ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಅದನ್ನ ಇನ್ಫಾರ್ಮ್ ಮಾಡಿ. ಓಕೆ, ನೀವೇ ಇನ್ಫಾರ್ಮ್ ಮಾಡ್ಬೋದು, ಟೀಚರ್ಸ್ಗೆ ಕಳಿಸಿ ಅಥವಾ ಪೇರೆಂಟ್ಸ್ ಕಡೆಯಿಂದ ಇನ್ಫಾರ್ಮ್ ಮಾಡಿಸಿ. ಡೆಫಿನೆಟ್ಲಿ the things will be set right. Okay, right. Before starting the actual discussion of Coulomb's law, okay, I'll just give a brief idea how actually he formulated this law. And in fact, in order to understand it, already I mentioned about charging by conduction, and in fact I had given some different illustrations also. But the thing is, usually in the beginning for carrying out experiments related to charges, basically they were using spherical systems, because already I have given the idea. Spherical system or spherical conductors are the one having uniform surface, having same curvature throughout, and thereby whatever charge that we give distributes itself uniformly all over the surface. Okay, this is the advantage of spherical system. Okay, and that's why they were utilizing it. And in fact, whenever you consider a spherical conductor, and if you have given some q coulomb of charge to this one, say if it is spherical conductor A, and it has been given some charge q, I don't know the magnitude, just I am mentioning it is q. I am having another identical spherical conductor, and I'll say it as B. I'll name this one as B. Now what I do is, this is carrying charge, this is not at all having any charge. This is uncharged spherical conductor. Now I'll bring these two together That means I will bring A in contact with B. This is having Q and this is having zero charge. But once I bring these two into contact, immediately charges present on this one start moving on to this one. And in fact, I am considering two identical conductors because by choosing two identical conductors, I am having one important advantage. Once we consider this Q and this one as 0, therefore initial net charge, if we consider, it is, okay, I will write this as Q1 plus Q2, okay, net charge. But in this case, the first one is having charge Q and second one is not at all having any charge. This is by the idea of charges are additive. Okay, already you know charges can be added like numbers. Okay, that's why Q plus 0 is the net initial charge present on the system. Now I am considering this as a system. But because of, as these two conductors are in contact, redistribution of charge or this distribution of charge takes place and these two are identical. That's why whatever net charge that is there on this system, okay, containing two identical spherical conductors placed in contact, okay, once we separate them, the charges that will be present on each, okay, if we consider, that is, I'll write Q1 dash, and in fact, it will be equal to Q2 dash, because whatever net charge that the system was possessing before the contact, okay, basically gets distributed equally among the two. Okay, net charge gets distributed. Okay, in fact, here the second conductor is having no charge, the first one is only possessing charge Q. Okay, therefore, the new charges that we get on the two conductors, when we separate them, we must allow the two conductors to, or the charges to move from one to the other, and then only we have to separate. And in fact, it takes very small time interval for the process to happen. ಹಾಗಾಗಿ ಇವೆರಡನ್ನ ಈಗ ನಾನು ಸಪರೇಟ್ ಆಗಿ ತಗೊಂಡಾದ್ಮೇಲೆ on this one a new charge will be there. Okay, I call this as Q1 and Q2 is 0. Now it gets a new charge. But this one, if we consider, it will be the net initial charge of the system by 2 because I am bringing two identical spherical conductors into contact. That's why whatever net charge that the system was possessing gets distributed equally on the two spherical conductors. Okay, that means the second conductor, which was not at all carrying any charge, because of the contact, now it also gets the charge, which will be same as the new charge that we get on A. And in fact, here this is Q only. Therefore, when some charge is there, say Q, and if this is uncharged, if you bring these two into contact, according to this idea, it is clear half of the charge is transferred onto this one. That means both will be getting same amount of charges. Okay, already I mentioned this idea by considering containers containing liquids. Here I am considering two identical containers. This one is having liquid up to certain height. Now if I interconnect these two, then basically in both half the amount of liquids will be getting. Okay, ಅದರಲ್ಲಿ ಎಷ್ಟಿತ್ತು ಅದು ಅರ್ಧ ಆಗಿ ಡಿವೈಡ್ ಆಗುತ್ತೆ. Okay, this is as long as these two are identical. Okay, therefore when you consider a charged spherical conductor by using uncharged identical spherical conductor, it is possible to share half of the charge to the uncharged. Thereby we will be definitely knowing the magnitude of the charge present on the two after the contact. Okay, now I will consider third spherical conductor, which is also identical. Now if I bring these three into contact, what has to happen? Initially even the third one, that is C, is also having no charge. ಇದಕ್ಕೂ ಚಾರ್ಜ್ ಇಲ್ಲ, ಇದಕ್ಕೂ ಚಾರ್ಜ್ ಇಲ್ಲ, but only this is carrying charge. But you are bringing, I am bringing the three into contact. Once I bring these three into contact, And according to this, basically, even the third one gets a new charge and it will be equal to now 3. It has to divide itself into 3 parts. Okay. Therefore, basically, it becomes q by 3. Okay. This is basically the idea that Coulomb's used for carrying out experiment, and because of the experimental results only he formulated Coulomb's law. Okay, but here I have taken only one having charge and these two having no charge at all. Now what I do is I'll consider Q on this one also. Even this is also having the same charge as this. Okay, idraste charge ide anta ankolana. Now when we consider these two together, now Q, okay, therefore what actually happens? 2Q by 3. Therefore, if you know the charge on one, by bringing uncharged spherical conductors, we can divide the charge present on the one onto the other uncharged spheres, so that they possess same amount of charges. And if two are possessing some charge and the third one is uncharged, again whatever charges that these two are carrying gets divided into 3 equal parts. So this is the basic idea related, and in fact here we are using charging by conduction. We are using the idea of charges are additive, and once you consider here the total charge even after the redistribution remains the same. Therefore, even the conservation law is also followed. Okay, some conservation law no kuda. Yes, volume kadme ideppa. Hello. Now is it okay? Okay, right. That is the thing. ಯಾಕೆಂದ್ರೆ ನಿಮ್ಗೆ ಏನ್ ಕೇಳಿಸ್ಕೊಳ್ತಾ ಇದ್ದೀರಾ ಅಂತ ನನಗೆ ಕೇಳಿಸ್ತಾ ಇರಲ್ಲ ಅಲ್ವಾ, ಹಾಗಾಗಿ ನಿಮಗೆ ಅಲ್ಲಿ ಹಾಕಿದ ತಕ್ಷಣ ಅಟ್ಲೀಸ್ಟ್ ತಕ್ಷಣ ನೋಡಿಲ್ದಲೇ ಇದ್ರು ಕೂಡ ನೋಡಿದೆ. Right. Okay. Therefore, this is the one that you have to remember. In fact, in competitive examinations, you'll come across problems on this idea. Okay. Therefore, you should be knowing the idea of additive, charges are additive, the conduction, charging by conduction, and also the conservation. And another important thing is, already I mentioned about charging two identical spherical conductors simultaneously by the method of induction. But in that case, already I have given the idea, the two spherical conductors will be hello, is it okay now? ನಿಮ್ಮಲ್ಲಿ ಏನಾದ್ರು ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಅನ್ಕೊಂಡಿದ್ದೀರಾ ನೋಡ್ರಪ್ಪ. ಬೇರೆಯವ್ರಿಗೆಲ್ಲ ಕ್ಲಿಯರ್ ಅಂತ ಹೇಳ್ತಾ ಇದಾರಲ್ಲಪ್ಪ. Maximum volume has been given even in this one also. Okay. ಸುಳ್ಳು ಹೇಳ್ತಾ ಇದೆಯಾ ಅಂತ ಹೇಳ್ತಾ ಇಲ್ಲಪ್ಪ, ಅರದು 2F1. Hello. Right. Therefore, now if we consider just the two, now I'll remove this. Let us say these two have been charged by the method of induction, initially by placing them in contact. Okay, in that case, definitely this will be having minus Q, because both the conductors will be possessing equal amount of charges but of opposite nature. Now if you bring these two into contact, you just observe here, if this is plus Q, now it is minus Q. And if I continue with this one, now this is having charge minus q. Now when I add, the net charge becomes equal to 0. Okay, therefore the charges get neutralized. Okay, that means after the contact, this one also gets the charge, this one also gets, sorry, this one also loses its charge. Okay, that's why after the contact, the two will be in uncharged state. Okay, this is basically the idea that you have to remember. Okay, now after mentioning these, now I'll move on to the actual discussion of Coulomb's law. Here I am considering two charged bodies. One possessing charge Q1, and here is another one, and this is carrying charge Q2. Already you know electrostatic force, whenever we consider, let's say a charged body, it will be in a position to attract light objects. Therefore, in order to understand whether a body is charged or not, basically they were using some light object just to understand it. And in fact, even when you consider gold leaf electroscope, a thin foil of gold leaves will be there. Because of the divergence, they were detecting the charge. But when we consider the interaction that was happening, definitely it was of very small magnitude. Basically, Coulombs try to measure the interaction between the, in fact, he used charged conductors to understand the interaction between the charged particles. Already they were having the idea, bodies having like charges repel, bodies having unlike charges attract. But what amount of interaction will be there? What amount of forces will be there on each? Okay, that is what Coulombs studied by carrying out experiments. In fact, after today's class, I will send a video where actually you will get the clear idea how we formulated Coulomb's law. Okay, I won't be explaining it. Okay, because in fact, according to syllabus, in 8 hours, you have to complete the whole syllabus. Sorry, whole chapter. This chapter, electric charges and fields. In fact, already have taken 4 classes. This is the 5th one. Okay, that's why. And in fact, just because we are doing the classes online, I cannot go fast. Okay, ಇಷ್ಟು ಕೆಲವು ಸಲ ಸ್ಲೋ ಹೋದ್ರೆ ಕೆಲವು ಸಲ ಫಾಲೋ ಮಾಡಿರಲ್ಲ ನೀವು, ಹಾಗಾಗಿ ಫಾಸ್ಟ್ ಆಗಿ ಹೊಟ್ಟೋಗ್ಬಿಟ್ರೆ ಇನ್ನೂ ಕಷ್ಟ. Okay, another important thing is, you will not be knowing whether you have understood the things or not. ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಆಗಿದ್ರೆ ನಿಮ್ಮ ಫೇಸೇ ನಮ್ಗೆ ಇಂಡೆಕ್ಸ್ ಆಗ್ತಾ ಇತ್ತು, ಲಿಟ್ಮಸ್ ಪೇಪರ್ ತರ. ಓಕೆ, ಹಾಗಾಗಿ ಅರ್ಥ ಆಗಿದೆ ಆಲ್ಮೋಸ್ಟ್ ಎಲ್ಲ ಎಲ್ಲರಿಗೂ ಅಂದ್ಕೊಂಡು ಮುಂದೆ ಕೊಟ್ಟೋಗ್ಬಿಡ್ತಾ ಇತ್ತು. ಬಟ್ ಫಸ್ಟ್ ಚಾಪ್ಟರ್ a very important ಚಾಪ್ಟರ್. ಓಕೆ, ಹಾಗಾಗಿ ಎಕ್ಸ್ಟ್ರಾ ಕ್ಲಾಸಸ್ ಅಕಸ್ಮಾತ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅದಕ್ಕೆ ಬೇಕಾಯ್ತು ಅಂತಂದ್ರೆ ಬೇರೆ ಇದನ್ನ ಕಳಿಸುತ್ತೆ, ತೊಂದರೆ ಇಲ್ಲ. ಬಟ್ ಡೆಫಿನೆಟ್ಲಿ ಇನ್ ನೆಕ್ಸ್ಟ್ ಆಫ್ಟರ್ 1 or 2 weeks you have to increase the speed. ಅದು ಮಾಡಬೇಕಾಗತ್ತೆ, ವಿಧಿ ಇಲ್ಲ. ಓಕೆ, ಯಾಕೆಂದ್ರೆ ಆಲ್ರೆಡಿ ಯು ಹ್ಯಾವ್ ಬಿನ್ ಗಿವನ್ ದ ಐಡಿಯಾ, ಸೆಪ್ಟೆಂಬರ್ ಟೆಸ್ಟ್ ವಿಲ್ ಬಿ ದೇರ್. ಓಕೆ, ಹಾಗಾಗಿ ಅದಕ್ಕೆ ಏನಾದ್ರು ಅವರು ಪ್ರಿಸೈಸ್ ಆಗಿ ಚಾಪ್ಟರ್ಸ್ ನ ಫಿಕ್ಸ್ ಮಾಡಿದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಕಂಪ್ಲೀಟ್ ಇಟ್. ಓಕೆ, ಹಾಗಾಗಿ ಸ್ವಲ್ಪ ನೀವು ಕೂಡ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಫಾಲೋ ಮಾಡೋಕ್ಕಾಗಲಿಲ್ಲ ಅಂತಂದ್ರೆ ತಿರ್ಗಾ ಅದನ್ನ ಅನಲೈಸ್ ನೋಡ್ಕೊಂಡು ಮಾಡಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ರೈಟ್. ಹಿಯರ್ ಐ ಆಮ್ ಕನ್ಸಿಡರಿಂಗ್ 2 spherical conductors carrying charges Q1 and Q2. For convenience, I'll consider this one to be positive charge 1, this one also to be positive charge. But here another important point you have to remember. Here I am considering 2 charged bodies, right? Spherical conductor for convenience. Definitely when you consider these bodies, they are having their own dimensions. Size ಇದೆ ಅದಕ್ಕೆ ಎರಡಕ್ಕೂ ಕೂಡ. But whenever we consider the distance of separation between these two is large compared to the dimensions of the charged bodies that we are, or particles that we are considering, then we can consider the bodies as point charges. Therefore, already in fact, if you have gone through the first year textbook, then you will be knowing whenever I consider a body, under motion. If it is moving through distances which are very large compared to its dimension, we consider the body as a point mass. In the same way, we are considering charged particles or bodies. Okay, whenever the size of the bodies or the particles is small compared to the distance of separation that we are considering between them, then those particles or the bodies can be considered as point charges. Okay, point charges, we can always consider them as point charges. Therefore, when you consider this Q1 and Q2, basically if this distance is large compared to the dimensions, you can consider these two as point charges. Therefore, first of all, you should be knowing the idea of point charges. In fact, when you consider Coulomb's law, it is applicable for point charges. You have to consider the charged bodies whose sizes are very small compared to the distance of separation. Okay, that is the thing. And here, the two have been separated. Okay, I'll just represent this as R. R is the symbol that I am using to represent the separation between the two two charged conductors or the charged particles. Now they are point charges because I am considering R to be large compared to the dimensions of this. And in fact, here R is the distance between the centers of these two charged particles, which are spherical in nature. And according to Coulomb, whenever we consider this one, both are positive already, you know. That's why this one will be exerting repulsive force on this. Similarly, this one will also be exerting the repulsive force on this. Basically, Coulomb was trying to measure the magnitude of this force only. Okay, and let us consider the force of repulsion here, or the force exerted by the first on the second to be F. Already you have the idea of Newton's third law. For every action, there will be an equal and opposite reaction. Therefore, if the first charged particle is exerting a force F on the second, placed at a distance R from it, similarly, the second also exerts same amount of force on this one also. That means these two charged particles carrying charges plus Q1 and plus Q2 separated by distance R, okay, basically experience some electrostatic force of repulsion. If I take this one as negative, automatically the force becomes attractive. Okay, but here, whether it is force of attraction or force of repulsion, the electrostatic force that will be there between any two charged particles separated by certain distance, when you consider, according to Coulomb's law, the force will be directly proportional to the product of the magnitude of the charges. Okay, we have to just consider the magnitude of the charges. Okay, it will be proportional to the product of the magnitudes of the charges. Okay, that is mod of Q1 into Q2. Okay, therefore F will be proportional to the product of the magnitude of the two charges. Okay, very word is important. Okay, this is the first idea we got by carrying out the experiment. The next idea was the force of interaction between the two charged particles. Okay, basically was directly proportional to the product of the magnitudes of the charges, and also it was inversely proportional to square of the distance of separation. Okay, F proportional to 1 over R square, that is inversely proportional to square of the distance. Okay, if you just observe this, it is clear for you now. It is very similar to Newton's law of gravitation. Newton's law of gravitation says the force of gravitational force between any two bodies will be directly proportional to the product of the mass. In fact, mass is always positive, no question of negative mass. But here we'll be coming across positive charges, negative charges, okay, like charges, unlike charges. That's why force proportional to the product of the magnitude of the charges. Okay, you should not just write product of the charges. It has to be product of the magnitudes of the charges and inversely proportional to square of the distance. Okay, not only this, he also introduced a very, very important idea. Whenever we consider the interaction between the charged particles, the interaction was basically along the line joining the two particles, that is centers of the two particles. It was acting along the center, like in joining the two centers, whether it is attractive force or repulsive force. Okay, basically the interaction will be there along this line. Okay, therefore, Coulomb's law states the electrostatic force of attraction or repulsion between any two charged particles will be directly proportional to the product of the magnitudes of the charges and inversely proportional to square of the distance. And if can always introduce the word the point charges. Okay, therefore the force of interaction, the force of repulsion or attraction that will be there between two point charges will be directly proportional to the product of the magnitudes of the charges and inversely proportional to square of the distance between them. Okay, this is the and in fact the force will be acting along the line joining the centers of the two particles or the bodies. Okay, this is the complete statement of Coulomb's law. That is electrostatic force of attraction or repulsion between any two point charges will be directly proportional to the product of the magnitudes of the charges and inversely proportional to square of the distance between them. Now, let us combine these two ideas. Once we combine these two ideas, we get F proportional to mod of Q1, Q2 divided by R square. Okay. Here, we are having proportionality symbol. If you want to convert this one into an equation, okay, then automatically we have to use some constant of proportionality, right? Therefore, F is equal to a constant K mod Q1 Q2 by R square. Okay, this is the equation that we get from the idea of Coulomb's law. Coulomb's law states the electrostatic force of attraction or repulsion between any two point charges is directly proportional to the product of the magnitudes of the charges and inversely proportional to square of the distance. That's why F will be equal to K, a constant of proportionality, Q1, Q2 by R square. Okay, this is basically the one. But here, the very, very important idea is what is actually this one? What is the value of K? Okay, once we consider that K, proportionality constant that we are using here, basically depends on two important factors. In fact, in the last class, while introducing the Newton's law of gravitation, I mentioned that the gravitational constant depends only on one factor, that is system of units. Okay, G, capital G depends only on the system of units. But here, similar to Newton's law of gravitation, here also we are getting a constant of proportionality. But the difference is this constant of proportionality that we are using in Coulomb's law will be depending on two factors, not one. Okay, the first one is similar to gravitation. Here also it will be depending on the system of units. That means whether we are using SI system for measuring the charge or the distance, or basically decides it. Another factor is, initially let us consider these two charged particles in air or vacuum. Initially I am considering these two charges in air and or vacuum. And I will measure the interaction between the two. And I will consider the force as F air or F vacuum, depending on the one. Afterwards, I will remove this air and I will place these two charged particles in some other medium, say water. Initially, I placed the two charged particles in air or vacuum and I calculated the force. But now I am introducing water in between the two. And when I measure the force, okay, basically the magnitude I am representing as F in water, but F in air will not be equal to F in water. Therefore, now you are having another idea. The force of interaction between the two charged particles depends on the medium present between the two. Definitely, this idea was not there in gravitation. In fact, gravitational force is independent of the presence of any medium in between the two or the presence of the third object or the third body. Okay, therefore, not only the proportion here, the force depends on, or in fact depends on the medium in which we are carrying out the experiment. If we change the medium in which we are carrying out the experiment, automatically the interaction between the two charged particles will be different. Okay, that's why when you consider the proportional, in fact, definitely Coulomb did not study these things. He just formulated it. Afterwards, the idea was developed. Okay, in fact, scientists were able to measure the forces correctly, and then only they modified it. Now we are having this one, the constant K, and this constant K depends on the system of unit. And the next one is the medium, that is nature of the medium. Therefore, it is possible to change the interaction between any two charged particles by changing their magnitudes of the charges, by changing the distance of separation, and also by changing the medium, okay, present in between the two. Okay, therefore, we are having the option of decreasing the interaction between the two charged particles by making use of some particular medium. In fact, when I say it depends on medium, definitely in different media, the forces will be different. Therefore, if you want less, we can use a particular medium. If you want more interaction, we can go for a particular medium. That's why when we consider this electrostatic force, okay, it is possible to shield or change. Okay, completely we can avoid it also. How it happens afterwards, I'll be discussing. But it is possible to change the force that is there between the two charged particles by changing the medium present in between the two, but it is not possible for us to avoid the gravitational force. Okay, now hope Patadalo Kutkondru Kuda, definitely gravitational force will be there. Only if you reach the center of the earth, the gravitational force on us becomes zero. Okay, that is the thing. But it is possible to change the electrostatic force of interaction between the two charged particles by considering a particular medium or changing the medium. Okay, these are the ideas that you should be knowing related to Coulomb's law. I'll repeat the statement before moving on to the next idea. Coulomb's law states the electrostatic force of attraction or repulsion between any 2 point charges is directly proportional to the product of the magnitudes of the charges and inversely proportional to square of the distance between them. And the force acts along the line joining the two charges or the particles. Okay, that is joining the centers of the two particles. Okay, this is a statement. It's very, very important one. Usually you'll come across a question related to this. And if you are asked to explain it, then you have to mention, or you have to draw the diagram, you have to mention this, and you have to write this one. But this K depends on the system of units and depends on the nature of the medium. Already just to introduce that the force depends on the medium, I have given some introduction, the illustration. In air or vacuum, some force will be there. If it is placed in water, it will be different. Okay. In fact, whenever we consider this K, if we consider, if we are using SI system and air or vacuum as the medium, if you are taking SI system and if you are placing the two charges in air or vacuum, then this K is given by 1 over 4 pi epsilon naught. Epsilon naught. 1 over 4 pi epsilon naught. And this epsilon naught is considered as the permittivity of air or vacuum. This is known as permittivity. Permittivity, okay. In fact, here also they will be using permittivity of air or vacuum, 1 over 4 pi epsilon naught. This is the value of K, the proportionality constant, which is depending on the system of unit, depending on the nature. In fact, already I have given the idea. And only because of SA system that we are having, this factor comes into picture. Okay, this 4 pi is because of the system, and this one is deciding the nature of the medium that we are considering. Therefore, K is depending on the system of unit and the medium. That's why force not only depends on these two, but also it depends on the system of units and also the nature of the medium. As long as we are using air or vacuum and SI system, the value of K is given by 1 over 4 pi epsilon naught. Epsilon naught is known as permittivity of air or vacuum. Okay, this is the thing, permittivity of air or vacuum. And if you are using SI system only and other media, okay, ಬೇರೆ ಯಾವ್ದಾದ್ರು ಮೀಡಿಯಂಗಳು ತಗೊಂಡಿದ್ದೀವಿ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. When you are using any other media, this K will be equal to 1 over 4 pi epsilon. It is also equal to 1 over 4 pi epsilon naught into epsilon r. Okay, epsilon r. Okay, I will mention what actually these two. In fact, epsilon, when you consider, it is known as permittivity of the medium, and epsilon r is known as relative permittivity. Relative permittivity of the medium. This is permittivity of the medium. Epsilon r is known as relative permittivity of the medium. Epsilon naught is known as permittivity of air or vacuum. That's why you can easily understand that once we go for air or vacuum, because here we are just saying permittivity of the medium. If the medium is air or vacuum, this value becomes equal to 1. That's why epsilon r, sorry, K value is just 1 over 4 pi epsilon r. Therefore, you should also remember this epsilon r is equal to 1 for air or vacuum. That's why the value of K is simply 1 over 4 pi epsilon naught for air or vacuum. For other media, it is 1 over 4 pi epsilon naught into epsilon r. It is relative permittivity. Okay, permittivity. Here it is permittivity of air or vacuum. This is relative permittivity. Okay, therefore, when you multiply these two, you'll be getting epsilon, which is nothing but the permittivity of the medium. Okay, this is about the constant of proportionality that will be coming across in Coulomb's law. It depends on the system of units, it depends on the nature of the medium. For SI system, for air or vacuum, its value is 1 over 4 pi epsilon naught, and for other media, it is simply 1 over 4 pi epsilon or 1 over 4 pi epsilon naught into epsilon r. Already have given the names, and this point also is important. Epsilon r will be 1 for air or vacuum, because when I say relative, it is with respect to air or vacuum only we will be considering. Afterwards, I'll give the definition also. Sorry, I'll give the definition of permittivity, relative permittivity. Okay, then you will be understanding it better. But now, for the moment, you just remember this is basically the considering permittivity with respect to air or vacuum. When you are considering air or vacuum itself as the medium, automatically this value becomes equal to 1. It is similar to, that is, relative density. Okay, whenever you consider relative density of an object, we'll be comparing the density of the given object with the density of water. Okay, ಹಾಗಾಗಿ ವಾಟರ್ನೇ ತಗೊಳ್ತು ಅಂತಂದ್ರೆ ಅದರ ಫ್ಯಾಕ್ಟರ್ 1 ಆಗುತ್ತೆ, ಬೇರೆ ತಗೊಳ್ತು ಅಂತಂದ್ರೆ ಬೇರೆ ಬರುತ್ತೆ. Okay, similar to that, we are getting the permittivity. Okay, I will explain what is actually permittivity. Okay, in fact, in the textbook they have not given the definition. Okay, permittivity, what is actually permittivity? It is a character, a property associated with the medium okay, and which helps in deciding the interaction between the two charged particle placed in that medium. A medium ಅಲ್ಲಿ ಇಟ್ಟರೆ ಎಷ್ಟು interaction ಸಾಧ್ಯ, that idea we can easily get by the idea of permittivity. Okay, this is the thing. Now let us observe here, k is equal to 1 over 4 pi epsilon is there. Okay, now let us assume epsilon, if it increases, ಯಾವುದೋ ಒಂದು ಮೀಡಿಯಂ ತಗೊಂಡಿದ್ರಿ ಮುಂಚೆ, ಇನ್ನೊಂದು ಮೀಡಿಯಂ ಹೋಗಿದ್ದೀರಾ, ಅದರ ಎಫ್ಸಲಾನ್ ಜಾಸ್ತಿ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ಎಫ್ಸಲಾನ್ ಜಾಸ್ತಿ ಆಯಿತು ಅಂತ ತಕ್ಷಣನೇ ಈ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ, ಎಫ್ಸಲಾನ್ is in the denominator. Then the permittivity of the medium increases, 1 over 4 pi epsilon decreases. That means k decreases. ಹಾಗಾದ್ರೆ epsilon, that is permittivity of the medium, increases, the proportionality constant value decreases. Once the proportionality constant value decreases, for the given magnitudes of the charges and given separation, what has to happen to the force? Okay, force ಏನಾಗಬೇಕು? Okay, already Aditya Kashyap, good. It decreases, right? Once epsilon increases, as it is in the denominator, 1 over 4 pi epsilon what value decreases. That's why k decreases, and thereby force between the charged particles decreases. Similarly, if epsilon decreases, ಕಮ್ಮಿ ಆಯಿತು ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ, then immediately this factor value increases. That means k increases. ಹಾಗಾದ್ರೆ epsilon ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇದ್ರೆ k ವ್ಯಾಲ್ಯೂ ಕಮ್ಮಿ ಆಗುತ್ತೆ, ಎಪ್ಸಲಾನ್ ಕಮ್ಮಿ ಇದ್ರೆ k ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ ಎಪ್ಸಲಾನ್ ವ್ಯತ್ಯಾಸ ಆದಂಗಾದಾಗೆ k ವ್ಯತ್ಯಾಸ ಆಗಿ ಫೋರ್ಸು ಕೂಡ ವ್ಯತ್ಯಾಸ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Therefore, you can consider permittivity as that physical quantity, okay, which will be deciding the interaction between the two charged particles placed in that particular medium. Okay, ಎಷ್ಟು interaction ಇರುತ್ತೆ ಅನ್ನೋದನ್ನ ಹೇಳ್ತಾ ಹೋಗುತ್ತೆ. In fact, this permittivity will be measuring the reciprocal of the easiness with which the charges are allowed to interact with each other. Okay, I'll repeat, permittivity measures, or it will be equal to the reciprocal of the easiness. That means how easily the charged particles can interact with each other. Whenever the medium is allowing the charges to interact, then automatically, okay, there will be variation in the value of k, and therefore force also changes. ಈಗ ಎರಡು ಚಾರ್ಜ್ಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ನ ತಗೊಂಡಿದ್ದೀವಿ ಒಂದು ಮೀಡಿಯಂ ಅಲ್ಲಿ, ಆ ಮೀಡಿಯಂ ಅವೆರಡನ್ನು ಕೂಡ ಜಾಸ್ತಿ ಇಂಟ್ರಾಕ್ಟ್ ಆಗೋದ್ ಬಿಟ್ರೆ ಫೋರ್ಸ್ ಅವೆರಡರ ಮಧ್ಯೆ ಏನಾಗಿರುತ್ತೆ, ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಆ ಮೀಡಿಯಂ ಅವುಗಳ ಇಂಟ್ರಾಕ್ಷನ್ ಅವಾಯ್ಡ್ ಮಾಡಿಸ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಚಾರ್ಜಸ್ ವಿಲ್ ಬಿ ಲೆಸ್. ದಟ್ಸ್ ವೈ when you consider the meaning of the term permittivity, or if you want to measure it, ಚಾರ್ಜಸ್ ಟು ಇಂಟ್ರಾಕ್ಟ್, ಯಾವ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಚಾರ್ಜಸ್ ತುಂಬಾ ಇಂಟ್ರಾಕ್ಟ್ ಆಗಕ್ಕೆ ಸಾಧ್ಯ ಇದೆಯೋ ಅಲ್ಲಿ ಫೋರ್ಸು ರೆಸಿಪ್ರೋಕಲ್ ಆಫ್ ಈಸ್ನೆಸ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಎಪ್ಸಲಾನ್, ಓಕೆ, is equal to the reciprocal of the ease with which the charges interact. Nodi, when I consider this, if a medium allows the charges to interact to a greater extent, idu value ಜಾಸ್ತಿ ಆಯಿತು, ಎಪ್ಸಲಾನ್ ವ್ಯಾಲ್ಯೂ ಕಮ್ಮಿ. ಎಪ್ಸಲಾನ್ ವ್ಯಾಲ್ಯೂ ಕಮ್ಮಿ ಆದ ತಕ್ಷಣ ಕೆ ಜಾಸ್ತಿ, ಕೆ ಜಾಸ್ತಿ ಆದ ತಕ್ಷಣ ಫೋರ್ಸು ಜಾಸ್ತಿ. ಹಾಗಾದ್ರೆ ಯಾವ ಮೀಡಿಯಮ್ಮು ಚಾರ್ಜಸ್ ನ ಇಂಟ್ರಾಕ್ಟ್ ಆಗಕ್ಕೆ ಬಿಡುತ್ತೋ ಈಸಿಯಾಗಿ, ಅವುಗಳಿಗೆ ಎಪ್ಸಲಾನ್ ವ್ಯಾಲ್ಯೂ ಓಕೆ ಕಮ್ಮಿ ಇರುತ್ತೆ. ಯಾವ ಮೀಡಿಯಮ್ಮು ಚಾರ್ಜಸ್ ನ ಜಾಸ್ತಿ ಇಂಟ್ರಾಕ್ಟ್ ಆಗಕ್ಕೆ ಬಿಡುತ್ತೋ ಆ ಮೀಡಿಯಮ್ದು ಎಪ್ಸಲಾನ್ ವ್ಯಾಲ್ಯೂ ಕಮ್ಮಿ. ಅದಕ್ಕೆ ಡಿನಾಮಿನೇಟರ್ ಬಂದು ಕೂತಿದೆ ಅದು. ಇದು ಜಾಸ್ತಿ ಆದಂಗೆ ಎಫ್ ಜಾಸ್ತಿ ಆಗೋದಾಗಿದ್ದಿದ್ರೆ ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ ಇರ್ತಿತ್ತು, ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಲ್ಲಿ ಅದು ಬರುತ್ತೆ, ಅದನ್ನ ಆಮೇಲೆ ನೋಡೋಣ. ಓಕೆ, ಈಗ ಸದ್ಯಕ್ಕೆ when you consider permittivity, it is defined as the reciprocal of the easiness with which the charges are allowed to interact with each other. If a medium is not at all allowing the charges to interact ಬಿಡ್ತಾ ಇಲ್ಲ ಅಂತ ನೋಡೋಣ, ಐಸೋಲೇಟ್ ಮಾಡಿಬಿಡ್ತಾ ಇದೆ ಚಾರ್ಜಸ್ನ, ಒಂದಕ್ಕೊಂದು ಯಾವುದೇ ತರ ಫೋರ್ಸಸ್ನ ಅಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಳೋದು ಬಿಡ್ತಿಲ್ಲ ಅನ್ನೋದಾದ್ರೆ ಈಸ್ನೆಸ್ 0 ಆಗೋಯ್ತು. 1/0 ಇನ್ಫಿನಿಟಿ, ಎಫ್ಸಲಾನ್ ಇನ್ಫೈನೈಟ್ ಆದ ತಕ್ಷಣಕ್ಕೆ 0. ಓಕೆ, ಹಾಗಾದ್ರೆ ಯಾವ ಮೀಡಿಯಮ್ಮು ಚಾರ್ಜಸ್ನ ಇಂಟ್ರಾಕ್ಟ್ ಆಗಿ ಬಿಡಲ್ವೋ ಅದ್ರದ್ದು ಎಫ್ಸಲಾನ್ ವ್ಯಾಲ್ಯೂ ಇನ್ಫೈನೈಟ್ ಇರುತ್ತೆ. ಯಾವುದು ತುಂಬಾ ಈಸಿಯಾಗಿ ಅಲೋ ಮಾಡುತ್ತೋ ಅದರ ವ್ಯಾಲ್ಯೂ ಕಮ್ಮಿ ಇರುತ್ತೆ. ಹಾಗಾದ್ರೆ ಎಫ್ಸಲಾನ್ ಕಮ್ಮಿ ಇದ್ರೆ ಅವಾಗ ಇಂಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ. ದಟ್ ಇಸ್ ವಾಟ್ ಐ ಆಮ್ ಎಕ್ಸ್ಪ್ಲೈನಿಂಗ್. ಓಕೆ, ಯಾರು ಧನುಷ್ ಈಗ ನಾವು ಹೇಳಿದ್ನಲ್ಲಪ್ಪ, ಪರ್ಮಿಟಿವಿಟಿ ಈಸ್ ದ ರೆಸಿಪ್ರೋಕಲ್ ಆಫ್ ದ ಈಸ್ ವಿತ್ ವಿಚ್ ದ ಚಾರ್ಜಸ್ ಆರ್ ಅಲೌಡ್ ಟು ಇಂಟ್ರಾಕ್ಟ್. ಎಷ್ಟು ಈಸಿಯಾಗಿ ಒಂದು ಮೀಡಿಯಂ ಚಾರ್ಜಸ್ನ ಅಲೋ ಮಾಡುತ್ತೋ ಇಂಟ್ರಾಕ್ಟ್ ಆಗಕ್ಕೆ ಅದರ ರೆಸಿಪ್ರೋಕಲ್ ವ್ಯಾಲ್ಯೂನೇ ಪರ್ಮಿಟಿವಿಟಿ, ಅಂದ್ರೆ ಪರ್ಮಿಟ್. ಓಕೆ, ಈಸಿಯಾಗಿ ಪರ್ಮಿಟ್ ಮಾಡಿದ್ರೆ ಎಫ್ಸಲಾನ್ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ. ಹಾಗಾಗಿ ಈಸಿಯಾಗಿ ಅಲೋ ಮಾಡ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಈ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಎಫ್ಸಲಾನ್ ಕಮ್ಮಿ ಇರುತ್ತೆ. ಎಫ್ಸಲಾನ್ ಕಮ್ಮಿ ಆದಾಗ ಕೆ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಫೋರ್ಸ್ ಕೂಡ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಇಟ್ ಮೀನ್ಸ್ ದ ಫೋರ್ಸ್ ಆಫ್ ಇಂಟರಾಕ್ಷನ್ ವಿಲ್ ಬಿ ಮೋರ್ if the medium is allowing the charges to interact to greater extent. If the medium is not allowing the charges to interact to greater extent, then K will be less for that one, epsilon will be more for that. That's why interaction automatically becomes less. Okay, this is the thing. Therefore, permittivity it will not be asked in the examination. Okay, that is sure. Permittivity textbook alle kottilla definition, but I have written it. It is the reciprocal of the ease with which the charges are allowed to interact. Okay, by a given medium. ಯಾವ ಮೀಡಿಯಂ ನಾವು ತಗೊಂಡಿರ್ತೀವೋ ಅದು ಎಷ್ಟು ಈಸಿಯಾಗಿ ಅಲೋ ಮಾಡುತ್ತೋ ಅದ್ರ ರೆಸಿಪ್ರೋಕಲ್ ನ ತಗೊಂಡ್ರೆ ಎಫ್ಸಲಾನ್ ವ್ಯಾಲ್ಯೂನ ಕೊಡುತ್ತೆ. ಅದು 1/4 ಎಫ್ಸಲಾನ್ ವ್ಯಾಲ್ಯೂ ತೆಗೆದ್ರೆ ಕೆ ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ. ಅಂಡ್ ದಟ್ ಕೆ ಡಿಸೈಡ್ಸ್ ದಿಸ್ ಎಫ್ ಇನ್ ಅಡಿಷನ್ ಟು ದೀಸ್ ಟು ಫ್ಯಾಕ್ಟರ್ಸ್. ಓಕೆ, ದಿಸ್ ಈಸ್ ಕೂಲಮ್ಸ್ ಲಾ. ಓಕೆ, ಸ್ಟೇಟ್ಮೆಂಟ್, explanation, and the ideas related to proportionality constant. The important difference that we come across here in case of this proportionality constant, okay, compared to the constant of proportionality that we use in Newton's law of gravitation. Newton's law of gravitation, that is gravitation constant, just was depending on system of units. But when you consider this one, it is depending on one more factor, that is nature of the medium. Okay, because of this, okay, definitely there will be different amount of interactions in different media. You may be considering same charged particles, you may be maintaining same distance, but once you change the medium, the interaction changes. But definitely this is not the case with gravitation. As long as you are considering two bodies of certain masses and some separation is there, the value of the force remains constant irrespective of the medium. Okay, ನೀವು ಎಲ್ಲೇ ತಗೊಂಡು ಹೋದ್ರು ಕೂಡ ಅವೆರಡರ ಮಧ್ಯೆ ಇಂಟರಾಕ್ಷನ್ ಅಷ್ಟೇ ಇರುತ್ತೆ. ಥರ್ಡ್ ಒನ್ ಇಲ್ಲಿ ಇಟ್ಟರು ಮಧ್ಯದಲ್ಲಿ ಇವೆರಡರ ಮಧ್ಯೆ ಏನ್ ಫೋರ್ಸ್ ಆಫ್ ಇಂಟರಾಕ್ಷನ್ ಇರುತ್ತೋ ಅದು ಅಷ್ಟೇ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ರಿಸಲ್ಟೆಂಟ್ ಬೇರೆ ಆಗ್ಬೋದು, ಆದ್ರೆ ಇಂಡಿವಿಜುವಲ್ ಪೇರ್ ನ ತಗೊಂಡಾಗ the interaction remains the same, it won't change. Okay, that's why by considering suitable media, it is possible to maintain greater interaction and also lesser interaction between the two charged particles. In fact, you should be knowing, here I have written epsilon r is equal to 1 for air vacuum. But if we consider epsilon r, it will be infinite for conductors. ಕಂಡಕ್ಟರ್ಸ್ಗಳನ್ನ ನಾವು ತಗೊಳ್ತು ಅಂದ್ರೆ ಕಾಪರ್ ಪ್ಲೇಟು, ಮೆಟಾಲಿಕ್ ಐರನ್ ಪ್ಲೇಟು, ಆ ತರ ಕಂಡಕ್ಟರ್ಸ್ಗಳನ್ನ ತಗೊಂಡ್ರೆ ಎಫ್ಸಲಾನ್ ಆರ್ ಫಾರ್ ಸಚ್ ಮೀಡಿಯಾ ಈಸ್ ಇನ್ಫಿನಿಟಿ. ಇನ್ಫೈನೈಟ್ ಆಗೋಗಿದ್ರಿಂದ ಎಫ್ಸಲಾನ್ ಆರ್ ಇನ್ಫಿನಿಟಿ ಆಗಿದ್ರೆ ಎಫ್ಸಲಾನು ಇನ್ಫಿನಿಟಿ ಆದಂಗೆ, ಯಾಕಂದ್ರೆ ಇದಕ್ಕೆ ಫೈನೈಟ್ ವ್ಯಾಲ್ಯೂ ಇದೆ, ಆದ್ರೆ ಇದು ಇನ್ಫೈನೈಟ್ ಆಗೋಯ್ತು. ಹಾಗಾಗಿ ಏರರ್ ವ್ಯಾಕ್ಯೂಮ್ ನಲ್ಲಿ ಎಫ್ಸಲಾನ್ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1. ಬೇರೆ ಯಾವುದೇ ಮೀಡಿಯಂ ತಗೊಂಡ್ರು ಕೂಡ ಫಾರ್ ಆಲ್ ಅದರ್ ಮೀಡಿಯಾ, ನಾವು ಅದರ್ ಮೀಡಿಯಾ ಅಂತ ತಗೊಳ್ತು ಅಂದ ತಕ್ಷಣನೇ ಎಫ್ಸಲಾನ್ ಆರ್ ವ್ಯಾಲ್ಯೂ ಬಿ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1. ಓಕೆ, ಇಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 1 ಫಾರ್ ಏರರ್ ವ್ಯಾಕ್ಯೂಮ್. ಏರರ್ ವ್ಯಾಕ್ಯೂಮ್ ಬಿಟ್ಟು ಬೇರೆ ಮೀಡಿಯಂ ನ ತಗೊಂಡ್ರೆ epsilon r value will be more than 1, and it will be equal to infinity for conductors. Therefore, by introducing a conducting metallic plate between the two charges, it is possible to nullify the interaction between the charges. Okay, that is, we are having idea of shielding ourselves from the charge. interaction. Interaction in the ತಪ್ಪಿಸ್ಕೊಳ್ಳೋಕೆ ಅವಕಾಶ ಇದೆ electrostatic force, but there is no chance of shielding ourselves from gravitational force. ನಾವು ಎಲ್ಲಿ ಹೋಗಿ ಕೂತ್ಕೊಂಡ್ರು ಕೂಡ except the center or except the infinity, okay, definitely the gravitational force will always be there, okay, because gravitational force is independent of the medium, but it depends on, when you consider the electrostatic force, it depends on the medium. Therefore, for air vacuum, it is equal to 1, epsilon r value is 1. For other media, it will be greater than 1. And for conductors, it is infinity. Okay, that's why by changing the medium, it is possible to get different amount of interactions. Okay, in fact, ನಾನು ಅವಾಗಲೇ ಮೆನ್ಷನ್ ಮಾಡಿದೆ, ಈ ಐಡಿಯಾ ನಾವು ತಗೊಳ್ಳೋಕ್ಕೋಸ್ಕರ F proportional to product of the magnitudes of the charges. He basically, Coulomb used the idea of bringing a charged spherical conductor with uncharged one. Okay, ಈಗ ಫಸ್ಟ್ ಒನ್ Q ತಗೊಂಡ, ಎರಡರಲ್ಲಿ Q ಇತ್ತು ಒಂದು ಸ್ಪೆರಿಕಲ್ ಕಂಡಕ್ಟರ್ ಮೇಲೆ, ಇನ್ನೊಂದನ್ನು ಕಾಂಟ್ಯಾಕ್ಟಿಗೆ ತಂದ ತಕ್ಷಣ ಎರಡರ ಮೇಲೆ ಎಷ್ಟು ಬಂತು ಚಾರ್ಜು? Q/2. ಈಗ Q/2 ಇರೋಂತ ಒಂದು ಸ್ಪೆರಿಕಲ್ ಕಂಡಕ್ಟರ್ ಜೊತೆಗೆ ಇನ್ನೊಂದು ಅನ್ಚಾರ್ಜಡ್ ಸ್ಪೆರಿಕಲ್ ಕಂಡಕ್ಟರ್ನ ತಂದ. When he brought uncharged spherical conductor in contact with a spherical conductor carrying Q/2, immediately the charges you obtained on the two Q/4. ಹಾಗಾಗಿ ಅವನಿಗೆ ಆಕ್ಚುಲ್ ಆಗಿ ಒಂದು ಸೆಂಟೆನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಯಾರ ಮೊನ್ನೆ ಮೆಸೇಜ್ ಮಾಡಿದ್ರು, ಸರ್ ಏನಂತ ಅದು. He was not at all any idea, Coulomb was not at all having any idea about measuring the magnitude of the force. Sorry, ಚಾರ್ಜ್ ನ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಎಷ್ಟು ಅನ್ನೋದು ಅವನಿಗೆ ಏನು ಗೊತ್ತಿರಲಿಲ್ಲ, ಅದನ್ನ ಮೆಜರ್ ಮಾಡೋದು ಹೇಗೆ ಅಂತಾನೂ ಕೂಡ ಗೊತ್ತಿರಲಿಲ್ಲ. ಬಟ್ he was having the idea that once we consider a charged spherical conductor, if we bring another uncharged spherical conductor in contact with it, basically the charge gets distributed equally among the two. Okay, ಎರಡರ ಮಧ್ಯೆ ಈಕ್ವಲ್ ಆಗಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ. With this idea, he carried out experiments repeatedly, and finally he formulated the idea the force will be directly proportional to the product of the magnitudes of the charges and inversely proportional to square of the distance. Okay, Newton's law obeys inverse square law. Okay, Coulomb's law also obeys inverse square law. What is the idea of inverse square law? Andre, initially if I have separated the two charges by a certain distance r, I'll get some force. But if the same charges are separated by a distance 2r, r ನ ಇಲ್ಲಿ ತಗೊಂಡಿದ್ದೀನಿ, ಡಬಲ್ ಮಾಡಿದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಡಿಸ್ಟೆನ್ಸ್ ಡಬಲ್ ಆಯ್ತು ಅಂದ ತಕ್ಷಣ 2r ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಇದೆ. ಹಾಗಾದ್ರೆ 2r ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಅಂದ ತಕ್ಷಣ 2 ಸ್ಕ್ವೇರ್ 4 ಬಂದ್ಬಿಡುತ್ತೆ. ಅಂದ್ರೆ ಮುಂಚೆ ಏನಿತ್ತು ಅದ್ರದ್ದು 1/4 ಅಷ್ಟು ಫೋರ್ಸ್ ಇರುತ್ತಷ್ಟೇ. ಓಕೆ, ದಟ್ ಮೀನ್ಸ್ it is possible to change the force of interaction by changing the separation between the charges. ಹಾಗಾದ್ರೆ 2 times ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ ಫೋರ್ಸ್ 1/4 ಆಗುತ್ತೆ, 3 times ಚೇಂಜ್ ಮಾಡಿದ್ರೆ 1/9 ಆಗುತ್ತೆ. ಓಕೆ, 10 times ಜಾಸ್ತಿ ಮಾಡ್ತು ಅಂದ್ರೆ 1/100th of the initial force we come across. Okay, this is the idea of inverse square law. Coulomb's law is obeying inverse square law. Gravitational force also obeys inverse square law. But the important thing is gravitational force between two bodies will always be attractive in nature. It can never be repulsive. Okay, repulsive ಆಗಿರಲ್ಲ. ಓಕೆ, ಯಾವಾಗಲೂ ಕೂಡ ಇದು ಇದಾಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಹಾಗಾಗಿ ಆದ್ರೆ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಬಂತು ಅಂದ್ರೆ it is attractive as well as repulsive. Another important difference between gravitational force and electrostatic force is gravitational force is independent of the nature of the medium present between the two, but Coulomb's force or electrostatic force or electrical force of interaction between the two charged particles will be depending on the nature of the medium also. Okay, these are the ideas that you should be knowing related to Coulomb's law and gravitation law. Okay, constant of proportionality ವ್ಯತ್ಯಾಸ ಫ್ಯಾಕ್ಟರ್ಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದ್ರಿಂದ ಫೋರ್ಸ್ ಕೂಡ ಡಿಪೆಂಡೆನ್ಸ್ ನ ತೋರಿಸುತ್ತೆ. ಓಕೆ, ಹಿಯರ್ I have given K for a SI system and air vacuum as 1/4 pi epsilon naught. In fact, when you consider the value of epsilon naught in this equation, we'll get the value that is 9 into 10 to the power 9. Okay, the value of 1/4 pi epsilon naught or the proportionality constant will be equal to 9 into 10 to the power 9. What is the unit of K or what is the unit of epsilon naught? You can always understand by using the idea of dimensions. Okay, equations ಇದನ್ನ ಉಪಯೋಗಿಸಿಕೊಂಡು K ದ ಯೂನಿಟ್ ಏನು ಬರುತ್ತೆ, epsilon naught unit ಏನು, that you can always find out. Okay, first I'll consider the unit of K. According to this, K is equal to what? F R square by mod of Q1 Q2. Is it right? K is equal to F into R square divided by this. ಹಾಗಾದ್ರೆ ಎಫ್ ಕೆ ಏನ್ ಗೊತ್ತು, ಯೂನಿಟ್ ಗೊತ್ತಿದೆ ನಿಮ್ಗೆ, ನ್ಯೂಟನ್. ಆರ್ ಸ್ಕ್ವೇರ್ ಹಾಗಾದ್ರೆ ಮೀಟರ್ ಸ್ಕ್ವೇರ್, ಇದು ಕೂಲಮ್. ಓಕೆ, ಇನ್ಫ್ಯಾಕ್ಟ್ ಕೂಲಮ್ಸ್ ಲಾ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದಾಗ ಅವನಿಗೆ ಕೂಲಮ್ ಅನ್ನೋದು ಗೊತ್ತೇ ಇರಲಿಲ್ಲ. ಆಮೇಲೆ ಅವನ ಅದು ಸ್ಟಡಿ ಮಾಡಿದ್ರಿಂದ ಅವನಗೋಸ್ಕರ ಆ ನೇಮ್ನ ಕೊಟ್ಟು ನ್ಯೂಟನ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್. ಹಾಗಾದ್ರೆ ಇದು ಪರ್ ಕೂಲಮ್ ಸ್ಕ್ವೇರ್. ಓಕೆ, ಆಫ್ಟರ್ವರ್ಡ್ಸ್ ಐ ಡಿಫೈನ್ ದಿಸ್ ನ್ಯೂಟನ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಪರ್ ಕೂಲಮ್ ಸ್ಕ್ವೇರ್. ಓಕೆ, ದಿಸ್ ಈಸ್ ದ ಯೂನಿಟ್ ಆಫ್ ಕೆ. ಕೆ ವ್ಯಾಲ್ಯೂ ಇದಾಗಿರುತ್ತೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ಬಂದಾಗ ಇನ್ನೊಂದು ಯೂನಿಟ್ ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತೀನಿ. ಈಗ ನಾನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳಕ್ ಹೋಗಲ್ಲ. ನ್ಯೂಟನ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಪರ್ ಕೂಲಮ್ ಸ್ಕ್ವೇರ್ ಇಸ್ ದ ಯೂನಿಟ್ ಆಫ್ ಕೆ. ಈಗ ಕೆ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಂತ ಹೇಳ್ತಿದೀವಿ, 1/4 pi epsilon ಅಥವಾ ಎಪ್ಸಲಾನ್. ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ epsilon r will be equal to 1/4 pi k. ಕರೆಕ್ಟ್? ಈಗ ನೀವೇ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರಿ 4 pi ಅನ್ನೋದು ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್, ಒಂದು ನಂಬರ್. ಓಕೆ, ಹಾಗಾಗಿ ಅದಕ್ಕೆ ಏನು ಯೂನಿಟ್ ಇರಲ್ಲ. ಹಾಗಾದ್ರೆ 1/k. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಏನು ಯೂನಿಟ್ ಬಂದಿದೆ ಅದು ರಿವರ್ಸ್ ಆಗುತ್ತೆ. ಓಕೆ, ರೆಸಿಪ್ರೋಕಲ್ ತಗೋಬೇಕಾಗತ್ತೆ. ದಟ್ಸ್ ವೈ ದ ಯೂನಿಟ್ ಆಫ್ ಎಪ್ಸಲಾನ್ ಆರ್ ಎಪ್ಸಲಾನ್ ನಾಟ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು -1 m to the power -2 ಕೂಲಮ್ ಸ್ಕ್ವೇರ್. ಓಕೆ, ದಿಸ್ ವಿಲ್ ಬಿ ದ ಯೂನಿಟ್ ಆಫ್ ಎಪ್ಸಲಾನ್. ಓಕೆ, ಆರ್ ಎಪ್ಸಲಾನ್ ನಾಟ್. ಬರೀ ಎಪ್ಸಲಾನ್ ಅಷ್ಟೇ ಅಲ್ಲ, ಎಪ್ಸಲಾನ್ ನಾಟ್ ಆದ್ರೂ ಕೂಡ ಅಷ್ಟೇ. ಓಕೆ, ಎರಡಕ್ಕೂ ಕೂಡ ಒಂದೇ ಯೂನಿಟ್. ಆದ್ರೆ ಒಂದು ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿರಿ, ಈ ಎಪ್ಸಲಾನ್ ಆರ್ ಅಂತ ಏನ್ ತಗೊಳ್ತಿದೆ, ಎಪ್ಸಲಾನು ಎಪ್ಸಲಾನ್ ನಾಟ್ ಯೂನಿಟ್ ಒಂದೇ ಅಂತ ನಾನು ಹೇಳಿದ ಮೇಲೆ ಇಲ್ಲಿ ಇನ್ನೊಂದು ಫ್ಯಾಕ್ಟರ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತಿದ್ದೀರಾ ಅಂತಂದಾಗ ಯೂನಿಟ್ ವ್ಯತ್ಯಾಸ ಆಗಬಾರ್ದು ಅಂತಂದ್ರೆ ಇದ್ರ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರ್ಬೇಕು, ಓಕೆ, ಒಂದು ನಂಬರ್ ಆಗಿರ್ಬೇಕು. ಓಕೆ, ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಜಸ್ಟ್ ಎ ನಂಬರ್. ಓಕೆ, ಒಂದು ನಂಬರ್ ಆಗಿರ್ಬೇಕಾಗತ್ತೆ. ಹಾಗಾಗಿ ಎಪ್ಸಲಾನ್ ಆರ್ ವಿಲ್ ನಾಟ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಎನಿ ಯೂನಿಟ್. ಓಕೆ, ಎಪ್ಸಲಾನ್ ಆರ್ ನೋ ಯೂನಿಟ್. ಓಕೆ, ಈಗ ನಿಮ್ಗೆ ಒಂದು ಕೆಲಸ ಕೊಡ್ತಾ ಇದ್ದೀನಿ, ಹೋಮ್ವರ್ಕ್. ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ದ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಫಾರ್ ಕೆ. ಕೆ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಬರೀಬೇಕು. ಎಪ್ಸಲಾನ್ ಎಪ್ಸಲಾನ್ ನಾಟ್ ಇದು ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಬರೀಬೇಕು. ಎಪ್ಸಲಾನ್ ಆರ್ಗೆ ಯೂನಿಟ್ ಇಲ್ಲ ಅಂತ ಅಂದ್ಮೇಲೆ ಅದಕ್ಕೆ ಡೈಮೆನ್ಷನ್ಸ್ ಇರಲ್ಲ. ಹಾಗಾಗಿ ಎಪ್ಸಲಾನ್ ಆರ್ ಇಸ್ ಡೈಮೆನ್ಷನ್ಲೆಸ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ. ಲಾಸ್ಟ್ ಇಯರ್ ಕೆಲವೊಂದು ಹೇಳಿತ್ತು. ಓಕೆ, ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಡೈಮೆನ್ಷನ್ಲೆಸ್. ಓಕೆ, ಆದ್ರೆ ಇದನ್ನ ತಗೊಂಡ್ರೆ ಇದು ಕೂಡ ಡೈಮೆನ್ಷನ್ಲೆಸ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಎಪ್ಸಲಾನ್ ಆರ್. ಬಟ್ ಎಪ್ಸಲಾನ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಯೂನಿಟ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಡೈಮೆನ್ಷನ್. ನಾನು ನಿಮಗೆ ಕೊಡ್ತಾ ಇರೋ ಹೋಮ್ವರ್ಕ್ ಏನು, ಕೆಗೆ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಬರ್ದಿರ್ಬೇಕು. ಎಪ್ಸಲಾನ್ ನಾಟ್ ಎಪ್ಸಲಾನ್ ಅಂದ್ರೆ ಎರಡಕ್ಕೂ ಸೇಮೆ, ಅದಕ್ಕೆ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಬರ್ದಿರ್ಬೇಕು. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಐಡಿಯಾನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿ ವಿಲ್ ಬಿ ಡಿಸ್ಕಸಿಂಗ್ ಕೂಲಮ್ಸ್ ಲಾ ಇನ್ ವೆಕ್ಟರ್ ಫಾರಮ್. ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಆದ್ರೆ ಇಲ್ಲೊಂದು ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿರಿ, ಈ 4-5 ಫ್ಯಾಕ್ಟರ್ SI ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಮಾತ್ರ ಬರುತ್ತೆ. ಅದಕ್ಕೆ ಸ್ಪೆರಿಕಲ್ ಸಿಮಿಟ್ರಿ ಅದ್ರ ಬಗ್ಗೆ ನಾನು ಜಾಸ್ತಿ ಹೇಳಕ್ ಹೋಗಲ್ಲ. ಓಕೆ, ಆಮೇಲೆ ನಾನಾಗ್ಲೇ ಹೇಳಿದ್ದೀನಲ್ಲ, ಇವತ್ತು ಕ್ಲಾಸಸ್ ಮುಗಿದಾದ್ಮೇಲೆ ವಿಡಿಯೋ ಕಳಿಸ್ತೀನಿ. ವಿಡಿಯೋನ ನೋಡಿ, will understand how actually Coulomb measured the interactions and formulated the law. Okay, thank you.
So good morning, friends. Welcome to online classes. So last week I was discussed about the isomerism in complex compounds. Under that, under the type of isomerism, I think optical isomerism I was completed. Under I take some examples. Okay. I take one more example under the same type called as optical isomerism. So it is one of the examples for optical isomerism. Okay, I'm good with it. So in optical isomerism, so whatever the isomers have mirror images, okay, they cannot be superimposed on one another. Next, whatever the ions or molecules in those which are optically active and they can rotate in a plane polarized. Therefore, we have two isomers. You can put like this. This is Guru ಅಲ್ವಾ? ಗುರು ಕರೀರಿ ಗುರು ಅಲ್ಲೇನೋ ಬಂದಿದ್ದಾನೆ ಸ್ಕ್ರೀನ್ ಮೇಲೆ ಬಂದಿತ್ತು. ಶ್ರವಣ. So if the isomer rotates to the right side, it is called as a dextro. The isomer rotates to, left side, we call it as a levo. Okay. So example 2 mark again. Write the optical isomerism for the following a given complex n. For this complex n, so these are the optical isomers. You can put like this. So this is dextro. So this is levo. Okay. Okay. This is the second example. Comes under optical isomerism. Okay. So I think that completes the isomerism in complex compounds. So next, today I pass on to the next concept. It's very important from the point of examination. Okay. So namely, valence bond theory. Okay. Under that, first I can take some points regarding Wheeler's bond theory. Then I can go for the actual the applications of Wheeler's bond theory. Okay, for the taken complex compounds. Okay, so valence bond theory abbreviation ಬಂದು VBT ಗೊತ್ತಿದೆ. So V stands for valence, B stands for bond, and T stands for theory. Okay, first I want to give the introduction. Okay, study. This theory was first proposed by the two chemists, namely, okay, Hilter and London. In the year 1927, okay, Hilter and London were the chemists were proposed first this theory in the year 1927. Next, this theory next modified by the next chemist by the namely, okay, Linus Pauling. Linus Pauling. Pauling in the year 1931. Okay. Therefore, till today we can take the concept with respect to what is the headache given by this chemist, namely that Linus Pauling from this year onwards till today. Therefore, the valence bond theory is modified by this chemist, namely Linus Pauling in the year 1931. Okay. Next, this theory has some important points. I can take such important points in the form of that the silent features of VBT. Important points we called. So important points regarding valence bond theory. Okay. If you know the points, then you can easily understand the applications for the taken the complex compound, because in order to explain that type of hybridization, geometry and the magnetic property of the given complex compound based on the VBT, if you know the points, you can easily understand in the next class. Okay. First, I want to give some points regarding the VBT. I take first example. So it is one of the example for complex compound. Here, I want to give what is meant by the covalent bond or dative bond. Okay. In this VBT, we define the definition of covalent bond in a different way. ನಮಗೆ ಗೊತ್ತಿದೆ ಏನು covalent bond is a type of covalent bond in which one of the atom can donate both the electrons for the bond formation. That can shown by a symbol by arrow mark pointing from donor to acceptor. Okay. Illi donor or the ligand can donate a pair of electrons to the metal atom M. ಇಲ್ಲಿ L and stands for ligand, M stands for the metal atom in the given complex compound. Therefore, they are symbolically given by the, covalent bond. Okay, covalent bond. So in the definition, okay, covalent bond is a type of covalent bond in which one of the atom can donate both of the electrons for the bond formation. That is shown by a symbol by arrow mark from pointing from donor to acceptor. In the given complex compound, the donor is ligand, then acceptor is metal atom. Therefore, you can show the arrow mark from ligand to a metal is called as a covalent bond. But in the VBT theory, we can define the definition of covalent bond in a different way. I can take first point. Okay. The first point. By the overlapping of the ligand orbital containing a pair of electrons with the vacant hybrid orbital of the metal atom or metal ion. Okay, a covalent bond is formed by the overlapping of the ligand orbital containing a pair of electrons with the vacant hybrid orbital of the metal atom or metal ion. ಇದು ligand orbital that overlap with the ಈ ಕೇಸಲ್ಲಿ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಓಕೆ, ಅಂದ್ರೆ ಇದು ವೇಕೆಂಟ್ hybrid orbital of the metal atom and the ligand orbital having a lone pair of electron. Okay, when the overlap means mix up, get together. Okay, therefore the ligand orbital is overlap with the metal orbital containing overlap with the ligand orbital containing a pair of electrons with the metal orbital to form a covalent bond. Therefore, according to VBT, a covalent bond is formed by the overlapping of the ligand orbital containing a pair of electrons with the vacant hybrid orbital of the metal atom or metal ion. It is the definition of the covalent bond according to VBT. Okay, so overlap means the orbital they get together, they mix up. At a point, the bond is formed. Okay, so this is the definition of the covalent bond by VBT. One point to okay. Second point. Okay. Study in the given complex compound, the central metal atom. Here in this complex compound, copper metal ion is the central metal atom. Okay, contains a definite number of vacant orbitals. Whatever the metal atom in the complex compound contains a definite number of vacant orbitals. Those vacant orbitals, okay, those vacant orbitals which are necessary for the overlap with the ligand orbital to form a covalent bond. Therefore, the second point is in a complex compound, the central metal atom contains a definite number of vacant orbitals. Okay, a metal atom, okay, contains a definite number of vacant orbitals. Next point ಬಂದು the number of vacant orbitals provided by the metal ion in the complex that is equal to its quotient number. ಅಂದ್ರೆ ಎಷ್ಟು ವೇಕೆಂಟ್ ಆರ್ಬಿಟಲ್ ನ ಪ್ರೊವೈಡ್ ಮಾಡುತ್ತೆ ಮೆಟಲ್ ಆಟಮ್ ಅದಕ್ಕೆ ಯಾವ್ದು ಸಮ ಆಗುತ್ತೆ ಆ ರೆಸ್ಪೆಕ್ಟ್ ಮೆಟಲ್ ಆಟಮ್ದು ಕ್ವಾಡ್ರೇಚರ್ ನಂಬರ್ಗೆ ಸಮ ಆಗುತ್ತೆ. ಈ ಕೇಸಲ್ಲಿ ಈ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ನೋಡಿ the copper metal atom can provide 4 vacant orbital because the coordination number of copper metal atom in this complex is 4. What is meant by coordination number? I told already. The total number of ligands are bonded to metal ion in the complex that is equal to that is called as a coordination number. ಅಂದ್ರೆ ಇಲ್ಲಿ amine molecules are act as a ligand. How many molecules are there? 4 molecules. ಅಂದ್ರೆ 4 molecules are act as ligand. Those ligands attached to metal ion. Therefore, 4 ligands attached to metal ion. Therefore, the coordination number of copper is 4 in this case. Therefore, the copper metal atom can provide 4 vacant orbital. This is the meaning. Therefore, the number of vacant orbital provided by the metal atom that is equal to its coordination number. On the basis, in this complex compound, the copper metal atom can provide 4 vacant orbital because the coordination number of copper is 4 in this case because 4 ligands attached to the copper metal atom. A third point, okay, third point, okay. The metal atom can provide a definite number of vacant orbital that is equal to its coordination number. Okay. Next, I can pass on to fourth point. So fourth point is ನೋಡಿ ಏನು the complex compound having a definite geometry, having a definite shape. Okay, if you take any example of complex compound, that complex compound possesses the definite geometry. Okay, ಇಲ್ಲಿ the geometry or shape of the complex compound depends on the type of the hybridization. Okay, okay, sorry, 4 point. The type of the geometry or shape of the complex depends on type of hybridization. Okay. First, what is meant by the meaning or definition of hybridization? Okay. Here, the process I can define it. The process in which one or more the different orbitals they mix up. If 2 or more the different orbitals possess the different energy and shape. After mixing, they give the same number of identical hybrid orbitals. So such process is called as the hybridization. ಅಂದ್ರೆ ಒಂದಕ್ಕಿಂತ ಹೆಚ್ಚು ಆರ್ಬಿಟಲ್ ಓವರ್ಲ್ಯಾಪ್ ಆಗ್ತವೆ. ಓವರ್ಲ್ಯಾಪ್ ಆದಾಗ ದೇ ಗಿವಿಂಗ್ ದ ಸೇಮ್ ನಂಬರ್ ಆಫ್ ಆರ್ಬಿಟಲ್ ಕೊಡುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, ಈಗ ಎಸ್ ಆರ್ಬಿಟಲ್ 1 ಮತ್ತೆ 3 ಪಿ ಆರ್ಬಿಟಲ್ ಟು ಗಿವ್ sp3 which are called sp3 hybrid orbitals. We called hybrid orbitals. ನೋಡಿ, ಒಂದು ಎಸ್ ಮತ್ತೆ 3 ಪಿ ಆರ್ಬಿಟಲ್ ದೇ ಕಂಬೈನ್ ಟು ಗಿವ್ ಒಟ್ಟು ಎಷ್ಟಾಗುತ್ತೆ 1 + 3 ಒಟ್ಟು 4. We get 4 identical. ನೋಡಿ, what is identical? ನೋಡಿ, so before overlap the energy and shape of the s orbital and p orbital are different. This is energy, s orbital energy kadime compared to the energy of the p orbital. ಆಮೇಲೆ ಶೇಪ್ ತಗೊಂಡಾಗ ಎಸ್ ಆರ್ಬಿಟಲ್ ಶೇಪ್ ಸ್ಫೆರಿಕಲ್, ಪಿ ಆರ್ಬಿಟಲ್ ಶೇಪ್ ಡಂಬೆಲ್ ಶೇಪ್. ಓಕೆ, ಅಂದ್ರೆ even though they differ in the energy and shape, after overlap, they giving the same number of identical hybrid orbitals. ಇಲ್ಲಿ ಬಂದಂತ 4 sp3 hybrid orbital possess the same energy and same shape. That is the meaning of hybrid orbitals. ಓಕೆ, ಅಂದ್ರೆ ಬಿಫೋರ್ ಮಿಕ್ಸಪ್ ಆಗಕ್ಕಿಂತ ಆ ಎರಡು ಆರ್ಬಿಟಲ್ದು ಎನರ್ಜಿ ಮತ್ತೆ ಶೇಪ್ ಚೇಂಜ್ ಇರುತ್ತೆ. ಬಟ್ ಮಿಕ್ಸಪ್ ಆದ್ಮೇಲೆ ಆ ಬಂದಂತ ಆರ್ಬಿಟಲ್ದು ಎನರ್ಜಿ ಮತ್ತೆ ಶೇಪ್ ಒಂದೇ ಆಗುತ್ತೆ. ಸೊ ಸಚ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಎ ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್. ಐಡೆಂಟಿಕಲ್ ನಾಲ್ ರೆಸ್ಪೆಕ್ಟ್ ಅಂದ್ರೆ ಎನರ್ಜಿನೂ ಒಂದಿರುತ್ತೆ, ಶೇಪ್ ಒಂದಿರುತ್ತೆ. ಅಂದ್ರೆ ಸೇಮ್ ನಂಬರ್ ನೋಡಿ, ಇದು ಒಂದು ಎಸ್ ಆರ್ಬಿಟಲ್ ಮೂರು ಪೇರ್ಬಿಟಲ್ ಕಂಬೈನ್ ಆದಾಗ ಒಟ್ಟು 4 ಬರ್ತವೆ. ಹೀಗೆ 1 + 3 4 ಅಂತ. ಓಕೆ, therefore we can get 4 sp3 hybrid orbital when one s orbital combines with the 3p orbitals. Okay, I can define once again the process in which 2 or more the different orbitals undergoes overlap or the mix up to give the same number of identical hybrid orbitals. So such is called as the definition of that hybridization. Okay, therefore the geometry shape of the complex compound depends on the type of action. Ready? If the complex compound possesses this type of action, what is the geometry obtained? It is called tetrahedral. I can take a table. So type of hybridization. sp3, next to dsp2, next to dsp3, next to d2sp3. In the syllabus we have 4 types. In the sp3 type, ಇನ್ನೊಂದು dsp2 type, third one ಬಂದು dsp3, fourth one ಬಂದು d2sp3. Okay. With respect to the type of hybridization, we get the geometry of the respective. Okay. So geometry, or I mean shape we call. So sp3 hybridization andre the geometry or shape is going to be tetrahedral. Tetrahedral. dsp2 ಆದ್ರೆ ಸ್ಕ್ವೇರ್ ಪ್ಲಾನರ್. ಇಲ್ಲಿ ಟೆಟ್ರಾ ಅಂದ್ರೆ 4, ಹೀಡ್ರಾ ಅಂದ್ರೆ ಪೇಸು, 4 ಪೇಸ್ ಇರಂತ ಒಂದು ಜಾಮಿಟ್ರಿ ಬರುತ್ತೆ ಆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ಗೆ. ನೆಕ್ಸ್ಟ್ dsp3 ಆದ್ರೆ dsp2 ಆದ್ರೆ ಅದಕ್ಕೆ ಸ್ಕ್ವೇರ್ ಪ್ಲಾನರ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ dsp3 ಆದ್ರೆ ಟ್ರಿಗನಲ್ ಬೈಪಿರಮಿಡಲ್. Trigonal bipyramidal. Trigonal bipyramidal. The last one, last type andre dsp3 bandre octahedral. Octahedral. Okay. So in our next conference, baranta complex compounds ke the geometry is going to be tetrahedral antara ಒಂದರಲ್ಲಿ ಬಂದಿರುತ್ತೆ, ಸ್ಕ್ವೇರ್ ಪ್ಲಾನರ್ ಒಂದು ಬಂದಿರುತ್ತೆ, ಇನ್ನೊಂದು octahedral ಇನ್ನೊಂದು 2 ಬರ್ತೈತೆ. ಈ 4 ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಈ 3 ಶೇಪ್ ಬಂದಿರುತ್ತೆ. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಪರ್ಟಿ ಫಾರ್ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಗೆ. ಓಕೆ ಓಕೆ, therefore the geometry or shape of the complex compound depends on the type of the hybridization. If the complex compound undergoes sp3 hybridization, the geometry is going to be tetrahedral. If the complex compound undergoes d2sp3 hybridization, the geometry is going to be octahedral and etc. And also the shape is also depends on the number of hybrid orbital. ನೋಡಿ s ಮತ್ತೆ 3p ನೋಡಿ, ಇಲ್ಲಷ್ಟೇ ಒಂದು d ಒಂದು s ಮತ್ತೆ 2p ds ಹೇಳಿದ್ರೆ, ಇಲ್ಲಷ್ಟೇ dsp3 ಅಂದ್ರೆ ಒಂದು d ಆರ್ಬಿಟಲ್ ಒಂದು s ಆರ್ಬಿಟಲ್ ಮತ್ತೆ 3p ಆರ್ಬಿಟಲ್. dsp3 ಅಂದ್ರೆ 7d ಮತ್ತೆ ಒಂದು s ಮತ್ತೆ 3p. therefore the geometry is also depends on the number of hybrid orbital. ಓಕೆ, ಅದು ಹೇಳ್ಬೋದು. ಓಕೆ, ಅಥವಾ ಸಿಂಪಲ್ ಆಗಿ the geometry of the complex compound depends on the type of the hybridization. Next point, next one. Okay, 5ನೇ ಪಾಯಿಂಟ್ ನೋಡಿ ಇಲ್ಲಿ ತಗೊಂಡ್ರೆ ನೋಡಿ whatever the vacant orbitals of metal atom undergoes the process hybridization to give the same number of identical hybrid orbital. ಇಲ್ಲಿ ತಗೊಂಡ್ರೆ ಒಂದು s orbital ಮತ್ತೆ 3 p orbital to give 4sp3. ಓಕೆ, ಇಲ್ಲಿ ಒಂದು d orbital, ಒಂದು s orbital ಮತ್ತೆ 2 p ಒಟ್ಟು ಎಷ್ಟಾಯ್ತು? 1 1 2 2 2 4. ಸೊ ಇಲ್ಲಷ್ಟೇ 4 ಐಡೆಂಟಿಕಲ್ ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ ಆಫ್ sp2. ನೋಡಿ ಇಲ್ಲಿ ಒಂದು, ಇಲ್ಲಿ ಒಂದು, 2 ಮತ್ತೆ 3 ಒಟ್ಟು 5 sp3 ಹೈಬ್ರಿಡ್, ಸಾರಿ 5 ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ ಆಪ್ಟೈನ್. ನೋಡಿ ಇಲ್ಲಿ 2, ಇದೊಂದು s1 3 ಮತ್ತೆ ಪಿನಲ್ಲಿ 3 ಒಟ್ಟು 6. 2 1 3 3 3 6 ಒಟ್ಟು 6 ವಿಕೆಟ್, 6 hybrid orbital. Okay, when 2 d orbital and 1 s orbital and 3 p orbital undergoes overlap. Okay, therefore whatever the vacant hybrid orbital of metal ion undergoes the process called hybridization to give the same number of the same and identical number of the respective hybrid orbital. sp3 hybrid, ಇದು dsp2 hybrid, ಇದು dsp3 hybrid, ಇದು ds3 hybrid. Okay. So next point one, if the complex compound contains one or more unpaired electrons, ಒಂದಕ್ಕಿಂತ ಹೆಚ್ಚು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ರೆ, ಅನ್ಪೇರ್ಡ್ ಅಂದ್ರೆ ನಾಟ್ ಪೇರ್ಡ್ ಅಂತ, ಒಂದೇ ಅಂದ್ರೆ ಅನ್ಪೇರ್ಡ್, 2 ಬಂದ್ರೆ ಪೇರ್ ಅಪ್ ಅಂತ. ಅಂದ್ರೆ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಒಂದಕ್ಕಿಂತ ಹೆಚ್ಚು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ರೆ such complex compound shows the property, okay, shows the magnetic property is paramagnetic property. Corner point, if the complex compound contains one or more unpaired electrons ಒಂದಕ್ಕಿಂತ ಹೆಚ್ಚು ಅನ್ಪೇರ್ಡ್ ಇದ್ರೆ such complex compound shows at the base like a paramagnetic property. Okay, ಅಂದ್ರೆ ಆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ನ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಗೆ ನಾವು, ಸಾರಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ಗೆ ದೇ ಗೆಟ್ ರಿಪೆಲ್ ಆಗುತ್ತೆ ಬಿಕಾಸ್ ಆಫ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದ unpaired electrons. So such property shown by the complex compound which is called as a paramagnetic property. Next, if the complex compound does not contain any unpaired electrons, ಒಂದಿರಲ್ಲ unpaired ಇರಲ್ಲ, ಅವಾಗ such complex compound, okay, ಅಂದ್ರೆ the complex compound do not contain unpaired electrons. Great. So such complex compound shows the magnetic property is called diamagnetic property. Okay. So this property important under the application ability for the taken complex compounds. So this is an important property. Okay. Here already. So mention the magnetic property of the given complex M. ಆ ಕೊಟ್ಟರ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಏನಾದರೂ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ರೆ ಅವಾಗ ಅದರ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಈಸ್ ಆಕ್ಟ್ ಆಸ್ ಎ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಇನ್ ನೇಚರ್. ಆ ಕೊಟ್ಟರ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಒಂದು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದ್ರೆ ಆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ಇಟ್ ಆಕ್ಟ್ ಆಸ್ ಎ ಡೈಮಂಡ್ ಪ್ರಾಪರ್ಟಿ. ಆ ಕಾರಣಕ್ಕೆ ಈ ಪಾಯಿಂಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ದ ಅಪ್ಲಿಕೇಶನ್ ಇನ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಐ ಕ್ಯಾನ್ ಟೇಕ್ ಲಾಸ್ಟ್ ಪಾಯಿಂಟ್ ಬಂದು ನೋಡಿ, ಲಿಗೆಂಡ್ ಅಂತ ತಗೊಂಡಾಗ ಲಿಗೆಂಡ್ ಅಲ್ಲಿ ವಿ ಹ್ಯಾವ್ 2 ಟೈಪ್ಸ್, ಒಂದು ಸ್ಟ್ರಾಂಗ್ ಲಿಗೆಂಡು, ಇನ್ನೊಂದು ವೀಕ್ ಲಿಗೆಂಡು. ಇನ್ ಸಮ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದ ಸ್ಟ್ರಾಂಗ್ ಲಿಗೆಂಡ್. ಈ ಕೇಸಲ್ಲಿ ಯಾವ ಲಿಗೆಂಡು? ಅಮೈನ್ ಲಿಗೆಂಡ್. ಇದು ಲಿಗೆಂಡು. ಎಂತ ಲಿಗೆಂಡು? ಸ್ಟ್ರಾಂಗ್ ಲಿಗೆಂಡ್. ಅವು ಯಾವ ಅಂದ್ರೆ ಬೇರೆ ಕೊಡ್ಬೋದು, ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ಬೋದು. ಈಗ ಕಾರ್ಬನ್ ಇಲ್ಲಿ ಕೊಡ್ಬೋದು, ಓಕೆ, ಸೆನಡೈನ್ ಕೊಡ್ಬೋದು. ಓಕೆ, ಅಮೈನ್ ಮಾಲಿಕ್ಯೂಲ್ ಸ್ಟ್ರಾಂಗ್ ಲಿಗೆಂಡು, ಕೋಬಾಲ್ಟ್ ಕಾರ್ಬನಲ್ ಅಯಾನು ಸ್ಟ್ರಾಂಗ್ ಲಿಗೆಂಡು, ಸೆನಡೈನ್ ಆಲ್ಸೋ example for strong ligand. Okay, ಇದನ್ನ ತಗೊಂಡಾಗ ಈ ಕೇಸ್ ನೋಡಿ, ಫ್ಲೋರೈಡ್ ಈಸ್ ಆಕ್ಟ್ ಆಸ್ ಎ ವೀಕ್ ಲಿಗೆಂಡು. ಇಲ್ಲಿ ಕೋಬಾಲ್ಟ್ ಮೆಟಲ್ ಏನಾಗುತ್ತೆ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ, ಇಲ್ಲಿ ಫ್ಲೋರೈಡ್ ಅಯನ್ ಆಕ್ಟ್ ಆಸ್ ಎ ಲಿಗೆಂಡ್ ಆಗುತ್ತೆ. therefore ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಲ್ಲಿ ಫ್ಲೋರೈಡ್ ಇಸ್ ಎ ವೀಕ್ ಲಿಗೆಂಡು, ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಹಾರ್ಮೋನ್ ಆಕ್ಟ್ ಆಸ್ ಎ ಸ್ಟ್ರಾಂಗ್ ಲಿಗೆಂಡು. therefore if the presence of strong ligand in the taken in the given complex compound, in the complex compound ಏನಾಗುತ್ತೆ, okay, the presence of unpaired bonds forcibly get paired up. And point two, okay, when strong ligand ಅಥವಾ in the presence of strong ligands, in the presence of strong ligands, such as standard ion, covalent ion, next to amine molecule, etc. The unpaired electron, forced to get paired up. Okay, so this force to get paired up is against to Hundsoul. It is against to Hundsoul. It is against to Hundsoul ಅಂತ ಕರೀತಾರೆ. So Hundsoul you already come across in first PUC under the periodic table. ಅಲ್ಲಿ ಬಂದಿರುತ್ತೆ ಒಂದು ಸ್ಟೇಟ್ಮೆಂಟ್. What is Hundsoul? Right. The pairing of electron does not take place until each hybrid orbital contain at least one electron. I can take one example. ಇದೆ ಈ ತರ ಇದ್ರೆ ಕೇಳ್ತಾನಲ್ಲಿ ನೋಡಿ, electrons pair up takes place until each orbital has at least one electron ಇರುತ್ತೆ. ಅವಾಗ ಮಾತ್ರ ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಬಂದು ಈ ತರ ಪೇರ್ ಅಪ್ ಆಗುತ್ತೆ, ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಬಂದ್ರೆ ಇಲ್ಲಿ ಪೇರ್ ಅಪ್ ಆಗುತ್ತೆ, ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಬಂದು ಇಲ್ಲಿ ಪೇರ್ ಅಪ್ ಆಗುತ್ತೆ. ಓಕೆ, ಅಂದ್ರೆ the pairing of electrons takes place until each orbital possesses at least one electron. The statement of Hundsoul. Okay, the pairing of electrons takes place in each hybrid orbital. Okay, contain at least one unpaired carbon. Contain one unpaired carbon. ಅಂದ್ರೆ ಪ್ರತಿ ಆರ್ಬಿಟಲ್ ಅಂದ್ರೆ unpaired carbon ಅವ ಮಾತ್ರ ಪೇರಿಂಗ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. therefore the pairing of electrons takes place ಇಂತರ ಇನ್ನೊಂದು ಬಂದ್ರೆ ಇದು ಬರಬೇಕು. the pairing of electrons takes place until the each orbital possesses at least one electron. next ಬಂದು ಇದು ಬರುತ್ತೆ ಅಂತ ಅರ್ಥ. ಓಕೆ, but it not happen in this discussion. ಅಂದ್ರೆ ಈ ತರ ಆಗಲ್ಲ. ಅಂದ್ರೆ ನೋಡಿ, when strong ligand, really ನೋಡಿ, I can take this example. The ligand of the amine, when the ligand amine is moved towards the metal atom, in the metal atom the presence of the ಸರಿ ಇರೋದು ಗುರುನ ಇದಾಯ್ತು, ಇದು ಬಂದ್ಬಿಡ್ತು, ಏನ್ ಮಾಡೋದು? ಸರಿ ಗುರು ಸರಿ. Okay, so when the ligand move towards the metal ion, whatever the unpaired electrons present in the metal ion, they are forced to get paired up. Possibly they get paired up. Again, ನೋಡಿ, I can take this example. ಈ ತರ ಇದೆ ಅಂದ್ಕೊಳ್ಳಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ. ಈಗ ಬಂದಂತ ಎಲೆಕ್ಟ್ರಾನ್ ಬಂದು ಇಲ್ಲಿ ಫಸ್ಟ್ ಪೆರಪ್ ಆಗಬೇಕು, ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಬಂದು ಇಲ್ಲಿ ಪೆರಪ್ ಆಗಬೇಕು, ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿ ಬಂದು ಪೆರಪ್ ಆಗಬೇಕು, ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಬಂದು ಇಲ್ಲಿ ಪೆರಪ್ ಆಗಬೇಕು ಬೈ ದಿಸ್ ರೂಲ್. ಬಟ್ ಇಲ್ಲ ಹಂಗಾಗಲ್ಲ. In the presence of strong ligand, whatever the unpaired electrons in the metal ion forcibly get paired up, ಅವಾಗ ಇದು ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ, ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ, ಅವಾಗ this becomes like this. ಈ ತರ ಆಗುತ್ತೆ. So this is pairing is against to control. Important to okay. ಅಂದ್ರೆ in the presence of strong ligand in the taken complex compound at the time, whatever the unpaired electrons in the metal atom, they forcibly get paired up. This pairing is against to control. Key point. Okay. So these are the points come across under the application CBT for the taken complex compound. Okay. In the syllabus, there are 4 examples. Among 4 examples, one example is compulsory. This is a question board exam only. This is the question number 25. On the basis of EBT, on the basis of valence bond theory, explain the type of hybridization, then geometry and minor property. The more point na keltane for 3 marks question. No, it is important, and also it is fixed one in the question paper for the question number 25. ಪ್ರತಿ ವರ್ಷ 4ರಲ್ಲಿ ಒಂದು ಗ್ಯಾರಂಟಿ ಕೇಳ್ತೇನೆ. 4 ಓದ್ಕೊಂಡ್ರೆ 3 ಮಾರ್ಕ್ ಗ್ಯಾರಂಟಿ ಬರುತ್ತೆ ಅಂತ. Okay, I will take the next application VBT. Okay, under first I can take example with respect to the examine cobalted ion. So if you know the points regarding the VBT, you can easily understand the applications for the taken complex compounds. But ಈ ಫೀಚರ್ಸ್ ನಿಮಗೆ ಕೇಳಲ್ಲ, ಬಟ್ ಈ ಪಾಯಿಂಟ್ಸ್ ಎಲ್ಲ ಗೊತ್ತಿದ್ರೆ ಮಾತ್ರ ನೆಕ್ಸ್ಟ್ ತಗೊಂಡ ಅಪ್ಲಿಕೇಶನ್ ಅಲ್ಲಿ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ ಕಾನ್ಸೆಪ್ಟ್. ಓಕೆ, application of valence bond theory. First, okay, I can take. Okay. On the basis of VBT, explain the type of hybridization geometry and any property. Okay. So for the given complex compound, you go for explain that is a process called the type of aberration. ಆಮೇಲೆ according to the type of aberration we get respect to geometry and with respect to the presence of or not present indre such complex compound base take a paramagnetic property. Unpaired electrons ilde idre such complex compound base take the diamagnetic property. Okay. Okay. ಈಗ I can take example for one is ಯಾವುದು this called ನೇಮ್ ಬಂದು ನೋಡಿ, ಇದು ಹಯಾನ್ ಎಕ್ಸಾಮೈನ್ ಕೋಬಾಲ್ಟ್ ಥರ್ಡ್ ಹಯಾನ್. ನೇಮ್ ಬಂದು type is the name. Okay. Examine cobalt. Third ion. Because this complex state which is in the F+3 oxide state, therefore the top state of the metal atom is 3. That can be shown in the Roman number in the bracket. Okay. Example in the question for metal atom, the atomic number is given. Okay. ಇಲ್ಲಿ atomic number for cobalt is given, Z is equal to 27. Okay. Atomic number for cobalt is 27 in bracket. So ಪ್ರತಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ಗೆ ಆ ರೆಸ್ಪೆಕ್ಟ್ ಮೆಟಲ್ ಆಟಮ್ ದು atomic number ಕೊಟ್ಟಿದ್ದಾನೆ in bracket ಅಲ್ಲಿ. By using that atomic number can show the outer electron configuration ನಾವು ಹೇಳ್ಕೊಂತೀವಿ. So before pass on to the steps, I want to give a brief sentences for the complex chain. First point ಬಂದು okay. According to atomic number, ಅದಕ್ಕಿಂತ ಮುಂಚೆ in the given complex chain, so which is the essential metal atom cobalt. Therefore, in this complex ion, the central metal atom is cobalt 10, which is in the F+3 state, which is in the F+3 oxide state. Okay. Hege, how do you get this one? The cobalt atom becomes cobalt 10 by loss of 3 electrons. So, therefore, it possesses the F+3 oxide. Cobalt atom becomes cobalt ion by loss of 3 electrons. That's why the cobalt metal ion is in this state. Okay. How to remove the electrons? 3 electrons. Okay. I want to represent the outermost, the outer is a copper metal atom. Sorry, cobalt metal atom. Okay. So the outer electron configuration is in the electron configuration of cobalt in the ground state. The ground state is given by outermost. I can take again with respect to noble gas configuration. Noble gas configuration. Argano 18 next 3d7 4s2. ನೀವು ಎಕ್ಸಾಂಪಲ್ ಫಸ್ಟ್ ಆರ್ಗಾನ್ ಬರ್ಕೊಬಿಡಿ. ಆರ್ಗಾನ್ ಅಟಾಮಿಕ್ ನಂಬರ್ 18, can show 18 at the top. Next write 4s2. ಯಾಕಂದ್ರೆ ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಸ್ ಸಬ್ಶೆಲ್ ಫಿಲ್ ಆದ್ಮೇಲೆ the electrons goes to the d subshell. ಆ ಕಡೆಗೆ ಫಸ್ಟ್ ರೈಟ್ 4s2. ಅವಾಗ 18 2 20 ಆಯ್ತು. ಇಲ್ಲಿದ್ದು 7. You can show 7 for d. In such a you can remember in the exam. Okay. So argon 18, write 4s2. The remaining 7 goes to the d 3d. So this is the outer electron configuration of the cobalt metal atom in the ground state. ಈಗ that cobalt atom becomes cobalt 10 by loss of 3 electrons. Therefore, to remove 3 electrons from which? From where? ಇಲ್ಲಿಂದ 2. ಅಂದ್ರೆ we remove the electrons 2 from 4s orbital and 1 more from 3d. So ಇಲ್ಲಿಂದ electrons 2 ಆಗುತ್ತೆ, ಇಲ್ಲಿಂದ 1 ಆಗುತ್ತೆ. ಒಟ್ಟು 2 + 1 3. Okay. ಇಲ್ಲಿಂದ 2, ಇಲ್ಲಿಂದ 1 3 ಆಗುತ್ತೆ. So 3 remove ಆದ್ಮೇಲೆ the remaining, okay, therefore the remaining outer is of cobalt is given by, okay, therefore so the outer EC, ಅಂದ್ರೆ the outer electron configuration of cobalt ion is given by argano 18. So 3d ಎಷ್ಟು 7 1 ಮಿಕ್ಕಿದ್ದು 6, 3d 6 ಮತ್ತೆ 4s ಇಲ್ಲಿ 0. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ತೆಗೆದುಬಿಟ್ವಿ, ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರಲ್ಲ, ಆ ಕಡೆಗೆ ಎಷ್ಟು 0. So this is the outer electron configuration of the cobalt 10, the given complex chain. I can take this one. It is important for next step. Okay. So this point ಗೊತ್ತಿರಬೇಕು. These are the parts we know it, easily understand the next steps, okay, for the given complex chain. Okay. Therefore, The same thing can be written in the box diagram under the step 1. Okay. So you exam alli idella barkonಡ್ಮೇಲೆ what is shown, the step 1, step 2, step 3 can go like this. Okay. The exam you can write like this. Okay. Okay. To explain the type of hybridization, geometry and micro property for the given composition, I take some steps. In the first step, the first one step, okay. The outer electron configuration of cobalt ion is given in the box diagram. The box diagram as follows. As follows. ಬದಲವಲೆ helium cobalt ion. So we take only this part. We take the outermost, okay. D6 ಮತ್ತೆ 4s0, 3D6 ಅಂತ okay. ಐದು ಇನ್ನೊಂದು ಮತ್ತೆ ಇನ್ನೊಂದು 6. So it contains in the 3D ನಲ್ಲಿ how many electrons? 6. Okay. Okay. Next 4s. ಇದು 4s orbital. 4s ಅಲ್ಲಿ ಇಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, 4s ಇರೋದ್ರೆ ಇಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ನೆಕ್ಸ್ಟ್ ಯಾವುದು? 4p. Okay, we can represent like this. In order to show the outer electron configuration of cobalt ion in the box diagram, we can show the arrangement of electrons by putting brackets at the box type. Therefore, you can take like this. Okay, so this is the arrangement of electrons in the box diagram that can shown by like this. Okay. Next step ಅಲ್ಲಿ step 2. Study in the given complex compound, the ligand is amine. We know that ligand is a two type. Here amine act as a strong ligand. Ligand ಅಲ್ಲಿ ಎರಡು ತರ ಇರುತ್ತೆ, ಒಂದು weak ligand ಮತ್ತೆ ಇನ್ನೊಂದು strong ligand. But ಈ complex compound ಅಲ್ಲಿ amine act as a strong ligand. According to one of the that is the point with respect to unity theory, in the presence of in the presence of strong ligand, whatever the unpaired electrons of the metal atom, forcibly they get pair up. That pairing is against to unsol. Therefore, the electrons idu ಇಲ್ಲಿ jump ಆಗುತ್ತೆ, ಇದು ಇಲ್ಲಿ jump ಆಗುತ್ತೆ. Therefore, the resultant EC of cobalt ion is given. ನಾನು ಇಲ್ಲಿ ಬರ್ತೀನಿ. I can show the the pair of electrons take place in the same diagram. Okay, ಇಲ್ಲಿದ್ದಂತ ಎರಡು electrons ಇಲ್ಲೊಂದು ಬಂತು, ಇಲ್ಲೊಂದು ಬಂತು. So this is the arrangement of electrons take place when the strong ligand is moved towards the metal atom, ಅಥವಾ in the presence of a strong ligand, whatever the unpaired electrons in the metal ion are forcibly get paired up. Therefore, we get this type of the arrangement of electrons take place. Therefore, the resultant E sub cobalt 10 is put like this. In the second step of it. Okay. So this is the diagram comes under the second step. Okay. I can pass on third step. ಈಗ ಇಲ್ಲಿ ಡಿ ನಲ್ಲಿ 2 ವೇಕೆಂಟ್ ಮತ್ತೆ ಎಸ್ ಅಲ್ಲಿ 1 ವೇಕೆಂಟ್ ಆರ್ಬಿಟಲ್ ಮತ್ತೆ ಪಿ ನಲ್ಲಿ 3 ವೇಕೆಂಟ್ ಆರ್ಬಿಟಲ್ 1 2 3. ಯಾಕೆ ತಗೊಂಡೆ ಅಂದ್ರೆ ನೋಡಿ, there are 6 ligands or bonded to metal ion. Therefore, the 6 ligands can donate a electron pair to the vacant orbital of the 2 3d and 1 4s and 3 4p. Therefore, the vacant, next step ಹೇಳ್ತೀನಿ, the vacant, the empty we call the vacant or empty, okay, of 2 3d orbital, we call 2 d orbital, next to 1 4s 1 s orbital and 3 p orbital. Okay, so 2 d orbital, 1 s orbital ಮತ್ತೆ 3 p orbital undergoes the process called as a hybridization. Undergoes the process called as a hybridization to give what is ornate to give d2 2 d ಮತ್ತೆ 1 s ಮತ್ತೆ 3 p to give d2 sp3 hybrid orbital to give ಎಷ್ಟಾಗುತ್ತೆ ಒಟ್ಟಿಗೆ 2 1 3 ಮತ್ತೆ 3 3 6 ಒಟ್ಟು 6 to give 6 d2 sp3 hybrid orbitals. Okay, therefore the vacant 2 d orbital 1 s and 3 p orbital undergoes the process called hybridization to give 6 d2 sp3 hybrid orbital. I want to show like this. Agile ಬರ್ತೀನಿ. It is the diagram in third step. D2 sp3 hybridization to give sp3 addition ಆಗುತ್ತೆ. ಇದು ಹಾಗೆ to give 6 d2 sp3 hybrid orbital are obtained. So the 6 d2 sp3 hybrid orbital which are similar in the energy and also in the same shape. All the 6 d2 sp3 orbitals are the same energy and same shape. Okay. So these are occupied the position in space at 6 corners of the octagon. Okay. 6 points ಅಲ್ಲಿ ಈ d2 sp3 orbital occupy ಮಾಡ್ತೀವಿ. Okay. So this is the third step diagram. Okay. Then fourth step ತಗೊಂಡಾಗ okay, the vacant 2 d ಮತ್ತೆ 1 s ಮತ್ತೆ 3 p, the vacant 6 ಒಟ್ಟು ಎಷ್ಟಿದೆ ಒಟ್ಟು 6 2 3 4 5 6 ಒಟ್ಟು ಎಷ್ಟು 6. Therefore the 6 vacant d2 sp3 hybrid orbital are occupied by the 6 electron pairs given by the donated by the 6 ligands. ಅಂದ್ರೆ ಇಲ್ಲಿ ligands have amine molecules. Amine molecules are capable of donating the 6 electron pair to the vacant the 6 d2 sp3 hybrid orbital. In other words, the 6 d2 sp3 hybrid orbital are occupied by the 6 electron pair given by the 6 amine ligands to form the 6 covalent bonds. ಇದರ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಕೋಬಾಲ್ಟ್ ಗೆ. ಇದನ್ನ amine molecule, 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 ಇದು molecule. Okay. Therefore, so So each ligand can donate a electron pair. Therefore, the 6 ligands can donate 6 electron pairs. Therefore, the resultant electron configuration of cobalt-10 is given like this. I can show like this. Okay. I can take the fourth diagram in the next same one. We called as the D2sp3 hybrid orbitals. Okay. Okay. The 6 D2sp3 hybrid orbitals are occupied by the 6 electron pair given by the 6 ligands. Okay. Ready? In order to show the electrons coming from the ligands, I can put a pair of endomorph. Okay. Ready? ಇಲ್ಲಿ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರು, ಇಲ್ಲೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರು, ಇಲ್ಲೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರು, ಇಲ್ಲಿ ಒಟ್ಟು 6 electron pair given by the 6 ligands. Okay. To represent the electrons brought by the ligands by putting a pair of endomorph, which indicates the electron pair given by the ligands. ಇವು ಈ ತರ ಬರೋದ್ರಂದ್ರೆ whatever the upward arrow mark, whatever the downward arrow mark indicates the electron pair in the metal ion itself. ಅಂದ್ರೆ ಇದಕ್ಕೆ ಬರ್ದಿರೋದೆಲ್ಲ electrons present in the metal ion. ಈ ತರ ಬರ್ಕೊಳ್ಳೋದೆಲ್ಲ electrons brought by the ligands. Therefore, in order to differentiate the electrons present in the metal ion and electrons coming from the ligands, I can take like this. So this is the actual arrangement of electron in the metal ion in the complex. ಈ ಕೊಟ್ಟರ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಈ ಮೆಟಲ್ ಗೆ ಈ ತರ ಇರುತ್ತೆ ಅರೇಂಜ್ಮೆಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ವಿಬಿಟಿ ಥಿಯರಿ. Therefore, so this is the actual arrangement of electrons of the metal atom, the metal ion in this complex compound. Okay. This is 4-step diagram. And one day diagram is bardiddini, but in exam alli you can write all the 4 diagrams. First step barkodu. Okay. The last point bandu, ಐದನೇ ಪಾಯಿಂಟ್ ಬಂದು okay, ಐದನೇ ಪಾಯಿಂಟ್ ಬಂದು last point. Fifth point, last point. Okay. So since the complex possess that is the type of hybridization, so D2sp3 andre if since the complex possess the type of hybridization is D2sp3, therefore this complex of the shape of the complex is found to be octahedral. Okay. So is due to the shape is found to be octahedral. Point. The last point, this complex compound do not contain any unpaired electrons. Therefore, this complex possesses the which property? Main property? Parent property. Parametric property. ಯಾವುದೇ ಒಂದು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲ, ಆ ಕಾರಣಕ್ಕೆ this complex compound ಬೇಸ್ ಟೇಕ್ a parametric property. According to one of the point of UBT theory, the complex do not contain any unpaired electrons. Such complex compound based like a diamond property. Okay. If the complex compound do not contain any unpaired electrons, such complex compound based like a diamond property. ಅಂದ್ರೆ ಒಂದು ಅಥವಾ ಒಂದಕ್ಕಿಂತ ಹೆಚ್ಚು unpaired ಇದ್ರೆ such complex compound acts as a parent property. But ಈ ಕೇಸಲ್ಲಿ ಯಾವುದೇ unpaired electrons ಇಲ್ಲ, ಆ ಕಾರಣಕ್ಕೆ this complex compound based like a which property, namely diamond property. If we summarize all the 3 points by putting at last report on the barbittu, we can write the 3 points like this in the exam. Okay. Exam ಅಲ್ಲಿ last ಅಲ್ಲಿ ಬರಬೇಕು important points ಅಂತ. We can write important points ಅಂತ. That is easy to evaluate by the evaluation. Okay. By the evaluator. First point. Type of hybridization. You know, it's called as a D2sp3. Second bandu ಜಾಮಿಟ್ರಿ ಅಥವಾ ಶೇಪ್, ಜಾಮಿಟ್ರಿ ಅಥವಾ ಶೇಪ್ ಬಂದು ಆಕ್ಟಾಹೆಡ್ರಲ್, ಆಕ್ಟಾಹೆಡ್ರಲ್. ಲಾಸ್ಟ್ ಪಾಯಿಂಟ್ ಬಂದು ಮ್ಯಾಗ್ನಿ ಪ್ರಾಪರ್ಟಿ, ಬಂದು ಓಕೆ. ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್ ಬರೆದ್ರೆ ಸಾಕು, ಈಸಿಲಿ ವ್ಯಾಲ್ಯೂ ಬೈ ದ ಲೆಟರ್ ಟು ಗಿವ್ ಫುಲ್ ಮಾರ್ಕ್. ಇದಕ್ಕೊಂದು ಮಾರ್ಕು, ಇದಕ್ಕೊಂದು ಮಾರ್ಕು, ಇದಕ್ಕೊಂದು ಮಾರ್ಕು. ಇಫ್ ಯು ರೈಟ್ ದ ಪಾಯಿಂಟ್ಸ್ ಅಟ್ end, you can write like this. Okay, time is over. I will take the next example tomorrow. Okay, thank you and all.
Good afternoon, students. ಕೆಲವರು ಬರ್ತಾ ಇದ್ದಾರೆ ಅಟೆಂಡೆನ್ಸ್ ಇದನ್ನ ಅಸೈನ್ಮೆಂಟ್ ಸಬ್ಮಿಟ್ ಮಾಡೋದಕ್ಕೆ ಎಲ್ಲ ಒಟ್ಟಿಗೆ ಒಂದು ಟ್ಯಾಗ್ ಮಾಡ್ಕೊಂಡ್ ಬಂದ್ಬಿಡಿ. ಫಸ್ಟ್ ಅಸೈನ್ಮೆಂಟ್ಸ್ ಎಲ್ಲ ಒಂದ್ ಕಡೆ, ಸೆಕೆಂಡ್ ಅಸೈನ್ಮೆಂಟ್ಸ್ ಎಲ್ಲ ಒಂದ್ ಕಡೆ. ಒಂದೊಂದು ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಒಂದೊಂದು ಹೇಳಿದೆ. ಈಗ ಸಪೋಸ್ 2A1ಗೆ ಕನ್ನಡ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಹೇಳಿದೆ, ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ಗೆ 2N ಸೆಕ್ಷನ್ ಅವ್ರು ಎಲ್ಲರೂ ಬಂದ್ಬಿಟ್ಟು ಕೊಡಬೇಕು. ಅಲ್ಲಿ ಒಬ್ರು ಕನ್ಸರ್ನ್ ಟೀಚರ್ ಇರ್ತಾರೆ, ಅವ್ರ ಹತ್ರ ಕೊಟ್ಟು ಸೈನ್ ಮಾಡಿಬಿಟ್ಟು ಹೋಗ್ಬೇಕು. ರೈಟ್? ದಟ್ ಇನ್ಫಾರ್ಮೇಶನ್ ವಿಲ್ ಕಂಟಿನ್ಯೂ ದ ಪ್ರಾಬ್ಲಮ್ಸ್. ಬೇಗ ಲಾಗಿನ್ ಆಗಬೇಕು. ನಿಮ್ಮ ನೆಟ್ ಅವೈಲಬಿಲಿಟಿ ನೋಡಿಕೊಂಡು ಬೇಗ ಲಾಗಿನ್ ಆಗಿ. ಯು ವಿಲ್ ಕಂಟಿನ್ಯೂ ದ ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡ್ಕೊತಾ ಇದ್ರೆ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. ಐ ಹೋಪ್ ಯು ಆರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಇಟ್. ಏನಾದರೂ ಗೊತ್ತಾಗದೇ ಇದ್ರೆ ಡೋಂಟ್ ಹೆಸಿಟೇಟ್ ಟು ಮೆಸೇಜ್ ಮಾಡಿ, ವಾಟ್ಸಪ್ ಮಾಡಿ. ಸೊ ದಟ್ ಇಫ್ ಟೈಮ್ ಪರ್ಮಿಟ್ಸ್ ನೋಡೋಣ ಸಾಲ್ವ್ ಮಾಡೋದಕ್ಕೆ ಅಲ್ಲಿ ವಿಲ್ ಡಿಸೈಡ್ ಇಟ್. I had given a problem 2 to the power of cos square x homework ಕೊಟ್ಟಿದ್ದೆ ನಿಮಗೆ. I hope you have solved it. We'll continue the problems ಅನ್ನು ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಹಾಗೆ ಪ್ರತಿದಿನ ಡಿಫರೆನ್ಷಿಯಬಿಲಿಟಿ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳು ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ ಯು ಹ್ಯಾವ್ ಟು ಗೋ ಥ್ರೂ ದ ಫಾರ್ಮುಲಾ ಲಿಸ್ಟ್. ರೈಟ್? ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾ ಹೋಗಿ. ಹಾಗೆ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಕಂಟಿನ್ಯೂ ಮಾಡಿ. ಕಂಟಿನ್ಯೂ ದ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್, ದ 15th one. Cos cube root x. Okay, observe here. I will be explaining it. One problem nodi gottagbidutte nimge. What is the thing we have to do anta? The first thing here is itara kottirtare, differentiate cos cube root x with respect to x. That will be the framing of a question, right? ನೀವು what you have to do, let y is equal to cos cube of root x. Here two functions have been combined, composition of two functions ಇದೆ. So differentiation, observe here, dy by dx, ಆಮೇಲೆ ಬರ್ಕೊಳ್ಳಿ dy by dx cos cube x ಗೆ f of x whole to the power of n ಕಾನ್ಸೆಪ್ಟ್ ಅಪ್ಲೈ ಮಾಡ್ಕೋಬೇಕು. So n into f of x whole to the power of n minus 1 into d by dx of cos of root x. Oh, here function 3 times ಆಗುತ್ತೆ ಇಲ್ಲಿ. ಇವಾಗ ನೋಡಿ, 3 into cos square root x into differentiation of cos of root x. It is wherever minus appears, always you have to use brackets here. Minus of sin of root x into differentiation of root x. ಒಟ್ಟಿಗೆ ಬರ್ದಿದ್ದೀನಿ 1 by 2 root x. That is a differentiation. I repeat once again, cos cube root x ಅಂದ್ರೆ f of x whole to the power of n ಇದ್ದಾಗೆ. f of x whole to the power of n ಅನ್ನ ಹೇಗೆ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ತೀವಿ? It is n into f of x whole to the power of n minus 1 into f dash of x. So similarly, n andre 3 value, 3 into f of x whole to the power of n minus 1 andre 3 minus 1, it becomes 2. So 3 into cos square root x into differentiation of cos square root x over. It is only differentiation of cos root x. You know that ಇದನ್ನ ಹಾಗೆ ಇಟ್ಕೊಳ್ತೀರಾ. cos root x ಗೆ it is minus of sin root x into root x differentiation is 1 divided by 2 into root x. You can combine this and write, itara ನೀವು combine ಮಾಡಿ ಬರಿಬಹುದು ಅಷ್ಟೇನೆ. Minus 3 by root x into cos square root x into sin of root x ಅಂತ you can conclude it. Okay, I hope it is clear for you. Fine, any doubt you can ask me. Any doubt, you can ask me here. Sumit Bharadwaj, first step. ಪ್ರತಿದಿನ ಫಾರ್ಮುಲಾ ಓದಬೇಕು ಅಂತ ನಾನು ಹೇಳ್ತೇನೆ ಇದೀನಿ. ಫಾರ್ಮುಲಾ ಓದಲ್ಲ, ಬ್ಲೈಂಡ್ ಆಗಿ ಕೂತ್ಕೊಂಡ್ರೆ ಏನು ಗೊತ್ತಾಗಲ್ಲ. It is of the formula ಬರ್ದಿದ್ದೀನಿ. ರೂಲ್ಸ್ ಅಂಡ್ ರೆಗ್ಯುಲೇಷನ್ ಟು ಸಾಲ್ವ್ ಕಾಂಪೋಸಿಟ್ ಫಂಕ್ಷನ್. ಸುಮಿತ್ ಭಾರದ್ವಾಜ್ ಅಂಡ್ ಅದರ್ಸ್ ಎಲ್ರಿಗೂ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಈ ಫಾರ್ಮುಲಾಗಳಿದೆ, ರೂಲ್. ಆ ರೂಲ್ ನ ಓದ್ಬೇಕು ನೀವು. ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಹೋಲ್ ಟು ದಿ ಪವರ್ ಆಫ್ ಎನ್ ಅಂದ್ರೆ ಎನ್ ಇಂಟು ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಹೋಲ್ ಟು ದಿ ಪವರ್ ಆಫ್ ಎನ್ ಮೈನಸ್ 1 ಇಂಟು ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಆಫ್ ದಿಸ್ ಟರ್ಮ್. ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಎಕ್ಸ್ ಅಂತೀವಿ, ಅಥವಾ ಡಿ ವೈ ಬೈ ಡಿ ಎಕ್ಸ್ ಅಥವಾ ಡಿ ಬೈ ಡಿ ಎಕ್ಸ್ ಆಫ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್. ಈ ರೂಲ್ನ ನಾವೇನು ಬರ್ದಿದ್ದೀವಿ ಅದನ್ನು ಈ ಪ್ರಾಬ್ಲಮ್ಗೆ ಅಡಾಪ್ಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ನೋಡಿ, ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಕಾಸ್ ರೂಟ್ ಎಕ್ಸ್ ಹೋಲ್ ಕ್ಯೂಬ್ ಅಂತ ಇದು. ಕಾಸ್ ಕ್ಯೂಬ್ ರೂಟ್ ಎಕ್ಸ್ ಅಂದ್ರೆ ದಿಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಸಿ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಹಿಯರ್ ಇಟ್ ಈಸ್ ಕಾಸ್ ಆಫ್ ರೂಟ್ ಎಕ್ಸ್ ಹೋಲ್ ಕ್ಯೂಬ್ ಇದ್ದಾಗಿದೆ. ದಿಸ್ ನಥಿಂಗ್ ಬಟ್ ಕಾಸ್ ಕ್ಯೂಬ್ ರೂಟ್ ಎಕ್ಸ್. ಓಕೆ, ಸೊ ಕಾಸ್ ದಿಸ್ ಇಸ್ ಆಫ್ ದಿ ಫಾರ್ಮ್. ನೋಡಿ, ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆಯಾ, ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಹೋಲ್ ಟು ದಿ ಪವರ್ ಆಫ್ ಎನ್. ಇದಕ್ಕೆ ಏನಾಗುತ್ತೆ ಅವಾಗ 3 ಇಂಟು ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಹೋಲ್ ಟು ದಿ ಪವರ್ ಆಫ್ ಎನ್ ಮೈನಸ್ 1. 3 ಇಂಟು ಕಾಸ್ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಎಕ್ಸ್ 3 minus 1 is 2 into differentiation of cos root x. Differentiation of cos root x is minus of sin root x into differentiation of root x is 1 by root 2. ಈ ರೂಲ್ ನ ನೀವು ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ತಾ ಇದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಡಿಫಿಕಲ್ಟ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಸಚ್ ಟೈಪ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್. ಆ ರೂಲ್ ನ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ಹೇಗೆ ಎಲ್ಲಿ ಅಡಾಪ್ಟ್ ಮಾಡ್ಕೋಬೇಕು, ಹೌ ಮೆನಿ ಟೈಮ್ಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್. ಮತ್ತೆ 1/2 ರೂಟ್ ಎಕ್ಸ್ ನ ಎಕ್ಸ್ ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬಾರ್ದು, ರೈಟ್? ಇಷ್ಟು ಮಾತ್ರ ಬರೆದು ನೀವು ಯು ಶುಡ್ ಸ್ಟಾಪ್ ಇಟ್ ದೇರ್ ಇಟ್ ಸೆಲ್ಫ್. ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದಿ ಹೌ ಮೆನಿ ಫಂಕ್ಷನ್ಸ್ ಹ್ಯಾವ್ ಬೀನ್ ಕಂಬೈನ್ಡ್, ಕಾಂಪೋಸಿಷನ್ ಆಫ್ ಫಂಕ್ಷನ್ ಬಗ್ಗೆ ನೀವು ತಿಳ್ಕೊಂಡಿರ್ಬೇಕು. ಅವಾಗ ಈ ಫಾರ್ಮುಲಾ ಅಡಾಪ್ಟ್ ಮಾಡಿಕೊಂಡು ಇದನ್ನ ಟ್ರೈ ಮಾಡಿದೀವಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಒನ್. ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎಕ್ಸ್ ಅಂತ ಇದೆ. ಅಬ್ಸರ್ವ್ ಹಿಯರ್, ನೋಡಿ, ವೆರಿ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಪ್ರಾಬ್ಲಮ್. ಎಕ್ಸಾಮಿನೇಷನ್ ಕೇಳೋದಕ್ಕೆ ಧೈರ್ಯ ಪಡ್ತಾ ಇಲ್ಲ. See, modulus function, it is very much familiar to you. You have studied about that definition, function, domain, range, graph, ಅದರ ಬಗ್ಗೆ ಎಲ್ಲ ಓದಿದ್ದೀರಾ. ಸೊ ಅದನ್ನ ಇಲ್ಲಿ if you recall it, y is equal to modulus of x. See, if it is plus x, it is plus x when it is x is greater than 0, it is minus x when x is less than 0, and it is equal to 0 when x is equal to 0. During relation and function chapter ಅಲ್ಲಿ ಅದನ್ನ ಓದಿದಿರ. ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎಕ್ಸ್ ಈ ತರ ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ಪ್ಲಸ್ ಎಕ್ಸ್ ವೆನ್ ಎಕ್ಸ್ ಇಸ್ ಗ್ರೇಟರ್ ದನ್ 0, ಮೈನಸ್ ಎಕ್ಸ್ ವೆನ್ ಎಕ್ಸ್ ಇಸ್ ಲೆಸ್ ದನ್ ಇಟ್ ಇಸ್ 0 ಈಕ್ವಲ್ ಟು. ಸೊ ಮಾಡ್ಯುಲಸ್ ನ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ ಎಕ್ಸ್ ಬರುತ್ತೆ ಅನ್ನೋ ಐಡಿಯಾ ಕಾನ್ಸೆಪ್ಟ್ ನಿಮ್ ತಲೆಯಲ್ಲಿ ಇದೆ. ವಿ ವಿಲ್ ಯೂಸ್ ದಟ್ ಒನ್. ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ ಎಕ್ಸ್ ಯಾವಾಗ ಬರುತ್ತೆ? ಇವಾಗ ಸೇ ಸಪೋಸ್ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ 2 ಯಾವಾಗ ಬರುತ್ತೆ ನೋಡಿ, ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ 4 ಅಂತ ಬರೆದ್ರೆ ಬರುತ್ತಬೋದಲ್ವಾ? ಸಿ, ಇಫ್ ಐ ರೈಟ್ ದಿಸ್ ರೂಟ್ ಆಫ್ 4 is plus or minus 2 ಬರೀಬೋದಾ? ಸೊ ಹಾಗಿದ್ರೆ ರೂಟ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಏನಾಗುತ್ತೆ ರೀ? ರೂಟ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್. ಸೊ ದಿಸ್ ಈಸ್ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ ಎಕ್ಸ್. ಸೊ this can be written as root of x square ಅಂತ ಬರೆಯಬಹುದು, right? Now you have to differentiate this one, dy by dx. Observe here carefully, dy by dx, root of f of x. If this is the function, what is the rule which we have to follow? It is 1 divided by 2 into root of f of x into differentiation of the term present inside the square root. It is nothing but f dash of x, right? It is nothing but f dash of x. So using this rule of differentiation, we'll apply that to this problem. It is 1 divided by 2 into root of x square into f of x. ಅಂದ್ರೆ ಆ radical sign ಒಳಗಡೆ ಇರೋದನ್ನ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಇಲ್ಲಿ ಅದರೊಳಗಡೆ ಏನಿದೆ ಇಲ್ಲಿ, this we have x square, differentiation of x square, or else if I want you can write it another step, differentiation of x square ಅಂತ ಬರಿತಾ ಇದೀನಿ. So this is equal to 1 divided by 2 into root of x square into differentiation of x square is 2x. Now 2 and 2 can be cancelled. Observe here with utmost concentration. So what remains? X divided by root of x square ಅಂತ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. So this is nothing but x divided by root of x square, once again can be written as modulus of x. So dy by dx. If y is equal to modulus of x, its derivative is x divided by modulus of x. That's a derivative. 1 mark ಗೆ ನಾವು ಅಸೈನ್ಮೆಂಟ್ ಗಳಲ್ಲಿ ಟೆಸ್ಟ್ ಗಳಲ್ಲಿ ಕೇಳ್ತಾ ಇರ್ತೀವಿ. ಫೈನಲ್ ಎಕ್ಸಾಮಿನೇಷನ್ ಅಲ್ಲಿ ಇದುವರೆಗೂ ಕೇಳಿದೆ ಪ್ರಾಬ್ಲಮ್. ಇಟ್ ಇಸ್ ಕ್ವೈಟ್ ಇಂಟ್ರೆಸ್ಟಿಂಗ್. ಮೇಕ್ ಎ ನೋಟ್ ಆಫ್ ಇಟ್. ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದ್ರೆ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್ ಮೀ. ಪ್ರತಿಯೊಂದು ಪ್ರಾಬ್ಲಮ್ ಲರ್ನಿಂಗ್ ಟೈಪ್ ಇರುತ್ತೆ. ಸೊ ಕೇರ್ಫುಲಿ ಅಬ್ಸರ್ವ್ ಹಿಯರ್. ಏನಾದ್ರು ಗೊತ್ತಾಗ್ತಿದ್ರೆ ಕೇಳಿ. ಮೈನಸ್ ಇಲ್ವಲ್ಲ ಜೀವನ್? ವೇರ್ ಡು ಯು ಹ್ಯಾವ್ ಮೈನಸ್ ಇನ್ ದ ಬ್ರಾಕೆಟ್? ವಿ ಹ್ಯಾವ್ ನಾಟ್ ಯೂಸ್ ಮೈನಸ್ ಎನಿವೇರ್. ಯಾವ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಏನ್ ಕನ್ಫ್ಯೂಷನ್ ಆಗ್ತಿದೆ ಕೇಳಿ. Second step, it is differentiation of x square, Pradeep. G1, what is that? Minus differentiation of x square. Root x ಗೆ ಫಾರ್ಮುಲಾ ಗೊತ್ತಿರಬೇಕು. ಫಾರ್ಮುಲಾ ಬೈ ಹ್ಯಾಟ್ ಮಾಡ್ತಾ ಇದ್ರೆ ನೀವು ನನ್ನ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಕೂತ್ಕೊಳ್ಳೋದಕ್ಕೆ ಪ್ರಯೋಜನ ಇಲ್ಲ. ಕೂತ್ಕೊಂಡ್ರು ಫಾರ್ಮುಲಾ ಬೈ ಹ್ಯಾಟ್ ಮಾಡಬೇಕು. ಡೆರಿವೇಟಿವ್ ಆಫ್ ರೂಟ್ ಎಕ್ಸ್ ಇಸ್ 1/2 ರೂಟ್ ಎಕ್ಸ್. ಸೊ ಇಟ್ ಇಸ್ ಇದು ರೂಟ್ ಎಕ್ಸ್ ಅನ್ಕೊಳ್ಳಿ. 1/2 ಇಂಟು ರೂಟ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಇಂಟು ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಬರ್ದಿದ್ದೀವಿ. ಇದರ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ 2x. 2 and 2 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಎಕ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ರೂಟ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಎಕ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಇದರ ಇನ್ನೊಂದು ಫಾರ್ಮ್ ಬರ್ದಿದ್ದೀವಿ ಅಷ್ಟೇ. ಇಟ್ ಈಸ್ ರೂಟ್ ಆಫ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎಕ್ಸ್. ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ಗೆ ಹೆಲ್ಪ್ ಆಗೋದಕ್ಕೋಸ್ಕರ ಬರ್ದಿದ್ದೀವಿ. ರೈಟ್? ಎನಿ ಮೋರ್ ಡೌಟ್? ಸುಮ್ಮನೆ ಕಾಪಿ ಮಾಡ್ಕೋಬಿಡಿ, ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೇನೆ ಯು ಕ್ಯಾನ್ ಎಂಜಾಯ್. ಅದರ್ವೈಸ್ it will be, you will find it difficult. Okay, move on to the next problem. If you have understood it, secant of tan of root x. More number of problems solve ಮಾಡಿದ್ರೆ ನಿಮಗೆ you get a good grip over the concept, composition function ಬಗ್ಗೆ, ಕಾನ್ಸೆಪ್ಟ್ ಬಗ್ಗೆ ಚೆನ್ನಾಗಿ ತಿಳ್ಕೊಂತೀರಾ. ಓಕೆ, ಅಬ್ಸರ್ವ್ ಹಿಯರ್. ಬರ್ಕೊಳ್ಳೋಕೆ ಹೋಗ್ಬೇಡಿ. ನೋಡಿ ಆಮೇಲೆ ಟೈಮ್ ಕೊಡ್ತೀನಿ ಬರ್ಕೊಳ್ಳೋದಕ್ಕೆ. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ನೋಟ್ಸ್ ಹಾಗೆ ಆಮೇಲೆ ಬಂದೇ ಬರುತ್ತೆ. Secant of tan of root x. Secant of tan of root x. See how many functions have been combined. Secant function, tan function, root x is another function. So carefully we have to differentiate. Let us assume that y is equal to secant of tan of root x. ಒಂದೇ ಸ್ಟೆಪ್ ನಲ್ಲಿ ಬರೀಬಹುದು ಇದನ್ನ. ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ಹೇಳ್ತಾ ಹೋಗ್ತೀರಿ. ಅಬ್ಸರ್ವ್ ವಿತ್ ಕೀನ್ ಇಂಟ್ರೆಸ್ಟ್. See dy by dx. Treat this as secant function. Secant of x ಅಂತ ಇದೆ ಅನ್ಕೊಳ್ಳಿ. Secant theta ಅಂತ. Secant theta ಅಂದ್ರೆ ಅದರ derivative it is secant theta into tan theta. So keeping that in mind, secant of tan root x into tan of tan root x. See just what I have written. Secant theta derivative, ಇದು theta ಅನ್ಕೊಂಡ್ರೆ secant theta derivative is secant theta into tan theta into d by dx of f of x ಅಂದ್ರೆ ಇದು f of x ಅಥವಾ ಇದು d by dx of derivative of tan root x. This is first step. Then retain the first two terms. Secant of tan of root x ಹಾಗೆ ಇಟ್ಕೊಳ್ಳಿ. Tan of tan root x ಹಾಗೆ ಇಟ್ಕೊಳ್ಳಿ into d by dx of tan root x. ಇವಾಗ ಇದನ್ನ tan theta ಅಂತ ಅನ್ಕೊಳ್ಳಿ. root x ನ tan theta ಗೆ differentiation is secant square theta. So using that one it becomes secant square root x into d by dx of this root x. ಈ ಟರ್ಮ್ f of x ಆಗುತ್ತೆ ಅವಾಗ ಅದು. ಸೊ ಇದರ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್. ಓಕೆ, ಇದನ್ನ ಕಂಬೈನ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಬಿಕಾಸ್ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಡಿಫರೆಂಟ್ ಫಂಕ್ಷನ್, ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಡಿಫರೆಂಟ್ ಫಂಕ್ಷನ್. ಯು ಹ್ಯಾವ್ ಟು ರಿಟೈನ್ ದಿಸ್ ಆಸ್ ಇಟ್ ಈಸ್. secant of tan root x into tan of tan root x into secant square root x into differentiation of root x is 1/2 root x. This is the final. This step and you direct again without writing these two steps you can write. It is allowed. Marks will not be deleted for these two because it is a 1 mark column if it is given, right? Usually it's length iral 1 mark kodala, but kotrunu that is not for 1 mark. Usually composite functions ಅಲ್ಲಿ 1 mark ಗೆ ಪ್ರಿಫರ್ ಮಾಡ್ತಾರೆ. ಆದಷ್ಟು ಸಿಂಪಲ್ ಆಗಿರೋದು ಕೊಡ್ತಾರೆ. But we have to learn the differentiation. ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದೆಯಾ ಕೇಳಿ. Any doubt you can. Okay, Jeevan, right? Next. Attendance is compulsory. Every period attendance ಅಂತ ತಗೊಳ್ತೀವಿ. ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದಿ ಪರ್ಸೆಂಟೇಜ್ ಆಫ್ ವ್ಯೂಯಿಂಗ್ ದ ವಿಡಿಯೋ ಅಥವಾ ನೀವೇನು ವಾಚ್ ಮಾಡ್ತಿದ್ರೋ ಅದಕ್ಕೆ ನಮ್ಮ ಪರ್ಸೆಂಟೇಜ್ ವೈಸ್ ಬರುತ್ತೆ. All the 4 periods attendance, it is important because shortage of attendance that will be uploaded for the board. Yeah, doubts idya? What is that? How do see ಹೌ ಮೆನಿ ಫಂಕ್ಷನ್ಸ್ ರೂಟ್ ಎಕ್ಸ್ ನ ಯಾವಾಗಲೂ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ತಪ್ಪು ಪಾಲ್ಗೊಳ್ಳಿ. ಇಲ್ಲಿ secant ಫಂಕ್ಷನ್ ಒಂದು, tan ಫಂಕ್ಷನ್ ಒಂದು, ರೂಟ್ ಎಕ್ಸ್ ಒಂದು ಫಂಕ್ಷನ್. ಸೊ 3 ಫಂಕ್ಷನ್ಸ್ ಹ್ಯಾವ್ ಬೀನ್ ಕಂಬೈನ್ಡ್. ಸೊ 3 ಸ್ಟೆಪ್ಸ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು ಆ ಥರ. ಇಟ್ಸ್ ನಾಟ್ ದಟ್ ರೂಟ್ ಎಕ್ಸ್ ಇದೆ ಅಲ್ಲಿ ಕಾಸ್ ಎಕ್ಸ್ ಇದೆ ಅಂತ ಅಲ್ಲ. ಹೌ ಮೆನಿ ಫಂಕ್ಷನ್ಸ್ ಹ್ಯಾವ್ ಬೀನ್ ಕಂಬೈನ್ಡ್, ದೇ ಹ್ಯಾವ್ ಕಂಪೋಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ತಗೋಬೇಕಾದ್ರೆ ಎಷ್ಟು ಫಂಕ್ಷನ್ಸ್ ಇದೆ? 3 ಫಂಕ್ಷನ್ಸ್ ಇದೆ. ಸೊ ಒಂದ್ಸಲ ಮಾಡಿಕೊಂಡಿದೀವಿ, ಆಮೇಲೆ ಎರಡನೇ ಸಲ ಥರ್ಡ್. ಸೊ ದಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಹೌ ಮೆನಿ ಫಂಕ್ಷನ್ಸ್ ಹ್ಯಾವ್ ಬೀನ್ ಕಂಬೈನ್ಡ್. ರೈಟ್? ಇನ್ನೇನೋ ಡೌಟ್ಸ್ ಇದೆಯಾ? ಇಲ್ಲಿರುವಂಥದ್ದನ್ನೇ ಟ್ಯಾನ್ ರೂಟ್ ಎಕ್ಸ್ಗೆ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಸೆಕೆಂಡ್ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಎಕ್ಸ್. ಈ ಸ್ಟೆಪ್ಸ್ಗಳೆಲ್ಲ ಬರೀಬೇಕಾಗಿಲ್ಲ, ಇದನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೀಬಹುದು. ಇಫ್ ಯು ಆರ್ ವೆಲ್ ವರ್ಸ್ ವಿತ್ ದಿ ಸಬ್ಜೆಕ್ಟ್, ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಾಗಿದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೀಬಹುದು ಇದನ್ನ. ಓಕೆ, ವಿಲ್ ಮೂವ್ ಆನ್ ಟು ದಿ ನೆಕ್ಸ್ಟ್ ಒನ್. ವೈ ನೆಕ್ಸ್ಟ್ ಫಂಕ್ಷನ್ ಈಸ್ ರೂಟ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎ ಸ್ಕ್ವೇರ್. ಈಗ ಯಾರು ಆನ್ಸರ್ಗಳು ಟೈಪ್ ಮಾಡೋದಕ್ಕಾಗಲ್ಲ, ಬಿಕಾಸ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ನೊಟೇಷನ್ಸ್ ಅಲ್ಲಿ ಟೈಪ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಅಬ್ಸರ್ವ್ ಹಿಯರ್. See, y is equal to root of x square plus a square. Differentiation, root x ಗೆ ಹೇಗೆ ನಾವು ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಮಾಡ್ಕೊಳ್ತೀವಿ? 1/2 root x. ಫಸ್ಟ್ ಅದನ್ನ ಅಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಳಿ. Here, how many functions have been composed? First product of how many functions? Root of f of x ಅಂದ್ರೆ ಒಂದು, f of x ಇನ್ನೊಂದು ಫಂಕ್ಷನ್ ಆಗುತ್ತೆ. ರೈಟ್? ಸೊ ಎರಡು ಫಂಕ್ಷನ್ ಇದೆ, ಎರಡು ಸಲ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು, ಅದು ಒಂದ್ಸಲ ಇರಲಿ. ಸೊ ದಿಸ್ ಈಸ್ ಡೆರಿವೇಟಿವ್ ಆಫ್ ದಿಸ್ ಈಸ್ 1/2 into root of x square plus a square into derivative of the term present inside the square root. Square root ಒಳಗಡೆ ಏನೇನು ಟರ್ಮ್ಸ್ ಇದೆಯೋ ಅದನ್ನೆಲ್ಲ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು. root of x square plus a square. I hope you are clear. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ರೂಟ್ ಆಫ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ 1/2 into root of f of x into differentiation of the term present inside the square root ಒಳಗಡೆ ಇರೋದನ್ನ ಇವಾಗ ಮತ್ತೆ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ 1/2 into root of x square plus a square into differentiation of x square is 2x, differentiation of a square is 0 because it is constant. Now this 2 and 2 can be cancelled. What is left out? ಏನು ಉಳ್ಕೊಳ್ಳುತ್ತೆ? ಸಿಂಪ್ಲಿಫೈಡ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೀಬೇಕು. x divided by root of x square plus a square. That's a final dy by dx. dy by dx ಅಂತ ಬರೀದೇ ಇದ್ರೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ನಲ್ಲಿ ನೀವು ಯಾವ್ದಾದ್ರು ಒಂದು ಸ್ಟೆಪ್ ನಲ್ಲಿ ಆದ್ರೆ ಇದು ಎಂಟೈರ್ ಥಿಂಗ್ ವಿಲ್ ಬಿ 0. ರಿಮೆಂಬರ್, ಡೆರಿವೇಟಿವ್ ಕಂಡುಹಿಡಿತಾ ಇದೀವಿ, ನೀವು ಬರೀಲೇಬೇಕು dy by dx ಅಂತ. ಕ್ವಿಕ್, ಆದಷ್ಟು ಫಾಸ್ಟ್ ಆಗಿ ಬರ್ಕೊಳ್ಳಿ. ಇವತ್ತು ಇದನ್ನ ಕಂಪ್ಲೀಟ್ ಮಾಡಿ. If time permits, we'll go to the next method. ಒಂದು ಹೋಮ್ ವರ್ಕ್ ತಗೊಳ್ಳಿ. dy root of 3x plus 2 ಇದೇ ತರನೇ. It is root of 3x plus 2 is for homework. Next one, 20th. Root of tan x. ನೋಡಿ ಹೇಳ್ಕೊಡ್ತೀನಿ. Root of tan x. That's a problem given. dy by dx. It is of the form root of f of x. ಪ್ರತಿ ಸಲ ರೂಲ್ ನ ಹೇಳ್ಕೋಬಾರ್ದು. ಒಂದ್ಸಲ ನೀವು ಕ್ಲಾಸ್ ಸ್ಟಾರ್ಟ್ ಆಗೋದಕ್ಕಿಂತ ಮುಂಚೆ ಫಾರ್ಮುಲಾ ಲಿಸ್ಟ್, ದೆನ್ ದ ರೂಲ್ಸ್ ಅಂಡ್ ರೆಗ್ಯುಲೇಷನ್ಸ್ ವಿಚ್ ಹ್ಯಾವ್ ಟು ಬಿ ಫಾಲೋಡ್, ಅದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ. ರೂಟ್ ಆಫ್ tan x ಅಂತಂದ್ರೆ ಇಟ್ ಈಸ್ 1/, ರೂಟ್ ಎಕ್ಸ್ ಗೆ 1/2 ರೂಟ್ ಎಕ್ಸ್, 1/2 into root x ಅಂದ್ರೆ ರೂಟ್ ಆಫ್ tan x into differentiation of the term present inside the square root. That means it is d by dx of tan x. Derivative of tan x you have to find. It is 1/2 into root of tan x into differentiation of tan x is secant square x. That itself is the answer. Just we are writing in the standard form. Secant square x into divided by 2 into root of tan x is the answer, right? I hope you are understanding the concept. Any doubt there? X into, what is that, Harsha? X divided by root of x square minus a square. Which one? ಯಾವ problem ರೀ ಅದು? For the homework problem. Homework problem ga? Okay, leave it. Nodi, next problem. 1 by root of 2x square plus 4. I repeat the problem. It is 1 divided by root of 2x square plus 4. 2x square plus 4. Square plus 4. ಇದನ್ನ ಬರ್ಕೊಳ್ಬೇಕಾದ್ರೆ ನಾವು ಪ್ರಾಬ್ಲಮ್ ನ ಈ ತರ ಬರ್ಕೊಂಡ್ಬಿಡ್ತೀವಿ. ಇಟ್ ಈಸ್ 2x square plus 4 whole to the power of minus half. This can be written as 1 divided by 2x square plus 4 whole to the power of half ಅಂತ ಬರೀಬಹುದು. That we have taken according to law of indices, that we have taken, and that is to the power of minus half. Now it is in the form of f of x whole to the power of n. So the formula, the rule says that it is n into 2x square plus 4 whole to the power of n minus 1. ನೋಡಿ minus half minus 1 ಅಂತಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ? minus 3 by 2. I hope it is clear. minus 3 by 2. ಗೊತ್ತಾಗ್ತಿಲ್ವಾ ಅಲ್ಲಿ ಬರ್ದಿರೋದು? minus 3 by 2 into d by dx of this term 2x square plus 4. Now this is equal to minus 1 by 2 minus n minus 1. ಇದರಿಂದ minus 3 by 2 ಬಂದಿದೆ. It is 2x square plus 4 whole to the power of minus 3 by 2 into differentiation of 2x square ಅಂದ್ರೆ 2 is constant. Differentiation of x square is 2x. It becomes 4x plus 0. Now, this 2 and 4 can be cancelled. What is left out? It is minus 2x into 2x square plus 4 whole to the power of minus 3 by 2. ಅದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಈ ತರ ಬರೀಬಹುದು ಅಥವಾ ಡಿವೈಡೆಡ್ ಬೈ ಅಂತ ತಗೊಂಡ್ರೆ ಡಿನಾಮಿನೇಟರ್ ಬರುತ್ತೆ. You can stop here itself, or you can write at the most 2x square plus 4 whole to the power of 3 by 2. This is the final dy by dx of the given problem, 1 divided by root of 2x square plus 4. ಏನಾದರೂ ಎಲ್ಲ ಸೈಲೆಂಟ್ ಆಗೋಗ್ಬಿಟ್ಟಿದ್ದೀರಾ? ಪ್ರಾಬ್ಲಮ್ ಕಷ್ಟ ಅನ್ಸ್ತಿದ್ಯಾ? ಆರ್ ಯು ಫಾಲೋಯಿಂಗ್? ಕಷ್ಟ ಆಗ್ತಿದ್ಯಾ? ಆರ್ ಯು ಫಾಲೋಯಿಂಗ್? ಆರ್ ಯು ಫಾಲೋಯಿಂಗ್? ರೈಟ್. ಡೋಂಟ್ ಹೆಸಿಟೇಟ್. ಏನೋ ಡೌಟ್ಸ್ ಇದ್ರೆ ಕೇಳಿ, ಹೌ ಎವರ್ ಸಿಂಪಲ್ ಇಟ್ ಈಸ್. ಕೇಳೋದಕ್ಕಿಂತ ಮುಂಚೆ ಒಂದ್ಸಲ ಫಾರ್ಮುಲಾ ಲಿಸ್ಟ್ ನೋಡಿ. ನಿಮ್ಗೆ ಇನ್ನೂ ಗೊತ್ತಾಗ್ಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಕೇಳಬಹುದು. ಓಕೆ, ಫೈನ್. ಬರ್ಕೊಳ್ಳಿ, ಬೇಗ ಬರ್ಕೊಳ್ಳಿ, ಬರೀಬೇಕು. ಸುಮ್ಮನೆ ಆಮೇಲೆ ನೋಟ್ಸ್ ಬರುತ್ತೆ, ಆಮೇಲೆ ಕಾಪಿ ಮಾಡ್ಕೊಳಕ್ ಹೋಗ್ಬೇಡಿ. ಕಾಪಿಂಗ್ ಅಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆ ನಿಮ್ಗೆ. ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅಲ್ಲಿ ನೋಡಿದೀವಿ ಬಹಳಷ್ಟು ಜನ ಇನ್ಫಿನಿಟಿ ಬರೆಯಕ್ ಬಂದಿಲ್ಲ, ಎಷ್ಟೋ ಜನಕ್ಕೆ 0 0 ಅಂತ ಬರ್ದಿದ್ದೀರಾ, ಯಾಕೆಂದ್ರೆ ಯಾವತ್ತೂ ಬರ್ದಿಲ್ಲ ಅನ್ನೋ ತರ. ಸೊ ದಟ್ ಶುಡ್ ನಾಟ್ ಬಿ ದ ಕೇಸ್. Whenever the problem is solved, try to solve it there at that moment itself. ಆಮೇಲೆ ಮಾಡೋಣ ಅಂತ ಬಿಡಬೇಡಿ. ನೋಡಿ ಇಲ್ಲೊಂದು ಈ ಪ್ರಾಬ್ಲಮ್ ಚೆನ್ನಾಗಿದೆ. ಇದು ಎಕ್ಸಾಮಿನೇಷನ್ಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಈ ಪ್ರಾಬ್ಲಮ್. ಇವಾಗ ನಾವು ನೆಕ್ಸ್ಟ್ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇರೋಂಥ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆಯಾ? ಐ ಹೋಪ್ ಇಟ್ ಇಸ್ ಕ್ಲಿಯರ್. ನೋ ಒನ್ ಹ್ಯಾಸ್ ಪೋಸ್ಟೆಡ್ ಎನಿ ಡೌಟ್ ದೇರ್. ಫೈನ್. root of tan x ಇತ್ತಲ್ಲ ಅದನ್ನೇ ಆಲ್ಟರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ ನೋಡಿ. root of tan of root x. Observe here, it is interesting. ನೀವು ಸಾಲ್ವ್ ಮಾಡಕ್ ಹೋಗ್ಬೇಡಿ. ನಿಮ್ಮ ಹತ್ರ ಸೊಲ್ಯೂಷನ್ ಬುಕ್ ಇದೆಯೋ ಕ್ವಶನ್ ಬ್ಯಾಂಕ್ ಇದೆಯೋ ಅದೆಲ್ಲ ಬೇಡ. ಪಾಠ ಮಾಡ್ಬೇಕಾದ್ರೆ ವಿತ್ keen interest you have to observe. Observe here. ನೋಡಿ ಏನು what's the difference between root of tan x, root of tan root x ಗೆ ಅಂತಂದ್ರೆ 1 divided by root of tan root x into differentiation of the term present inside the radical sign ಅಥವಾ square root ಕೆಳಗಡೆ ಇರುವಂತದ್ದು. So this becomes differentiation of tan of root x. Now 1 divided by 2 into tan of root x ಹಾಗೆ ಇರುತ್ತೆ. That will be retained as it is into tan of root x ಗೆ it is secant square root x. Secant square root x into d by dx of root x. Secant square root x into d by dx of root x. Here three functions, one the root of f of x into tan x ಇನ್ನೊಂದು root x. ಮೂರು ಫಂಕ್ಷನ್ ಇರೋದ್ರಿಂದ ಮೂರು ಸ್ಟೆಪ್ ಬರ್ತಾ ಇದೆ. So it is secant square root x into tan root x into root x derivative 1 by 2 root x. You can write this in the simplified form as secant square root x divided by 4 into root x into root of tan of root x. ನೋಡಿ root of tan x ಗುನು root of tan root x ಗೂ ಏನು ಡಿಫರೆನ್ಸಿಯೇಷನ್ ವ್ಯತ್ಯಾಸ ಅಂತ ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಗೊತ್ತಾಗಿದೆ. Write it down. Write it down. Don't mere copy it. Try to understand it. ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. ಪ್ರಾಬ್ಲಮ್ ಟೈಪ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ನೀವು ಸ್ಟೆಪ್ಸ್ ಅನ್ನ ಹೇಳಿ. ಫಸ್ಟ್ ಸ್ಟೆಪ್, ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್, ಥರ್ಡ್, ಫೋರ್ತ್ ಯಾವುದಾದ್ರೂ ಡೌಟ್ ಇದ್ರೂ ಕೇಳ್ಬೋದು. Okay. We are working out maximum number of problems so that you will be benefited. ನಿಮಗೆ ಬೆನಿಫಿಟ್ ಆಗಲಿ ಅಂತ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ವರ್ಕೌಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಟೆಕ್ಸ್ಟ್ ಬುಕ್ಸ್ ನಲ್ಲಿ ನೋಡಿ ಆಲ್ಮೋಸ್ಟ್ ಐ ಹ್ಯಾವ್ ಕವರ್ಡ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಫ್ರಮ್ exercise, worked example, then miscellaneous worked example, miscellaneous exercise, and few problems from exemplar also, so that ಸಬ್ಜೆಕ್ಟ್ ನಿಮಗೆ ಗೊತ್ತಾಗ್ಲಿ ಅನ್ನೋ ಒಂದು ದೃಷ್ಟಿಯಿಂದ ಸ್ವಲ್ಪ ಎಕ್ಸ್ಟ್ರಾ ಕ್ವಶನ್ಸ್ ಆಗುತ್ತೆ. ರೈಟ್, ಹೋಗ್ತಾ ಹೋಗ್ತಾ ನಾನು ಅದನ್ನ ಅಡಿಷನಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್, ಎಕ್ಸ್ಟ್ರಾ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಂತ ಕೊಡ್ತೀನಿ. ಇಫ್ ಯು ಆರ್ ಇಂಟ್ರೆಸ್ಟೆಡ್ ಯು ಕ್ಯಾನ್ ಸಾಲ್ವ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆನ್ ಎಕ್ಸಾಂಪಲರ್. ರೈಟ್, ಸೊಲ್ಯೂಷನ್ ಎಲ್ಲ ಕಡೆ ಎಲ್ಲ ಬುಕ್ಸ್ ಇದೆ, ಬಟ್ ಹೌ ಡು ಯು ಅರೈವ್ ಅಟ್ ದಟ್ ಸೊಲ್ಯೂಷನ್, ದಟ್ ಈಸ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂಡ್ ದಟ್ ಕೌಂಟ್ಸ್ ರಿಯಲಿ. ರೈಟ್, ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ ಹೋಮ್ವರ್ಕ್ ತಗೊಳ್ಳಿ ಇದನ್ನ. e to the power of root x. Root of e to the power of root x is homework problem. Root of e to the power of root x. Okay, next one, 24th one. 2 into root of cot of x square. Examination ಅಲ್ಲಿ 2 ಸಲ ಕೇಳಿದ್ದಾರೆ ಈ ಪ್ರಾಬ್ಲಮ್ ನ. 2 into root of cot of x square. Okay, observe here. 2 into root of cot of x square. ಟೆಕ್ಸ್ಟ್ ಬುಕ್ಸ್ ನ ಪಕ್ಕದಲ್ಲಿ ಇಟ್ಕೊಂಡ್ರಿ ನೀವು ವರ್ಕ್ ಮಾಡಬೇಕಾದ್ರೆ ಆಗ್ಲಿ, ಅವಾಗ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲಿ ನಾನು ಬರ್ದಿರೋದು ಗೊತ್ತಾಗದೇ ಇದ್ರು ಸಮ್ಟೈಮ್ಸ್ ದಿ ನೊಟೇಷನ್ಸ್, ಸಫಿಕ್ಸ್ ಪ್ರಿಫಿಕ್ಸ್ ಎಲ್ಲ ಬರ್ದಿರ್ತೀವಲ್ವಾ, ಸೂಪರ್ ಸ್ಕ್ರಿಪ್ಟ್ ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ ಅಲ್ಲ, ಸೂಪರ್ ಸ್ಕ್ರಿಪ್ಟ್ ಆಗಿದೆ, ಅದು ಇಲ್ಲಿ ದೊಡ್ಡದಾಗಿ ಬರೆಯೋದಕ್ಕಾಗಲ್ಲ. ಸೊ ಅವಾಗ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ನೀವು ನೋಡಿದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಈಸಿ ಫಾರ್ ಯು. ರೈಟ್, ನೆಕ್ಸ್ಟ್ 2 ಕಾನ್ಸ್ಟೆಂಟ್ ಹಾಗೆ ಇಟ್ಕೊಂಬಿಡಿ. ರೂಟ್ ಆಫ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಲ್ಲಿದೆ, 2 ಫಂಕ್ಷನ್, 3 ಫಂಕ್ಷನ್ ಆಗುತ್ತೆ. ಇದೊಂದು ಫಂಕ್ಷನ್, ಇಲ್ಲೊಂದು ಫಂಕ್ಷನ್, ಇಲ್ಲೊಂದು ಫಂಕ್ಷನ್, 3 ಫಂಕ್ಷನ್ ಕಂಬೈನ್ಡ್ ಆಗಿದೆ. ಸೊ 3 ಸ್ಟೆಪ್ಸ್ ಆಫ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಬರುತ್ತೆ. ಒಂದು 1 ಡಿವೈಡೆಡ್ ಬೈ ರೂಟ್ ಆಫ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಗೆ 2 ಇಂಟು ರೂಟ್ ಆಫ್ ಕಾಟ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್. ದಟ್ ಈಸ್ ಒನ್ ಥಿಂಗ್. ಓಕೆನಾ? into differentiation of cot of x square. Next 2 and 2 can be cancelled here. 1 divided by, observe carefully, ಆಮೇಲೆ ಬರ್ಕೊಳ್ಳೋದಕ್ಕೆ ಅವಸರ ಪಡಬೇಡಿ. Cot of x square into differentiation of cot of x square is, differentiation of this is minus cosecant square of x square into d by dx of x square. ಅಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಟರ್ಮ್ ಬರಲಿ, ಇಲ್ಲಿ ಒಂದು ರೂಟ್ ಆಗಾಯ್ತು, ಆಮೇಲೆ ಆ ರೂಟ್ ಒಳಗಡೆ ಇರುವಂತ ಟರ್ಮ್ಗೆ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ವಿ. ಕಾಟ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಇಸ್ ಮೈನಸ್ ಆಫ್ ಕೊಸಿಕೆಂಟ್ ಸ್ಕ್ವೇರ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಇಂಟು ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಮಾಡ್ಕೋಬೇಕು. ದಿಸ್ ಈಸ್ ಮೈನಸ್ ಕೊಸಿಕೆಂಟ್ ಸ್ಕ್ವೇರ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ into divided by cot of x square into differentiation of x square. You are familiar with that, it is 2x. That is the derivative of the given function, 2 into root of cot of x square. Manikanta, what is that bittiralla andre ಏನದು? ನೋಟ್ಸ್ ಇಲ್ಲಿದೆ ಇಲ್ಲ, ಬೋರ್ಡ್ ಮೇಲೆ ಇದೆ, ಬರಿಬೇಕು. ಆಮೇಲೆ ನಾವು ಅದನ್ನ ತರೋದಕ್ಕೆ ಹೇಳ್ತೀವಿ. ಬರಿಬೇಕು, ಕ್ಲಾಸಲ್ಲಿ ಬರ್ದಿರೋದು ಇಂಪಾರ್ಟೆಂಟು. ಪಾಠ ಮಾಡಬೇಕಾದ್ರೆ ಬರ್ಕೋಬೇಕು. ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಇದು, ಲ್ಯಾಂಗ್ವೇಜ್ ಕ್ಲಾಸ್ ಅಲ್ಲ, ಆರ್ ಬಯಾಲಜಿ ಕ್ಲಾಸ್ ಅಲ್ಲ. ನೋಟ್ಸನ್ನ ಕ್ಲಾಸಲ್ಲಿ ಬರಿತಾ ಇರೋದು ಮಾಡ್ತಾ ಇರೋದನ್ನ ಬರಿಬೇಕು. ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅವಾಗಲೇ ಕಲಿಯೋಕ್ಕಾಗೋದು. ಸುಮ್ಮನೆ ಯಾವಾಗಲೂ ಕಾಪಿ ಮಾಡೋಕ್ಕೆ, ಕಾಪಿ ರೈಟಿಂಗ್ ಅಲ್ಲ ಇದು. ಅಸೈನ್ಮೆಂಟ್ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗ್ತಿದೆಯಲ್ಲ ನಿಮ್ದು ಎಷ್ಟು ಒದ್ದಾಡ್ತಿದ್ರಿ ಬರೆಯೋದಕ್ಕೆ ಅಂತ. ಈಗಲೂ ಅಸೈನ್ಮೆಂಟ್ಗಳು ಶುರು ಮಾಡ್ಕೊಳ್ತೀವಿ ನೆಕ್ಸ್ಟ್ ಮಂತಲ್ಲಿ. In the month of September, we will be submitting the, we will be sending you the assignments. Same procedure. ಇವಾಗ ಹೇಗೆ ಮಾಡಿದ್ರೆ ಅದೇ ತರ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ಬೇಕು. ನೆಕ್ಸ್ಟ್ ಒನ್. Is that clear? Any doubt in the problem number 24? Tinosh? Hamsa? Dhrutan, are you in the class? Okay, fine. Next one will continue. It is root of x into secant x. Root of x into secant x. Observe here. See, in such case, ಹೇಗೆ ನಾವು ಸಾಲ್ವ್ ಮಾಡಬೇಕು? ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಇಟ್ ಇಸ್ ದ ಸೇಮ್ ಥಿಂಗ್, ಬಟ್ ಹಿಯರ್ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಟೂ ಫಂಕ್ಷನ್ಸ್ ಆರ್ ದೇರ್. ಪ್ರಾಡಕ್ಟ್ ರೂಲ್ ಎಕ್ಸ್ಟ್ರಾ ಅಪ್ಲೈ ಮಾಡ್ಕೊಳ್ತೀವಿ ಅಲ್ಲಿ. ಫಸ್ಟ್ dy by dx, ಇಟ್ ಈಸ್ ರೂಟ್ ಆಫ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಗೆ ಫಾರ್ಮುಲಾ ಏನು? 2 into root of f of x. f of x ಅಂದ್ರೆ x into secant x into differentiation of d by dx of x into secant x. x into secant. Okay, this is the rule which you have to adopt. Next, it is 1 divided by 2 into root of x into secant x into differentiation of x into secant x. x into, here product rule, first function and second function. First function into differentiation of second function is secant x ke differentiation ಏನು? secant x into tan x plus second function ಹಾಗೆ ಇಟ್ಕೊಳ್ಳಿ into differentiation of x ಅಂತಂದ್ರೆ 1. Is it fine? Now it is x into secant x into tan x plus secant x ಬೇಕಾದ್ರೆ ಕಾಮನ್ ತಗೋಬಹುದು, which cannot be cancelled. So ಹಾಗೆ ಇಟ್ಟಿದ್ದೀನಿ ನಾನು 2 into root of x into secant x. So this is the derivative of the function root of x into secant x. x into secant x tan x plus secant x divided by 2 into root of x into secant x. That's the derivative. These are the problems with related to root terms. Root ಆಗಿ ಇದ್ರೆ ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನ ಕಲ್ತ್ಕೊಂಡ್ವಿ. ಈಗ ನೆಕ್ಸ್ಟ್ ಲಾಗರಿಥಮಿಕ್ ಟರ್ಮ್ಸ್ ಬಂದ್ರೆ, ಹೌ ಟು ಫೈಂಡ್ ದ ಡೆರಿವೇಟಿವ್ ಆಫ್ ಲಾಗರಿಥಮಿಕ್ ಟರ್ಮ್ಸ್ ಇನ್ ಕಾಂಪೋಸಿಟ್ ಫಂಕ್ಷನ್ಸ್. ಆ ಕ್ಯಾಟಗರಿನಲ್ಲಿ ಏನೋ ಡೌಟ್ ಇದೆಯಾ ಕೇಳಿ. ಮನೋಜ್ ಡಿ ಎಸ್, ವಾಟ್ ಲೈನ್? ಲೈನ್ ಅಂತ ಏನೋ ಕಲ್ಸಿದ್ರಲ್ಲ, ಏನು? ಹರ್ಷ, ಥರ್ಡ್ ಸ್ಟೆಪ್. Okay, what is it, Manoj? Third line, third step. Okay, I hope this is the third step here. Notice y is equal to root of x into secant x, root of f of x. Root of f of x get 1 divided by 2 into root of f of x into derivative of this term x into secant x. ಇದನ್ನ derivative ಕಂಡುಹಿಡಿಯಬೇಕು. ಇದು ಪ್ರಾಡಕ್ಟ್ ರೂಲ್. ಇದನ್ನ ಹಾಗೆ ಇಟ್ಕೊಂಡಿದ್ದೀವಿ. We have retained as it is. We have not altered anything. ಏನು ಬೇಕಾಗಿಲ್ಲ, ಇದನ್ನು ಹಾಗೆ ಇಟ್ಕೋಬೇಕು. ಇದರ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಇದು ಏನಿದು? ದಿಸ್ ಈಸ್ ಒನ್ ಫಂಕ್ಷನ್, ದಿಸ್ ಈಸ್ ಅನದರ್ ಫಂಕ್ಷನ್. Two functions, product of two functions. First function into differentiation of second function, secant x ಗೆ secant x into tan x plus second function ಹಾಗೆ ಇಟ್ಕೊಳ್ಳಿ, differentiation of first function 1 ಬರುತ್ತೆ. ಸೊ x into secant x tan x plus secant x ಅದನ್ನ ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀವಿ. ಓಕೆ, ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಪವಿತ್ರ, ಮನೋಜ್ ಅಂಡ್ ಅದರ್ಸ್ ಥರ್ಡ್ ಸ್ಟೆಪ್ ಕೇಳಿದ್ರಿ. Is that clear? Product rule, product ಮತ್ತೆ ಫಾರ್ಮುಲಾಗಳು ಮರಿಬಾರ್ದು. Product rule. Fine. Okay. Good. Next one. Log of log x. Log of log x. Observe here, ನೋಡಿ, interesting one, but most of you commit mistakes here. ಸುಮ್ಮನೆ 1/x ಅಂತ ಬರ್ಬಿಡ್ತೀರಾ. It is not so. Log of log x ಅಂದ್ರೆ ಈ ತರ ಇದೆ. See, what is the derivative of log x according to the rules which we have mentioned? The derivative of this is 1 by, first log x ಏನಪ್ಪ ಬರಿತೀವಿ? 1/x ಅಲ್ವಾ? ಅದೇ ತರ 1/f of x. ಮತ್ತೆ ಡಿನಾಮಿನೇಟರ್ ಇರೋ ಟರ್ಮ್ ನ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು, f dash of x. ಈ ತರ ಮಾಡ್ಕೋಬೇಕು. That's a rule we have to follow while deriving logarithm of function in composite category. So log of log x andre 1 by log x into differentiation of log x into differentiation of log x. So this is equal to 1 by log x into log x differentiation is 1 by x. So that is itself is the answer. 1 by x into log x anta one order barita ideve ashte. That's the derivative. Can we solve the 25th problem according to the formula f of x whole to the power of n? Yes, you can solve. You can solve. It doesn't make it easier. Easy ಆಗಲ್ಲ, ಯಾಕೆಂದ್ರೆ to the power of half ಅಂದ್ರೆ ನೀವು half into whole to the power of half minus 1 ಅಂತ ಬರ್ಕೊಂಡು ಮತ್ತೆ you have to struggle. This is the best method for that one, Falguni. If you take up f of x whole to the power of n, it becomes complex because whole to the power of half will get. So that doesn't make easy. Fast ಆಗ್ತಾ ಇದೆಯಾ ನಿಮಗೆ? I hope you are following the speed. ನನ್ನ ಪ್ರಕಾರ ತುಂಬಾ ಸ್ಲೋ ಆಗ್ತಾ ಇದೆ. ಬಿಗಿನಿಂಗ್ ಆಗಿರೋದ್ರಿಂದ we are going slow. Log of root x is the next problem. Log of root x. Okay, observe here. ನೋಡಿ, ಬರ್ಕೊಳಕ್ ಹೋಗ್ಬೇಡಿ ಮಧ್ಯದಲ್ಲಿ, ಅವಾಗ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ನಿಮ್ಗೆ ಗೊತ್ತಾಗಲ್ಲ. ಬರೆಯೋದಕ್ಕೆ ಟೈಮ್ ಕೊಡ್ತೀನಿ ನೀವು ಕೇಳಿದ್ರೆ. Right? Log of root x explain ಮಾಡಬೇಕಾದ್ರೆ ನೋಡ್ಬಿಡ್ಬೇಕು. Log of root x according to the rules and regulations it is 1 by root x into denominator ಏನಿದೆಯೋ ಅದನ್ನು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿ into derivative of 1 by root x into derivative of root x. So this is equal to 1 by root x into derivative of root x is 1 by 2 root x. So now the simplification of this one is 1 divided by 2 into root x is x. So 1 by 2x is the derivative of log of root x. Carefully observe. Doubts idre keli. ನಮ್ಗೆಲ್ಲ ಈಸಿ ಆಗ್ಬೇಕಾಗಿರೋದು, ನಿಮ್ಗೆ ಈಸಿ ಆಗ್ಬೇಕಾಗಿರೋದು. Any doubt you can ask me. ಧನುಷ್, ಕ್ಲಾಸಲ್ಲೆಲ್ಲ ನಿದ್ದೆ ಮಾಡ್ತಿರ್ತೀನಪ್ಪ. ಧನುಷ್, ಕ್ಲಾಸಲ್ಲೆಲ್ಲ ನಿದ್ದೆ ಮಾಡ್ತಿದ್ಯಲ್ಲೋ? ಕಂಟಿನ್ಯೂಟಿ ಬಗ್ಗೆ ಈಗ ಕೇಳ್ತಿದ್ಯಲ್ಲೋ? 15th ಜುಲೈ ಹೇಳಿದೀವಿ, ಆಗಸ್ಟ್ ಬಂದ್ರೆ ಇವಾಗ ಎದ್ದಿದ್ಯಲ್ಲೋ? ಧನುಷ್, ಕ್ಲಾಸಿಗೆ ಬರ್ತಿರ್ಲಿಲ್ವಪ್ಪ? ಕಂಟಿನ್ಯೂಟಿ ಬಗ್ಗೆ ಈಗ ಕೇಳ್ತಾ ಇದೆಯಲ್ಲೋ? ಕ್ಲಾಸಲ್ಲಿ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಕೂತ್ಕೊಂಡ್ರೆ ಟೀಚರ್ ಹೇಳಿದ್ ಗೊತ್ತಾಗುತ್ತೆ. 2F to ಧನುಷ್. What is this Sanjana 23 ಅಂದ್ರೆ ಏನು? ಇವಾಗ ಗೆದ್ದಿದ್ದೇನಲ್ಲ ಧನುಷ್, ಕಂಟಿನ್ಯೂಟಿ ಈಗ ಗೆದ್ದಿದೆಯಲ್ಲೋ, ಕಂಟಿನ್ಯೂಟಿನೇ ಇಲ್ವಲ್ಲ ನಿನಗೆ ಓದೋದ್ರಲ್ಲಿ. ಸಂಚಯನ ವಾಟ್ ಇಸ್ ದಸ್ 23 ಅಂತ ಏನು ಟೈಪ್ ಮಾಡಿದಿರಲ್ಲ? ಎನಿ ಡೌಟ್ ಇನ್ ದ ಪ್ರಾಬ್ಲಮ್ 27? ಲಾಗ್ ಆಫ್ ರೂಟ್ ಎಕ್ಸ್ ಅಲ್ಲಿ ಏನೋ ಡೌಟ್ ಇದೆಯಾ ಕೇಳಿ. ಇಫ್ ನಾಟ್ ಐ ವಿಲ್ ಪ್ರೊಸೀಡ್. Fine. If there is no doubt, I will continue. Next, log of root of x ಬದಲು log of root of cos x ಬರ್ತಾ ಇದೆ ನೋಡಿ. Next problem, interesting one. ಇದು ಅಷ್ಟೇ ಸಿಂಪ್ಲಿಫೈ ಚೆನ್ನಾಗಿ ಈಸಿಯಾಗಿ ಮಾಡ್ಕೋಬಹುದು. The next one, 28th. Log of root of cos x. Log of root of cos x. Vikram, which problem? Second step. ಏನು ಇದೆ ಇದರಲ್ಲಿದೆ? What is there in this one? I am not convinced with your doubts. ಕ್ಲಾಸಲ್ಲಿ ಅರ್ಥ ಆಗ್ತಿಲ್ವಾ ನಿಮ್ಗೆ ಏನ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ನೀವು ಎಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ರೆ ಕಂಡುಬಿಡ್ತಾ ಇದ್ರೆ ಇಲ್ವೋ ಮಲ್ಕೊಂಡ್ಬಿಟ್ಟಿದ್ರೆ ಗೊತ್ತಾಗ್ತಿಲ್ಲ. ರೈಟ್, ಕಾಂಪ್ಲೆಕ್ಸ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಕೇಳಿಲ್ಲ. ರೂಟ್ ಗೊತ್ತಿಲ್ಲ ನಾನೇನು ಮಾಡೋಕ್ಕಾಗಲ್ಲ ರೀ. ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಅದನ್ನ ಫಾರ್ಮುಲಾ ಬಹ್ಯಾಟ್ ಮಾಡಿ ಫಾರ್ಮುಲಾ ಲಿಸ್ಟ್ ನ ಬರ್ಕೊಳ್ಳಿ. ನೀವು ಪ್ರಿಪೇರ್ ಆಗಿ ನಿಮ್ಮ ಮನಸ್ಸಿಗೆ ಬರಬೇಕು. ರೂಟ್ ಎಕ್ಸ್ ಅಂದ್ರೆ ಅದರ ಫಾರ್ಮುಲಾ ಏನು, ಲಾಗ್ ಆಫ್ ರೂಟ್ ಆಫ್ ಎಕ್ಸ್ ಅಂದ್ರೆ ಅದರ ಡೆರಿವೇಟಿವ್ ಹೇಗೆ, ರೂಲ್ಸ್ ಅಂಡ್ ರೆಗ್ಯುಲೇಷನ್ಸ್ ಅಲ್ಲಿ ಹೇಳಿದೀವಿ. ಬಿಗಿನಿಂಗ್ ಕ್ಲಾಸಸ್ ನೀವು ಅಟೆಂಡ್ ಆಗದೆ ಇದ್ರೆ ಆಮೇಲಿನ ಕ್ಲಾಸಸ್ ಅಲ್ಲಿ ಇಟ್ ವಿಲ್ ಬಿ ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಟು ಫಾಲೋ ಅಪ್. ನೋಡಿ ಇವಾಗ ಎದ್ದಿದ್ದೇನೆ ಒಬ್ಬ, ಕಂಟಿನ್ಯೂಟಿ ಚಾಪ್ಟರ್ ಮಾಡಲ್ವಾ ಸರ್ ಅಂತ ಇವಾಗ ಎದ್ದಿದ್ದಾನೆ ಧನುಷ್. ಎಸ್ ಎಸ್ ಚಂದನ್, ಎಸ್ ರೂಟ್ ಎಕ್ಸ್ ಎಲ್ವೇನ್ರಿ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡೋದು 1/2 ರೂಟ್ ಎಕ್ಸ್ ಬರುತ್ತೆ. ಇಲ್ಲಿ ಮತ್ತೆ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬಾರ್ದು. ಒನ್ಸ್ ಅಗೇನ್ ಯು ಶುಡ್ ನಾಟ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಇಟ್, ಓನ್ಲಿ ಒನ್ಸ್ ಯು ಹ್ಯಾವ್ ಟು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್. Tinosh is giving the answer for the 28th problem. Good, he is already giving the answer. Let me see the answer. What he has given is minus of tan x by 2. Fine. ನೋಡಿ ಆನ್ಸರ್ ಒಬ್ರು ಹೇಳ್ತಿದಾರಾಗ್ಲೇ, ಅದನ್ನ ಚೆಕ್ ಮಾಡ್ಕೋಣ. ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಟಿನೋಶ್. ಲಾಗ್ ಆಫ್ ರೂಟ್ ಆಫ್ ಕಾಸ್ ಎಕ್ಸ್ ಪ್ರತಿಯೊಂದು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲೂ ಕಲಿತಾ ಇರ್ತೀವಿ. ಅದಕ್ಕೆ ಪ್ರತಿಯೊಂದು ಪ್ರಾಬ್ಲಮ್ನು ಇಂಟ್ರೆಸ್ಟ್ ಇಟ್ಟು ಕಲ್ತ್ರೆ ಮಾತ್ರ ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಾಗೋದು. ಈ ತರ ರೂಟ್ ಎಕ್ಸ್ ನ ಇಲ್ಲಿ ಒಂದ್ಸಲ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ಮೇಲೆ ಮತ್ತೆ ರೂಟ್ ಎಕ್ಸ್ ಕಾಣಿಸ್ತು ಅಂತ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬಾರ್ದು. ದಟ್ ಇಸ್ ವೈ ಐ ಆಮ್ ಟೆಲ್ಲಿಂಗ್ ಯು ರೈಟ್ ಫ್ರಮ್ ದಿ ಬಿಗಿನಿಂಗ್ ಆಫ್ ಕಾಂಪೋಸಿಟ್ ಫಂಕ್ಷನ್. ಕಾಂಪೋಸಿಟ್ ಎಷ್ಟು ಕಾಂಪೋಸಿಟ್ ಆಗಿದೆ, ಎಷ್ಟು ಫಂಕ್ಷನ್ಸ್ ಕಂಬೈನ್ಡ್ ಆಗಿದೆ. ಇಲ್ಲಿ ನೋಡಿ ಎರಡೇ ಫಂಕ್ಷನ್ ಕಂಬೈನ್ಡ್ ಆಗಿರೋದು, ಒಂದು ಲಾಗ್ ಫಂಕ್ಷನ್, ಇನ್ನೊಂದು ರೂಟ್ ಎಕ್ಸ್ ಫಂಕ್ಷನ್. ಸೊ ಎರಡೇ ಸಲ ಸ್ಟೆಪ್, ಇಲ್ಲೊಂದ್ಸಲ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ವಿ, ಇಲ್ಲೊಂದ್ಸಲ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ವಿ. ಇದು ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಅಷ್ಟೇ. ಇನ್ನೊಂದ್ಸಲ ರೂಟ್ ಎಕ್ಸ್ ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬಾರ್ದು. ಐ ಮೇಕ್ ಇಟ್ ಕ್ಲಿಯರ್ ಇನ್ ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ಸ್ಟೆಪ್. ಸೈನ್ ಆಫ್ ರೂಟ್ ಎಕ್ಸ್. ಶಿವಕುಮಾರ್ ನೋಡಿ, ನೋ ದಟ್ಸ್ ನಾಟ್ ದಿ ಆನ್ಸರ್. ಲಾಗ್ ಆಫ್ ರೂಟ್ ಆಫ್ ಕಾಸ್ ಎಕ್ಸ್ 1/root of cos x into differentiation of root of cos. ನೋಡಿ ಇಲ್ಲಿ ಇದಕ್ಕೂ ಏನು ವ್ಯತ್ಯಾಸ ಇದೆ, ಇಲ್ಲಿ ಇದನ್ನು ಒಂದೇ ತರ ಅನ್ಸುತ್ತೆ ನಿಮ್ಗೆ, ಬಟ್ ಹಿಯರ್ 3 functions have been combined. ಹೇಗೆ ಸರ್, ಲಾಗರಿಥಮಿಕ್ ಒಂದು ಫಂಕ್ಷನ್, ರಾಡಿಕಲ್ ಸೈನ್ ಒಂದು ಫಂಕ್ಷನ್, ಕಾಸ್ ಎಕ್ಸ್ ಒಂದು ಫಂಕ್ಷನ್. ಬಟ್ ಇಲ್ಲಿ ಲಾಗ್ ಆಫ್ ರೂಟ್ ಎಕ್ಸ್ ಅಂತಂದ್ರೆ ಓನ್ಲಿ 2 ಫಂಕ್ಷನ್. ಎಕ್ಸ್ ಗೆ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ನೀವು ಒಂದೇ ಬರುತ್ತೆ, ಅದನ್ನ ಮಾಡಕ್ ಹೋಗ್ಬಾರ್ದು, ಅಷ್ಟೇ ಸಾಕು. ಇಲ್ಲಿ ಆದ್ರೆ 3 ಸ್ಟೆಪ್ಸ್ ಬರುತ್ತೆ. ಹೇಗೆ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ ಹೇಳಿದ್ವಿ ಈಗ, ಇಟ್ ಈಸ್ 1/root of cos x into differentiation of cos of root of cos x is 1/root of cos x into differentiation of cos x. ಅಲ್ಲಿಗೆ 3 ಸಲ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದಾಗ ಆಯ್ತಾ, ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ರಿಪೀಟೆಡ್ ಆಗಿ 3 times. ಇಲ್ಲಿ 3 functions have been combined. 3 steps of differentiation will arrive. 1/, observe the simplification here. 2 into 2 ಈ ಕಡೆಗೆ ಬರ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. ರೂಟ್ ಆಫ್ ಕಾಸ್ ಎಕ್ಸ್ ಇಂಟು ರೂಟ್ ಆಫ್ ಕಾಸ್ ಎಕ್ಸ್ ಎಷ್ಟಾಯ್ತಪ್ಪ, ಕಾಸ್ ಎಕ್ಸ್ ಆಯ್ತು. ಇಂಟು ಕಾಸ್ ಎಕ್ಸ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಇಸ್ ಮೈನಸ್ ಸೈನ್ ಎಕ್ಸ್. ಸೊ ದಿಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ ಸೈನ್ ಎಕ್ಸ್ ಬೈ ಕಾಸ್ ಎಕ್ಸ್ ಇಸ್ ಟ್ಯಾನ್ ಎಕ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ 2 ಇಸ್ ದಿ ಆನ್ಸರ್. ನೋಡಿ ಎಷ್ಟು ಬ್ಯೂಟಿಫುಲ್ ಆಗಿದೆ ಪ್ರಾಬ್ಲಮ್. ಕಂಟಿನ್ಯೂಟಿ ಪಾಠನೇ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಧನುಷ್ ನೋಟ್ಸ್ ಯಾಕ್ರಿ ಕೊಡ್ತೀರಾ? ಧನುಷ್ ಕಂಟಿನ್ಯೂಟಿ ಪಾಠ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ನೋಟ್ಸ್ ಬಗ್ಗೆ ಹೆಂಗೆ ಕೇಳ್ತೀರಾ? ಕಂಟಿನ್ಯೂಟಿ ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನೋಡಿ ಮಲಗಿರೋರ್ಗೆ, ಕಂಟಿನ್ಯೂಟಿ ಅಂಡ್ ಡಿಫ್ರೆನ್ಷಿಯಬಿಲಿಟಿ ಅಂತ ಚಾಪ್ಟರ್ ನೇಮು. ನಾವು ವಿ ಹ್ಯಾವ್ ಸ್ಟಾರ್ಟೆಡ್ ವಿತ್ ಡಿಫ್ರೆನ್ಷಿಯಬಿಲಿಟಿ, ಕಂಟಿನ್ಯೂಟಿ ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಮಾಡ್ತೀವಿ. ಹರ್ಷ ಜಿಇ ರೈಟ್ ಆನ್ಸರ್ tan x by 2. ಪಾಠನೇ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ನೋಟ್ಸ್ ಹೇಗೆ ಕೊಡ್ತೀಯಾ ಧನುಷ್? ಕಂಟಿನ್ಯೂಟಿದು ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಬರುತ್ತೆ, ಅದು ಒಂದು 4 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಬರುತ್ತೆ, ರೈಟ್? ನೋ ಪ್ರಾಬ್ಲಮ್, ಕಂಟಿನ್ಯೂ ಮಾಡಿ. ಈ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲಿ ಬರ್ಕೊಳ್ತಾ ಹೋಗು, ಕಂಟಿನ್ಯೂಟಿ ಬಗ್ಗೆ ಯೋಚನೆ ಮಾಡಬೇಡ ಜಾಸ್ತಿ. ಇದು ಕಂಟಿನ್ಯೂಟಿ ಇರಲಿ ಟಾಪಿಕ್ಗೆ. ಓಕೆ, ಲಾಗ್ ಆಫ್ ರೂಟ್ ಆಫ್ ಕಾಸ್ ಎಕ್ಸ್. ಬ್ಯೂಟಿಫುಲ್ ಸಿಂಪ್ಲಿಫೈಡ್ ಆನ್ಸರ್ ಮೈನಸ್ ಆಫ್ tan x by 2. ಹರ್ಷ ಜಿಗಿ ನೋಡಿ, ನೀವು ರಾಂಗ್ ಆನ್ಸರ್ ನಿಮ್ದು. ಮೈನಸ್ ಬರ್ದಿಲ್ಲ, ನೀವು ಬಿಟ್ಬಿಟ್ಟಿದ್ದೀರಾ. ಮೈನಸ್ ಬರುತ್ತೆ ಯಾಕೆಂದ್ರೆ ಕಾಸ್ ಎಕ್ಸ್ಗೆ ನೋಡಿ. ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಇಲ್ಲಿ 3 ಫಂಕ್ಷನ್ಸ್ ಕಂಬೈನ್ಡ್ ಆಗಿದೆ. ಒಂದು ಲಾಗರ್ಥಮಿಕ್ ಫಂಕ್ಷನ್, ಇನ್ನೊಂದು ರಾಡಿಕಲ್ ಸೈನ್ ಫಂಕ್ಷನ್, ಇನ್ನೊಂದು ಕಾಸ್ ಎಕ್ಸ್. ಸೊ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಇದು ಫಸ್ಟ್ ಸ್ಟೆಪ್, ಆಮೇಲೆ ಇಲ್ಲಿ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್, ಇದು ಥರ್ಡ್ ಸ್ಟೆಪ್ ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್ ಮಾಡಬಹುದು. ಸೊ ಹೌ ಮೆನಿ ಫಂಕ್ಷನ್ಸ್ ಕಂಬೈನ್ ಆಗಿದೆ ಅದನ್ನ ನೋಡ್ಕೊಂಡು ನೀವು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು. ಮತ್ತೆ ರೂಟ್ ಎಕ್ಸ್ ಎಲ್ಲಿದೆಯೋ ಅಥವಾ ಕಾಸ್ ಎಕ್ಸ್ ಎಲ್ಲಿದೆಯೋ. ಈಗ ಸೈನ್ ಎಕ್ಸ್ ಬಂತು, ನೀವು ಸೈನ್ ಎಕ್ಸ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಕಾಸ್ ಎಕ್ಸ್ ಬರುತ್ತೆ, ಕಾಸ್ ಎಕ್ಸ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಸೈನ್ ಎಕ್ಸ್ ಬರುತ್ತೆ. ನೀವು ಬದುಕಿರೋವರೆಗೂ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ಬೋದು, ಆ ಥರ ಅಲ್ಲ ಅದು. There are rules and regulations which has to be followed in composite function. Beginning ಅಲ್ಲಿ ಬರ್ದಿದ್ವಿ, ಅದನ್ನ ಕಾಂಪೋಸಿಟ್ ಫಂಕ್ಷನ್ ಮುಗಿಯೋವರೆಗೂ ನೋಡ್ಬೇಕು, ಓದ್ಬೇಕು. ಸುಮ್ಮನೆ ಬ್ಲೈಂಡ್ ಆಗಿ ಕ್ಲಾಸಲ್ಲಿ ಕೂತ್ಕೋಬಾರ್ದು. ಕೂತ್ಕೊಂಡ್ರೆ ತುಂಬಾ ಜಾಸ್ತಿ ಡೌಟ್ಸ್ ಬರುತ್ತೆ. ಯು ವಿಲ್ ನಾಟ್ ಬಿ ಏಬಲ್ ಟು ಗ್ರಾಫ್ ದಿ ಐಡಿಯಾ. ನೆಕ್ಸ್ಟ್ ಒನ್, 29th one. Yes, right, Harsha. Okay, typing error. Log of cos of e to the power of x. Next one, log of cos of e to the power of x. Okay, ನೋಡಿ ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಇನ್ನು ಇವಾಗ ಸ್ಟಿಲ್ ವಿ ಲರ್ನ್ ಇದೇ ತರನೇ ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದ್ವಲ್ಲ ಅದೇ ತರನೇ. ಅಬ್ಸರ್ವ್ ಹಿಯರ್, see here logarithmic function is 1, cosine function is 1, e power x. So 3 functions have been combined, composition of 3 functions. So now differentiate ಮಾಡಿದ್ರೆ first we will observe, will assume that it is y ಅಂತ ತಗೋಬಹುದು, ಅಥವಾ ನೀವು f of x ಅಂತ ತಗೋ. y ಅಂತ ಬಂದಿರೋದ್ರಿಂದ dy by dx ತಗೊಂಡಿದ್ದೀನಿ, f of x ಅಂತ ಬಂದ್ರೆ f dash of x ಅಂತ ಬರುತ್ತೆ. ಇದನ್ನ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಮಾಡೋಣ. 1 divided by cos of e power x ಆಯ್ತಾ ಫಸ್ಟ್ ಸ್ಟೆಪ್, into differentiation of the term present in the denominator, it is cos of e power x ಆಯ್ತಾ ಫಸ್ಟ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಲಾಗರಿಥಮಿಕ್ ಸಂಬಂಧಪಟ್ಟ ಹಾಗೆ. ನೆಕ್ಸ್ಟ್ cos of e power x ಗೆ ಸಂಬಂಧಪಟ್ಟ ಹಾಗೆ it is minus sin of e power x into differentiation of e power x. ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಆಯ್ತಾ. ನೆಕ್ಸ್ಟ್ ಮೈನಸ್ sin of e power x divided by cos of e power x ಅಂತಂದ್ರೆ tan of e power x, ಸಿಂಪ್ಲಿಫೈಡ್ ಮಾಡ್ಕೊತಾ ಇದೀನಿ, into derivative of e power x ಅಂದ್ರೆ e power x. ನೋಡಿ, this is the derivative. Logarithmic one function, cos one function, e power x. So 3 ಫಂಕ್ಷನ್ ಕಂಬೈನ್ಡ್ ಆಗಿದೆ. 3 ಫಂಕ್ಷನ್ ಕಂಬೈನ್ಡ್ ಆಗಿರೋದ್ರಿಂದ 3 ಸ್ಟೆಪ್ಸ್ ಅಲ್ಲಿ ನಾವು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ತೀವಿ. ಐ ಹೋಪ್ ಇಟ್ ಈಸ್ ಮೋರ್ ಕ್ಲಿಯರ್ ಫಾರ್ ಯು ಬೈ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್. ಈ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡೋದ್ರಿಂದ ನಿಮ್ಗೆ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. ಡೌಟ್ ಇದೆಯಾ ಕೇಳಿ. ಗೊತ್ತಾಯ್ತಾ ಇವಾಗ? ಆಲ್ ದಿ ಲೆವೆಲ್ಸ್ ಆಫ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್, ಎಷ್ಟು ಸಲ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು, ಮತ್ತೆ ಇಲ್ಲಿ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬಾರ್ದು. ನೋಡಿ, ಇ ಪವರ್ ಎಕ್ಸ್ ಬಂತಲ್ವಾ ಸರ್, ಇದನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು. ನೀವು ಇ ಪವರ್ ಎಕ್ಸ್ ಪ್ರಪಂಚ ಬದುಕಿರೋವರೆಗೂ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಇ ಪವರ್ ಎಕ್ಸ್ ಆಗೇ ಇರುತ್ತೆ. ಸೊ I hope it is clear. Okay, next problem nodi, beautiful problem. Say log of secant x plus tan x. Log of secant x plus tan x. ನೋಡಿ ಇದು ಎಷ್ಟು ಚೆನ್ನಾಗಿದೆ ಡಿಫರೆನ್ಸಿಯೇಷನ್ ಅಂದ್ರೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬಹುದು ಈ ಪ್ರಾಬ್ಲಮ್ ನ ನಾನು ನೆಕ್ಸ್ಟ್ ನಿಮಗೆ ಇಂಟಿಗ್ರೇಷನ್ ಅಲ್ಲಿ ಇದೇ ಪ್ರಾಬ್ಲಮ್ ನ ಐ ವಿಲ್ ಆಸ್ಕ್ ಯು ಒನ್ಸ್ ಅಗೇನ್ ಅಬ್ಸರ್ವ್ ಹಿಯರ್ ನೋಡಿ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಹಿಯರ್ ವೆರಿ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಒನ್ ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಲರ್ನ್ ಹಿಯರ್ ಓನ್ಲಿ ಟೂ ಫಂಕ್ಷನ್ಸ್ ಹ್ಯಾವ್ ಬೀನ್ ಕಂಪೋಸ್ಡ್ ಟೂ ಫಂಕ್ಷನ್ಸ್ ಕಂಬೈನ್ಡ್ ಆಗಿದೆ ಲಾಗರ್ಥಮಿಕ್ ಒಂದು ಫಂಕ್ಷನ್ secant x plus tan x ಒಂದೇ ಫಂಕ್ಷನ್ ಅದು ಎರಡು ಸೇರಿ ಸಮ್ ಆಫ್ ಟೂ ಫಂಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಸೊ ದಿಸ್ ಈಸ್ 1 divided by secant x plus tan x into differentiation of secant x plus tan x. Simplify ಮಾಡಿ ಆನ್ಸರ್ ಒಳ್ಳೆ ಆನ್ಸರ್ ಬರುತ್ತೆ ಇದರಲ್ಲಿ ಸಿಂಪಲ್ ಆನ್ಸರ್ ರೈಟ್ ಗೊತ್ತಾಗ್ತಿದೆಯಾ ಸೊ ಇಟ್ ಈಸ್ 1 by secant x plus tan x ಆನ್ಸರ್ ಗೊತ್ತಿದ್ರು ಒಂದ್ಸಲ ನೀವು ಡೆರಿವೇಟಿವ್ ನೋಡ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ ನಾವು ಸಮ್ ಆಫ್ ಟೂ ಫಂಕ್ಷನ್ಸ್ ಇದೆ ಇದನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ secant x ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಇದು secant x into tan x plus tan x differentiate ಮಾಡಿದ್ರೆ secant square x. But if you look at the numerator here, secant x is common here. Secant x is common, right? Dekha secant x is right answer. Secant x common ತಗೊಳ್ಳಿ. Secant x common ತಗೊಂಡ್ರೆ ಏನು ಉಳ್ಕೊಳ್ಳುತ್ತೆ tan x ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಒಂದು ಫಂಕ್ಷನ್ secant x ಕಾಮನ್ ತಗೊಂಡ್ರೆ ಇನ್ನೊಂದು secant x ಉಳ್ಕೊಳ್ಳುತ್ತೆ divided by secant x plus tan x. See, these two can be cancelled. These two can be cancelled. So, what is left out? Secant x ಉಳ್ಕೊಳ್ಳುತ್ತೆ. See, the simplified answer for this log of secant x plus tan x is secant x. Isn't it? A nice one. ಇದನ್ನ ನಾನು ಯಾಕೆ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ ಅಂತ ಅಂದ್ರೆ ಫಸ್ಟ್ ಬರ್ಕೊಂಬಿಡಿ ಹೇಳ್ತೀನಿ ಮೇಕ್ ಇಟ್ ಫಾಸ್ಟ್ ರೈಟ್ ಡೌನ್ ಇನ್ ನೋಟ್ಸ್ ಅಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ ನಿಮ್ಗೆ ಅವಾಗಲೇ ನಿಮ್ಗೆ ಗೊತ್ತಾಗೋದು ಕಾಪಿ ಮಾಡಬೇಡಿ ನಮ್ಮ ನೋಟ್ಸ್ ನ ಕಳಿಸ್ತೀವಲ್ಲ ಅದು ರೆಫರೆನ್ಸ್ಗೆ ಅಷ್ಟೇನೆ ಏನಾದರೂ ನಾವು ಬರ್ದಿರೋ ನೋಟೇಶನ್ಸ್ ಗೊತ್ತಾಗದೇ ಇದ್ರೆ ನೀವು ಇನ್ನೊಂದ್ಸಲ ಕ್ರಾಸ್ ಚೆಕ್ ಮಾಡೋಕ್ಕೆ ಈ ಪ್ರಾಬ್ಲಮ್ಸ್ ಎಲ್ಲ ರಫಲ್ಲಿ ಬರ್ಕೊಂಡು ಯು ಹ್ಯಾವ್ ಟು ವರ್ಕ್ ಇಟ್ ಔಟ್ ಅವಾಗಲೇ ನಿಮಗೆ ಸಬ್ಜೆಕ್ಟ್ ಗ್ರಿಪ್ ಸಿಗೋದು ಸುಮ್ಮನೆ ನಾನು ಬರ್ದಿರೋದನ್ನ ನೀವು ಬರ್ಕೊಂಡ್ರೆ ಅದರಿಂದ ಏನೂ ಪ್ರಯೋಜನ ಇಲ್ಲ See, what is the thing you have to remember about this problem ಅಂತ ಹೇಳಿದ್ರೆ in future ಇವಾಗ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಆಯಿತು ಇದಾದ್ಮೇಲೆ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಡೆರಿವೇಟಿವ್ಸ್ ಆಗುತ್ತೆ ಅದಾದ್ಮೇಲೆ ಇಂಟಿಗ್ರೇಷನ್ ಬರುತ್ತೆ in the beginning classes I told you that integration is inverse process of differentiation ಅಂದ್ರೆ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ತಿಳ್ಕೊಂಡ್ರೆ ಇಂಟಿಗ್ರೇಷನ್ ಈಸಿ ಆಗುತ್ತೆ ಅಂತ ಇವಾಗ ನೋಡಿ ಇಲ್ಲಿ y is equal to log of secant x plus tan x ಅಂತ ಇದೆ ಆಯ್ತಾ ಇದರ ಡೆರಿವೇಟಿವ್ ಈಗ ತಾನೇ ಡೆರೈವ್ ಮಾಡಿದೀವಿ dy by dx is equal to ಏನು ಬಂತು secant x ನೆಕ್ಸ್ಟ್ ಇಂಟಿಗ್ರೇಷನ್ ಏನ್ ಮಾಡ್ತೀವಿ ಗೊತ್ತಾ ಏನಂತ ಹೇಳ್ತಾ ಇರ್ತೀನಿ ನಾನು ಯಾವಾಗಲೂ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಚೆನ್ನಾಗಿ ಕಲ್ತ್ಕೊಳ್ಳಿ ಇಂಟಿಗ್ರೇಷನ್ ಈಸಿ ಆಗುತ್ತೆ ಅಂತ ಇಂಟಿಗ್ರೇಷನ್ ಅಂದ್ರೆ ಈ ತರ ಸಿಂಬಲ್ ಉಪಯೋಗಿಸ್ಕೊಳ್ತೀವಿ integration of secant x dx this is equal to log of secant x plus tan x this is the answer there alli integration idu symbol integration of secant x dx is log of secant x plus tan x andre illi idanna differentiate madidre ee answer barutte if you differentiate log of secant x plus tan x nodidire ಈಗ ತಾನೆ secant x ಬರುತ್ತೆ so integration is of secant x is log of secant x plus tan x. That is why I called it as integration as inverse process of differentiation. See, observe here. Integration of secant square x dx. ಯಾವುದನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಸೆಕೆಂಡ್ ಸ್ಕ್ವೇರ್ ಎಕ್ಸ್ ಬರುತ್ತೆ, tan x ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಸೆಕೆಂಡ್ ಸ್ಕ್ವೇರ್ ಎಕ್ಸ್ ಬರುತ್ತೆ. ಸೊ ಡೆರಿವೇಟಿವ್ ಆಫ್ tan x ಎಷ್ಟಪ್ಪ? ಸೆಕೆಂಡ್ ಸ್ಕ್ವೇರ್ ಎಕ್ಸ್. ಸೊ ದೇರ್ ಫೋರ್ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಸೆಕೆಂಡ್ ಸ್ಕ್ವೇರ್ ಎಕ್ಸ್ tan x. ದಟ್ ಇಸ್ ದ ಅಡ್ವಾಂಟೇಜ್ ಆಫ್ ಲರ್ನಿಂಗ್ ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್. ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್ ಕಲ್ತ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ಡೆಫಿನೆಟ್ ಆಗಿ ಇಂಟಿಗ್ರೇಷನ್ ಸುಲಭ ಆಗುತ್ತೆ. ಕಲಿದೇ ಇದ್ರೆ ಆಬ್ವಿಯಸ್ಲಿ ಅದಕ್ಕೊಂದು ಪ್ರಶ್ನೆ ಕೇಳ್ತಾನೆ, ಸರ್ ಕಲಿದೇ ಇದ್ರೆ ಏನಾಗುತ್ತೆ? ಕಲಿದೇ ಇದ್ರೆ ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್ ಬರಲ್ಲ, ಇಂಟಿಗ್ರೇಷನ್ ಬರಲ್ಲ. ಹಾಗೆ ಮಾಡ್ಕೊಳಕ್ ಹೋಗ್ಬೇಡಿ. ರೈಟ್. ವಿಲ್ ಕನ್ಕ್ಲೂಡ್ ಟುಡೇಸ್ ಕ್ಲಾಸ್ ಬೈ writing 2 homework problems. ಈ ಎರಡು ಹೋಮ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ನ ಟ್ರೈ ಮಾಡಿ. 31 and 32. Log of, quite interesting, x plus root of x square plus a square. ಇಲ್ಲೂ ಅಷ್ಟೇ ಚೆನ್ನಾಗಿ ಸಿಂಪ್ಲಿಫೈ ಆಗುತ್ತೆ, ಸಿಂಪಲ್ ಟರ್ಮ್ ಬರುತ್ತೆ, ನೋಡ್ಕೊಳ್ಳಿ. log of x plus root of x square plus a square. I repeat, log of x plus root of x square plus a square. Okay. Next, it is cos of tan of root x plus 1. These two are homework problems. Okay. I hope you enjoyed the differentiation of composite function. ಇನ್ನೊಂದು 2-3 ಪ್ರಾಬ್ಲಮ್ ಇದೆ. We'll conclude that, and I'll conclude today's class now. Thank you. Pass
ನಂದು ವೆಡ್ನೆಸ್ಡೇ ಕ್ಲಾಸ್ ಸ್ವಲ್ಪ ಆಫ್ ಆಗಿದೆ. Good afternoon, students. Let's start for the biology class. Okay, in the chapter called as reproduction in organisms, we have detailedly discussed with types of asexual reproduction and then sexual about the sexual reproduction. Okay. So the asexual reproduction takes place in plants is called as vegetative propagation, as well as we have also detailedly discussed about the vegetative types of vegetative propagation. Okay. So next we are going to discuss with the sexual reproduction. So sexual reproduction majorly involves three main events. Okay. The sexual reproduction in any of the living organism, whether it may be a plant, animals, or any living organism, it takes place in three events. So which are those events? Okay. So which is very common to all, each and every organism. Okay. So the sexual reproduction is mainly divided into three events. For events of sexual reproduction. Okay. So, which are these three events? First one, pre-fertilization event. Second one, fertilization event. Third one, post-fertilization event. Okay, so the events of entire total sexual reproduction is divided into how many types? Three events, which are those pre-fertilization event, fertilization event, and post-fertilization event. In sexual reproduction, its main process that is taking place is the fusion of gametes, isn't it? So, before the fusion of gametes, what are all the events that takes place during sexual reproduction will be discussed under the event called as pre-fertilization. Pre means what? Before. So, which process before? It is fertilization process before. Hence, it is called as what? Pre-fertilization event. Okay. Next, second one is what? Fertilization event. So, what do you mean by fertilization here? The process, how the fusion of male and female gametes takes place. Okay. So, that we are going to discuss on the fertilization event. And after the fertilization, the fusion of male and female gametes result in the formation of zygote. Zygote develops into embryo. Okay. All these processes are discussed under the event called as what? Post-fertilization event. Okay. So, the entire sexual reproduction is divided into how many events? Three. Pre-fertilization, before fertilization process. What are all the events that is taking place are discussed there. Fertilization, about the fusion of male and female gametes which result in the formation of zygote. And then post-fertilization includes development of zygote as well as the development of embryo. Clear? Okay, so these are all the events which involves in sexual reproduction. So what we have to do now, we have to discuss it in detail, each and every event. Okay, so what are all the things or the process that is taking place during pre-fertilization events and during post-fertilization events as well as during fertilization events. Okay, so let's start with the pre-fertilization events first. Pre-fertilization event is again classified into two sub-events, which are those. Very first one, gametogenesis. And the second one is gamete transfer. So these are the sub-events of pre-fertilization event. Okay. So fertilization means fusion of male and female. So whether they have to fuse means first they have to form, isn't it? So how the male and female gametes are forming, how the formed gametes are transferring. So that are all the events what we have to discuss under the pre-fertilization event, which includes two subtypes, which are those gametogenesis and gamete transfer. Okay, so that's why these two are the sub-events of pre-fertilization event. Okay, so let's start with the gametogenesis first. So what is gametogenesis then? Name only indicates, split the word into two parts. Genesis means to synthesize or produce. Okay, so what is synthesizing or producing here? Gametes. And name is having the definition, the process of production of or synthesis of gametes is called as what? Gametogenesis. Genesis means synthesis. Which is synthesizing here? Gametes is synthesizing. That's why the name gametogenesis. Okay, the process of formation of gametes is called as what? Gametogenesis. So, usually how many types of gametes are there? In sexual reproduction, we know that there is the two individuals of opposite sex involving in reproduction. That's why two different types of gametes are forming, which are those male gametes and female gametes. How many gametes are forming here? Two, which are those male gametes and female gametes. But in some of the algal members, these male and female gametes which are produced are not differentiated with each other. They are exactly similar to each other, to themselves. Okay. So hence there is no dissimilarity between the two different individual gametes formed by the two different individuals. Then such gametes are said to be what? Homogametes. What they are called as? Homogametes. Homo means what here? Same. Okay. What is same? The appearance of the gametes is so similar to each other so that they can't be able to differentiate it as a male and female gamete. Okay. So such gametes are said to be what? Homogametes. Homo means same. Same type of gametes are produced here. Male and female gametes are both are one and the same in the appearance. Okay. Such gametes are called as homogametes. Some of the algal members will produce such a type of homogametes during sexual reproduction. Okay. So whereas certain other organisms, especially human beings, higher mammals, will produce two different types of gametes. Means Male gametes are different in their appearance and female gametes are different in their appearance. So such gametes are said to be what? Heterogametes. Hetero meaning here different. Gametes means production of gametes. Okay. The former gametes are so similar in their appearance. Oh, sorry, different in their appearance. Then such gametes are said to be heterogametes. If they are very similar in their appearance, then they are said to be what? Homogametes. Okay. So, chlamydomonas, which produces similar type of gametes. Like this, both the gametes produced are exactly similar to one another. We can't able to differentiate it at all. Like, whereas in case of heterogametes, the male gametes are different and female gametes are different. So the male gametes is little bit larger in size when compared with the female gametes. The female gametes are little bit larger in size when compared with the male gametes. Okay, female gametes are larger in size than the male gametes, whereas male gametes are shorter in their appearance. Male gametes are shorter in their appearance. And one more difference what we can make out here is these are non-motile and these are motile. Male gametes are motile, female gametes are non-motile. Okay, production of such a type of gametes is said to be what? Heterogametes. Production of different types of gametes is called as what? Heterogametes. Okay, here the male gametes is called as what? This one, not this one. Male gametes is called as what? Antherozoid. Or it is also called as sperm. Okay, whereas the female gametes is called as what? Egg or ovum. Here this one, the male gametes are called as antherozoid or sperm. What are antherozoids? 1 mark question or an CET question. Okay, so antherozoids means anta kodtare. ಆಯ್ತಾ, ಇಲ್ಲಿ ಆಪ್ಷನ್ಸ್ ನ ಡಿಫರೆಂಟ್ ಆಗಿ ಹೇಳ್ತಾರೆ. ಸೊ ಮೊಟೈಲ್ ಸ್ಮಾಲ್ gametes or motile small male gametes, female gametes, like this different options will be given for you, but the correct answer is motile small male gametes. Okay, next, female is the called as what? Female gametes are called as what? Commonly called as egg or ovum, which is larger in size and produces, they are non-motile. They can't able to move from place to place. Okay, so then how the egg will be moving from fallopian tube to the ovary to fallopian tube, isn't it? So the doubt will arise. Here there is a special type of cells called as ciliated columnar epithelium cells. Okay, so this will push the egg from the cilia towards the fallopian tube. That the fertilization occurs and result in the formation of zygote. Okay, so usually these are basically, they are non-motile. They don't have motility. Why? Because they don't have locomotory organelle. So that's why they are non-motile in that appearance. Okay, so now we have discussed about what is gametogenesis. That is the process of formation of gametes is called as what? Gametogenesis. So usually how many types of gametes are forming here? Male gametes and female gametes. If both the gametes are similar in their appearance, exactly similar to one another, then such gametes are said to be homogametes. Example, algal members, chlamydomonas, some of the algal members. Okay. Next, so if the produced gametes are different in their appearance, then such gametes are said to be what? Heterogametes. The meaning of hetero is here different. So what is different here? Appearance of gametes is different. One female gamete is larger in size with non-motile, and one male gamete is smaller in size with motile. Okay, so the female gamete is said to be egg or ovum, and male gamete is called as antherozoite or sperm. So is that clear? Shall we go for the next one? Then what we have to discuss in this is the how the organisms are producing. Whether they have a single parent body has the capacity to produce both the gametes or different gametes. Different individuals will produce the different gametes. So that is going to discuss in the sexuality in plants and sexuality in animals. Okay, so let's discuss with the sexuality in plants. How plants are producing these gametes, whether in the same body or in the different plant body. Okay. Sexuality in plants. So usually plants have both the types. Means in some of the plants, the single plant is having both the reproductive organs which produce both the gametes from a same reproductive part. Okay, so such condition is said to be what? Bisexual. Means what? Bisexual. Next, in some of the plants, so gametes are produced in the separate individuals, different individuals. Okay, and such condition is said to be what? Unisexual. Unisexual. Bisexual, both the reproductive parts found in or both the gametes are produced from a same individual. Okay, single plants have both the reproductive unit, male reproductive unit as well as the female reproductive unit. So which is the reproductive unit of the plant? Flower. If the flower possesses both the reproductive units in the same flower, then it is said to be bisexual flower. Okay. So if the flower possesses either male reproductive unit or a female unit, any one of them, then the flower is said to be what? Unisexual flower. Similarly, we are going to answer this for the plant. Okay. If a plant produces both the gametes, then its condition is said to be bisexual condition. Okay. So if it is producing either any one of the gametes, then the condition is said to be what? Unisexual. A condition enanta kariತೀವಿ ನಾವು unisexual. In case of the lower plants such as multicellular algae, they don't have true plant body. Okay, so multicellular or the lower plants alli true plant body irodilla, plant like structures. So such plant body like structures we are calling as what? Thallophytes. Thallus. Okay, so if the same plant possessing both the reproductive unit, then such thallus is said to be what? Homothallus. Homo means same. Both are found in the same condition. Okay, so usually bisexual condition is also referred in one more name, that is homothallus in case of lower plants. Okay, such as multicellular algae, bryophytes in this. Okay, so this bisexual condition, homothallus, and it is also called as one more name, that is monoecious. Mono means again here what? Same. Monoecious. Okay, bisexual condition, homothallus, monoecious. Both are same, but for different things. Okay, bisexual means both the gametes are found and produced in the same plant, either a same plant or a same plant. Okay, so homothallus is regarding with the lower plants, such as what? Multicellular algae, bryophytes, and all. So they don't have true plant body. Hence, the primitive plant body is said to be thallus there. If the single thallus consisting of both the reproductive units, then it is said to be homothallus. Okay, so monoecious means it is regarding with the plant. Okay, the plant which possess both the reproductive units. Like, okay, we will come this way. Next, if the thallus consisting of any one of the reproductive units, then it is said to be heterothallus or heterothallic. Both are one and the same. Thallus, plant body. Condition is said to be thallic, heterothallic or homothallic, like this. So you should know the meaning of thallus here. What does thallus mean? Primitive plant body of a lower plant is called as what? Thallus, which don't have true roots, stem and leaves. Okay, so such primitive plant body of a lower plant is called as what? Thallus. If this thallus possesses both the reproductive units, then it is said to be homothallus. Okay, so suppose next, if the reproductive units are found on the different individuals, then it is said to be what? Heterothallic. Is that clear? Meaning of homothallic and heterothallic. So unisexual condition is said to be concerned with heterothallic, and we will call it in one more name, that is dioecious. What? Dioecious. Monoecious, dioecious. Okay. So this is about the different terminologies what we are using to represent whether the single plant body produces both the gametes or not. Okay. Next. So the plants are also classified as monoecious plants and dioecious plants. How? If a single plant possesses both the male and female flower in unisexual condition, so the flower, if it consisting of any one of the reproductive, either androecium part or gynoecium part. So you people know what is androecium and gynoecium. What is androecium? Male reproductive unit of the flower is said to be androecium, and female reproductive part of the flower is said to be what? Gynoecium. Isn't it? Okay. So if any unisexual, both the unisexual flower found on the same plant, if both the reproductive flowers, unisexual flowers found on the same plant, okay, then the condition is said to be monoecious plant. Clear? Monoecious plant. Okay. So here the unisexual flowers are of two types, I have told you. Which are those? The male reproductive part containing flowers, or said to be staminate flowers. Staminate flowers. Whereas female reproductive unit containing flowers are said to be pistillate flowers. Pistillate flowers. So unisexual flowers are of two types: staminate flowers, pistillate flowers. Name only indicates the definition here, no need of getting confusion. What staminate means what? The flower which consisting of stamen. Staminate means what? Stamen. So what is stamen? Male reproductive unit of the flower. So like this, you have to remember the definition. Pistillate means the flower which consisting of pistil. So what is the meaning of pistil here? Female reproductive unit of the flower. Okay, so like this, if both staminate flower and pistillate flower found on the same plant or same tree, then the condition is said to be monoecious. Okay, if suppose they found on the different plant, staminate flower on one plant, pistillate flower on the another plant, then the condition is said to be dioecious. Dioecious. So example for monoecious plants, what they have given in the textbook is cucurbita. Cucurbita. Okay, coconut and cucurbita is the example for monoecious. Whereas dioecious plant, date palm. Date palm or the example for dioecious condition. And even papaya is also very best example for dioecious plant. Means male flowers are produced in one plant, female flowers are produced in another plant. Okay. So this is about the plants depending upon the presence of unisexual flower, whether both the unisexual flower are found on the same plant or on the different plant. Here, see, bisexual, homothallous, monoecious, all will come with under the same name. Okay, but it is terminating for different things. Here it is for lower plants. Here it is for the plants which possessing the both the reproductive part or not, based on that. Okay, or both the unisexual flowers or not. Whereas unisexual, heterothallic and dioecious conditions all gives the same name. Is that clear? So this is about the functionality in plants. Usually the plants will either have both the conditions, bisexual condition or unisexual condition. So what is the meaning of bisexual here? Name only indicates. Bi means what? Two. Okay. So both the sex organs or gametes produced from the same plant. Okay. Unisexual means both the gametes are produced on the different plant. Why? Because they are having either any one of the reproductive unit, either male reproductive unit or female reproductive unit. Okay. Next, unisexual condition in case of lower plants such as multicellular algae and bryophytes, it is said to be homothallic. Why? Because what is the meaning of thallic here? Thallus, plant body is called as thallus. If the thallus is having both the reproductive part and the single thallus, then the condition is said to be homothallic. Okay. So next, heterothallic. If suppose the thallus is having either a male reproductive part or a female reproductive part, then the condition is said to be what? Heterothallic. Is that clear? Heterothallic. Okay. So the condition is similar to that monoecious. Mono means same plant body having both the reproductive units. Dioecious means different. Okay. So reproductive units are found on the different plants. Like, okay. Next, depending upon the same condition, we are going to classify the plants in another way, whether they possess both the unisexual flower on the same plant or not. If the plant possesses both the unisexual flower, that is staminate and pistillate flower, then it is said to be, condition is said to be monoecious. Example, coconut, cucurbita. Okay. So this one, if staminate flower found on the different plant, pistillate flower found on the different plant, then the condition is said to be what? Dioecious. Di means two sex organs or reproductive unit found on the different plants. Like this, the meaning will come. Okay, which is the best example for dioecious plants was given in the textbook? Date palms and papaya. Is that clear? Okay, so here you will come across with so many definitions today. What is gametogenesis? Very first. And then male gametes. What is male gamete? What is female gamete? What are homogametes? What are heterogametes? Example. And then next, bisexual condition, unisexual condition, homothallus, heterothallus, monoecious, dioecious, and then staminate flower, pistillate. Yeah, okay. These are all the definitions. What we have to memorize this. Why? Because any of the definition may ask for 1 or 2 marks questions for you. Okay. So what is monoecious condition, or what are monoecious plants? Give example. What are dioecious plants? Give example. What is heterothallic condition? What is homothallic condition? Give example. Like this. Okay. The flowers are also divided into 2 types based on they consisting of either both the sex reproductive unit or not. That is bisexual flower, this unisexual flower. Example for bisexual flower is hibiscus. Okay. Example for unisexual flower is many examples what we can take. So best example is papaya flower or date palm flowers. Anyone we can take, isn't it? Oh, so this is about the sexuality in plants. So next what we will do, we will go for the sexuality in animals. So how the animals are classified soon. Okay. As such of plants, animals are also classified into 2 conditions, that is bisexual condition and unisexual animals condition. The animals which possess both the reproductive units, so there is male reproductive unit and female reproductive unit in a same animal, and such animals condition are said to be what? Bisexual condition. The animals are called as bisexual animals. Okay. So if suppose the animal possessing either a male reproductive unit or a female reproductive unit, then the condition is said to be unisexual condition, and the animals are called as what? Unisexual animals. Okay. So how many types animals are classified here? Bisexual, unisexual. Meaning of bi means what here? 2. The animal possesses both the reproductive unit. Okay. The animal possesses only a single reproductive unit, either a male reproductive unit or a female reproductive unit. Okay. So bisexual animals are also scientifically called as one more name, that is hermaphrodite. ಏನಂತ ಕರಿತೀವಿ ನಾವು ಇನ್ನೊಂದು ಹೆಸರಲ್ಲಿ bisexual animals ನ they are scientifically termed in one name called as hermaphrodites. The meaning of hermaphrodite is bisexual animals. Okay. Example for bisexual animals, very best example what we can take is earthworm, hydra, So Hydra are one more peculiar animal which exhibit both the type of reproduction, asexual reproduction, sexual reproduction. Asexual reproduction by the formation of bud, external bud, sexual reproduction by the formation of gametes. A single animal has both the reproductive units, male reproductive unit, female reproductive unit, that is male sex organ, female sex organ, and reproduces both sperms and eggs inside a single body. Okay, so fertilization takes place and results in the formation of zygote. Zygote develops into embryo and embryo develops into new hydral form. Okay, so here two body forms are there, that is polyp and medusa. One will be producing by asexual reproduction method and another one is forming by sexual reproduction method. So that's why it exhibits both the reproduction types, both asexual and sexual one. Okay, which one? Hydra. Hydra, earthworm. Earthworm, even though earthworm is also a hermaphrodite, which having the both sex organs, male sex organ and female sex organ in a single animal. But what is the peculiar thing in the earthworm is, even though it is an hermaphrodite, they involve in the exchange of gametes. Okay, they involve in a process called as copulation and they will exchange their sperm. Okay, so that is the peculiar thing regarding the earthworm. But single body has the capacity to produce both the gametes. That's why the name hermaphrodites and bisexual animals. Whereas unisexual animals, example is, many examples we can take human beings or any mammals, okay, and arthropods, cockroach, male cockroaches are different from female cockroaches. We can make out there from the external appearance itself. Okay, so and ascaris, unisexual animal, male ascaris are different from female ascaris. We have certain differentiable characters by looking them morphologically only we can able to differentiate, isn't it? So higher animals exhibit this unisexual. So lower animals up to platyhelminthes, what we will come across is the hermaphrodites. Okay, both the sex organs found in the same animal. But from the ascaris, that is roundworm ascalmenthes, we can able to see this unisexual capacity or unisexuality in animals. Clear? So this is about the sexuality in animals. That is depending upon the production capacity, gametes production capacity, they are divided into bisexual animals and unisexual animals, that is hermaphrodites. Example earthworm, hydra, unisexual animals, cockroaches. Okay, so this is regarding the first sub-event of the pre-fertilization event, that is gametogenesis. Okay, so next what we have to discuss here is second event of the pre-fertilization event, that is gamete transfer. So, which is the second one, gamete transfer. Next event of the pre-fertilization is gamete transfer. So till now we have discussed how the gametes are producing and which or in which body the gametes are producing, how many types of gametes are there, like this. But now in the second event, what we have to discuss is how these gametes are transferring. Since two different gametes are produced in different individuals in some of the animals, especially in unisexual animals as well as in unisexual plants. Isn't it? So then how these gametes are transferred? So we know that in different individuals, in heterogametes, female gametes are non-motile. They can't able to move from one place to another place. But which is the one having the motility here? Male gametes. So male gamete only, it has to move from one place to another place near to the female gametes in order to form the zygote. Okay. So in case of lower plants such as multicellular algae, bryophytes and all, so both the gametes produced are similar in their appearance, whether both motile or non-motile, like this. Okay. So, in such a case, they will use certain medium to move in that. And after that, they will fuse with each other. So, which is acting as a medium for such a lower plants is water, which is a medium, basic medium used for gamete transfer. In case of the lower plants, that is, water is used as a medium. The male gametes are released into the water, female gametes are also released into the water. They will move from each other and finally they will meet and fusion takes. And such a type of water fertilization is also seen in amphibians, that is frog. There also external fertilization takes place where sperms and eggs are released into the water itself. Okay, so like this, water is used as a medium for transferring of the gametes. Okay, so in some of the cases, the motile gametes will move in the search of non-motile female gametes. But the plants, higher plants, here we can make out another special character, that is both the gametes are non-motile. Okay, so egg is also non-motile, male gametes is also non-motile. Then antherozoid is also non. So then, which is this mechanism which is involved here in transferring of male and female gametes? Usually, male gametes will be transferred near to the female gametes. So, at that time, higher plants uses a special mechanism to transfer the pollen grains containing male gametes into the female reproductive part. And that mechanism is called as what? Pollination. The process of transferring of male gametes from male reproductive part to the female reproductive part containing female gametes is called as what? Pollination. Okay, here the female reproductive part, receptive organ, that is stigma, receives the pollen grains containing male gametes. Okay, so this stigma, this is the female reproductive part which consisting of three parts: stigma, style, ovary. This ovary consisting of egg or ovum. Okay. So the pollen grains carrying male gametes will come and fall on this stigma. There, an interaction takes place between pollen and pistil, and it leads to the formation of a tube called as pollen tube. This pollen tube carries the non-motile male gametes from the stigma through the style and finally it enters the ovary containing egg. There, male gametes are released here and male gamete fuses with the egg to form the zygote. So this is a mechanism utilizing by the plants since both the gametes are non-motile here. Okay, so pollination, which includes the formation of pollen tube and transferring of male gametes near to the female gametes. Is that clear? So in case of bisexual condition, so there is same flower producing both male gametes as well as female. So pollination is very easy there, no need of requiring any pollinating agent. Whereas in case of unisexual condition, it requires what? A pollinating agent in order to transfer the pollen grains containing male gametes to the female reproductive part, that is stigma. Okay, so the required unisexual flower requires pollinating agent, whereas bisexual flower, of course, it may occur through pollinating agent, but usually so through the wind itself or through automatic itself, the pollination will take place. Clear? So this is how the pollination takes place in different entities. In case of animals, in hermaphrodites, no need of transferring gametes at all. So single body produces both the gametes and inside the body only the fertilization takes place and development proceeds. Okay. Whereas in the more complex higher organism, unisexual animals, there is a special mechanism so called copulation. Not population, it is copulation. Means the sexual contact between the two different individuals of opposite sex. Through this, the male gametes are transferred into the body of the female, that the male gametes, so-called sperms, will move and search of the female gamete, and it reaches the female gamete. That fertilization takes. These are all the mechanisms what is utilizing by the animals, plants, and lower organisms in order to transfer the gametes into the body of the female. So this is how the produced gametes are transferred. So the pre-fertilization event includes two sub-events, that is gametogenesis and gamete transfer. Gametogenesis includes the formation of gametes. How many types of gametes? Male and female. If both are similar, homogametes, both are different in their appearance, heterogametes. And based upon the production of the gametes, we have discussed the sexuality in plants and sexuality in animals. In that, bisexual condition, homothallic, monoecious, unisexual condition, heterothallic and dioecious. Bisexual flower, unisexual flower, bisexual, and then monoecious plant, dioecious plant, with all relevant examples. Okay, so today's topic is very important because we have come across with so many definitions, very important for 1 and 2 marks. Usually this chapter will not possess 5 mark question, so most of the 1 and 2 mark questions will be coming from this chapter. Okay, so that's why concentrate on the definitions what we are discussing in the class. Next, sexuality animals, bisexual animals, hermaphrodites, unisexual animals, and then gamete transfer. Lower plants utilizes water as the medium of transferring. Plants, since both the gametes are non-motile, they utilize special mechanism called as pollination. Okay, and higher more complex animals uses copulation mechanism in order to transfer the gametes. So, is that clear? I hope. So, what you have to do, you have to write all the definitions by looking the definitions in the textbook. Okay, so textbook definitions are more preferable while writing in the examination because your papers are valued by some other lecturers, not by us. So that's why always write that textbook definition, NCERT textbook definition. Is that clear? Okay. So in the next class, that is in the tomorrow class, we will discuss about the second event of sexual reproduction, that is fertilization event. Okay.